Hello everyone and welcome to Excel for Data Analytics full course by Simplilearn. Microsoft Excel is an incredibly powerful tool for organizing, analyzing and interpreting data. As data analytics becomes more increasingly important for business decisions, mastering Excel is essential for creating impactful reports and dashboards. So in this course, we'll begin with an overview of Microsoft Excel and its core features. You'll learn how to use Microsoft Power Query for easy data transformation and discover how Copilot in Excel can help you with AI-driven insights. We'll also cover the 8 key Excel formulas to streamline your workflow and dive into creating dashboards using ChatGPT. Additionally, we'll also explore database management system and clarify differences between data science and data analytics. So whether you're new to data analytics or looking to level up your skills, this course has everything you need. Also, if you're interested in a professional certificate course in data analytics, begin your learning journey with Simplilearn and IIT Kanpur Data Analytics full course. Explore our learning management system, track your progress and meet completion requirements. Learn to understand data and enhance your analytical skills through live sessions with industry experts. Hands-on lab and masterclasses by IIT Kanpur faculty. You can check out the link mentioned in the description box and in the pinned comment.
Companies around the world are generating vast volumes of data every hour. This data could be in the form of log files, web server and transactional data, as well as various customer-related data. Also, data is being generated at a rapid rate from social media websites and applications such as Facebook, Instagram, Twitter, and WhatsApp. Companies want to use this data to derive value out of it and make business decisions. That's where data analytics comes into use. Data analytics is the process of exploring and analyzing large data sets to find hidden patterns, unseen trends, discover correlations, and valuable insights to make business predictions. Data analytics improves the speed and efficiency of your business. A few years ago, a business would have gathered information manually, performed statistical and complex analytics, and unearthed information that could be used for future decisions. But today, that business can identify insights on the fly for immediate decisions. Most organizations have big data, and many understand the need to harness that data and extract value out of it. So, they use a lot of modern tools and technologies to perform data analytics. Some of the tools I will discuss in detail later in this tutorial.
So what does data analysts do? On a huge dataset, data analysts gather, analyze, and run statistical studies to glean insights and spot trends. They use various methods and tools to transform complicated data into useful insights. They therefore provide insightful data that enables businesses to make informed decisions, and this is the answer of question what data analysts do. So moving forward, let's jump into roles and responsibilities of a data analyst. The roles and responsibilities of a data analyst often consist of the following. The first one is create and manage databases and data system, fixing coding mistakes and other data related problems as necessary. The second one is using both primary and secondary sources for data mining. The third one is rearranging data in a way that both individuals and machine can understand. The fourth one is create documentation that clarifies the data analyst process for stakeholder. So now let's jump into how to become a data analyst with no experience, steps and strategies. So becoming a data analyst without prior experience can be challenging but achievable goal. So here is a detailed guide on how to break into the field of data analysis from scratch. So the first one is master the basics. Data analysts need a mix of technical and soft skills. Start by learning the basics of statistics and mathematics. So key topics are descriptive statistics. Learn measures of central tendency, mean, median, mode, measures of variability, range, variance, and standard deviation, and data distribution, like normal distribution and skewness and kurtosis. The second is inferential stat. Understanding hypothesis testing, confidence intervals, p-values, and statistical significance. The third one is probability theory. Basic probability concept, conditional probability, and Bayes theorems, and many more. The fourth point is linear algebra and calculus. Fundamental concept that underpin many statistical algorithms. So you guys can learn these topics from our Simplilearn's YouTube channel where each topic is explained in depth by our experts. The second point is programming languages and Python. In Python, learn the basic syntax, data types, and control structures like loops and condition. The second one is libraries for data analysis like NumPy, Pandas, and Matplotlib for data manipulation and visualization. The third one is library for statistical analysis like SciPy and stat models for performing statistical tests and modeling. And in R, like basic syntax like data types and structures. Data manipulation like dplyr, tidYR. The third point is statistical analysis, base R function, and package like ggplot2 for data visualization. So you guys can learn these topics from our Simplilearn YouTube channel where each topic is explained in depth by our expert. The third point is data visualization and reporting. So in this, we have first Tableau. Creating and customizing various charts and types like bar charts, line graphs, scatter plots. Second is building interactive dashboards and stories. The third one is connecting to different data sources and data blending. The second one, we have Power BI. Data modeling and creating relationship between data sets. The second point is designing reports with visuals, filters, and slicers. The third point is using DAX, data analysis expressions, for advanced calculation. In this category, third, we have Excel. So in this, you can learn advanced formulas like VLOOKUP, HLOOKUP, index, match, and arrays formulas. The second is pivot tables, summarizing, analyzing, and visualizing data. The third is data visualization, creating and formatting charts, sparklines, and conditional formatting. So you guys can learn these topics from our Simplilearn YouTube channel where each topic is explained in depth by our expert, or you can go through their official document websites. In Master the Basics, the last point is SQL database and the key concept. The key concept are basic SQL commands, select, from, where, join, group by, having, or order by. Second is database design, understanding tables, relationships, and normalization. The third is advanced SQL, subqueries, window function, and common table expression, CTEs. The fourth one is database management, connecting to a database, writing optimized queries, and understanding indexes. So you guys can learn these topics from our Simplilearn YouTube channel where we have SQL playlists covering each topic that is explained in depth by our expert. The second point is work on your personal project. Applying your new skills to real world problems is a great way to gain experience. So here are some projects ideas to help you get started. The first one is personal project, public data analysis. Choose a public data set that interests you and perform a comprehensive analysis. For example, analyzing COVID-19 trends over time, predicting house prices, or studying climate change impacts. The second is Kaggle competition. Kaggle is a fantastic platform where you can participate in data science competition. These competitions provide real-world data and problems to solve. For example, predicting customer churn, classifying images, or creating models to improve sales forecasting. The third one is build a dashboard. Create an interactive dashboard using tools like Tableau or Power BI to visualize data insights. For example, a dashboard tracking global financial market or visualizing crime rates in different cities. The third point is get certified. While certification won't replace real-world experience, they can be valuable additional to your resume. So there are numerous data analyst certifications available online, such as the Google Data Analytics Certificate, the Data Analyst Program by Simplilearn. This data analyst course by Simplilearn in collaboration with IBM will transform you into a data analytics expert. In this course, you will learn the latest analytics tools and techniques, how to work with SQL, the languages of R and Python, the art of creating data visualization, and how to apply stat and predictive analytics in the business environment. These certifications not only provide you with the solid foundation, but also show potential employers your commitment to learning and growing in the field. The fourth point is build a portfolio. One of the best way to showcase your skills to potential employers is by building a portfolio. This can include personal projects, data analysis on real-world dataset, or even Kaggle competition. The key here is to demonstrate your ability to apply what you have learned to real-world problems. Don't worry if you don't have access to fancy dataset or tools. There are plenty of publicly available dataset on sites like Kaggle or even government website. You guys can make a portfolio like this. So this is an example of one portfolio. So you can distribute your projects like this, or you can take help from this. Okay. The next point is networking and mentorship. Connect with professionals in the field through LinkedIn, local meetups, or professional association. Look for a mentor who can provide guidance, feedback on your projects, and potentially help you with the job referrals. Networking can be invaluable in learning about unadvertised job openings or internship. The next point is internship. Apply for entry-level position or internship. Look for job titles like junior data analyst, data technicians, or analytics assistant. Look for opportunities in local community, reach out to startups or non-profits, or even consider offering your services for free initially. Even customer service or administrator roles that involves data entry or reporting can serve as stepping stones, giving you practical experience with data. The seventh point is prepare for interviews. Be ready to discuss your projects, how you approach problems, and what you have learned. You should also be prepared for technical interviews that may test your knowledge of stat, programming, and data analysis techniques. You can refer to Simplilearn's video on data analysis interview question and answer on YouTube. So to sum it up, master the basics, build a portfolio, get certified, get experience through internship and freelancing, network like crazy, and never stop learning. And most importantly, believe in yourself and your abilities.
Now, let's discuss the various steps involved in the data analytics process. As you can see on the screen, there are 5 process steps. Now let me make you understand each of this one by one. So the first step is to understand the problem. Before starting with the analysis, you need to understand the business problem and define your goals. Asking questions at the outlet is vital because this would address issues such as how can we reduce production costs without sacrificing quality? What are some of the ways to increase sales opportunities with our current resources? Do customers view your brand in a favorable way? Answers to these questions will help you build a clear roadmap with lucrative solutions. Also, try to find out the key performance indicators and consider the matrix to track along the way. The second step in the process is data collection. After you have finalized your goals, it's time to start looking for your data. Data collection is the process of gathering information on targeted variables identified as data requirements. The emphasis is on ensuring accurate and right data is collected. Data collection starts with primary sources, which are also known as internal sources. This is typically structured data gathered from CRM software, ERP systems, marketing automation tools, and others. These sources contain information about customers, finances, gaps in sales, etc. Under external sources, you have both structured and unstructured data. So, if you are looking to perform a sentiment analysis towards your brand, you would gather data from various review websites or social media apps. The next step is to clean the data. The data which is collected from various sources is highly likely to contain incomplete, duplicate, and missing values. So, you need to clean these unwanted redundant data to make it ready for analysis. So to generate accurate results, analytics professionals must identify duplicate and anomalous data and other inconsistencies that could skew the analysis. According to a report, 60% of data scientists say most of the time is spent cleaning the data, while 57% of data scientists say it's their least enjoyable task. Now the fourth step in the process is data exploration and analysis. Once data is cleaned and ready, you can go ahead and explore the data using data visualization and business intelligence tools. You can also use various data mining and predictive modeling techniques to analyze the data and build models. You can use different supervised and unsupervised algorithms such as linear regression, logistic regression, decision tree, KNN, k-means clustering, and lots more to build prediction models for making business decisions. And the final step is to interpret the results. This part is important because it's how a business will gain actual value from the previous 4 steps. Interpreting the results will help you find unseen trends and patterns in the data and gain insights. You can have a validation check if the results are answering your questions. These results can be shown to your clients and stakeholders for better understanding and business collaboration. Now that we have looked at the various steps involved in data analytics, let's now see the different tools that can be used to perform the above steps.
Hey everyone, welcome to this video by Simplilearn. Today I've got a question for you. What's the difference between a data analyst and a data scientist? Well, in this video, we will give you the answers. From healthcare to ride-hailing apps and online shopping to streaming services. Big data has transformed applications and how we interact with them. Two key fields underpinning this transformation are data science and data analytics. Now, I know these concepts can be a bit tricky to grasp at first, so let's use a fun analogy to make it more clearer. Imagine for a moment that a business is like a human body. In this scenario, a data scientist would be a general practitioner, while a data analyst would be more like a specialist consultant. Both play crucial roles in keeping the body, or in our case, the business, healthy and functioning well. Think of the data scientist as the GP who looks at the entire body. They need to understand how all the different parts work together and how external factors affect overall health. This big picture views allows them to ask important questions about the body's well-being that others might miss. On the other hand, the data analyst is like a specialist focusing on a specific part of the body, let's say the heart or the brain. They dive deep into the area of expertise, answering specific questions and solving particular problems. For example, if there's an issue with the heart, the data analyst or heart specialist would be the go-to expert. But remember, while the specialist focuses on the area, the GP will still keep an eye on the overall health. They work together, each bringing their unique skills and keeping the body or the business in top shape. So in a nutshell, data scientists and data analysts both play vital roles in keeping a business healthy. The data scientist looks at the bigger picture while the data analyst dives deep into specific areas. Throughout this video, we will explore these roles in a more detail, looking at the specific tasks, skills they need, and how they contribute to the data-driven world we live in. So let's discuss the differences between data analytics and data science. Imagine a thriving social media app with millions of users sharing photos, videos, and messages every day. At this company, we have two data heroes, Alex, the data analyst, and Chris, the data scientist. They both work with data, but their roles are quite different. Alex is like the app's detective. Their job is to figure out on how many people are using the app right now. Alex looks at two things. Firstly, which features are most popular, when do most people log in, and how long do users spend on this app. Alex digs through user activity logs, engagement metrics, and customer feedback to answer specific questions. This helps the team make the app better today. That's what data analysts do. They solve current puzzles using existing information. Now, Chris, they're more like the app's fortune teller and inventor rolled into one. Chris takes all the data Alex collects, put a whole lot and more, and tries to predict the future. They ask big questions like, what new features will users want next year? How can we use AI to make the app more fun? What if we could predict trending topics before they explode? Chris uses complex mathematics, machine learning, and computer programming to spot trends and create new ideas. That's what data scientists do. They use data to predict the future and innovate. Both Alex and Chris are crucial for the app's success. Alex helps the app run smoothly and keeps user happy day to day. Chris helps the company plan for the future and stay ahead in the competitive tech world. Let's look at the key definitions of how they differ from each other. Comparing data science versus data analytics. Data science and data analytics, while related, serve distinct purposes. Data science is a broad multidisciplinary field encompassing areas like machine learning, artificial intelligence, and computer science. It involves researching vast amounts of unstructured data to ask and answer strategic long-term questions. Data scientists often build complex models and algorithms focusing on innovation and strategic decision-making, and they usually hold senior roles. In contrast, data analytics is a specialized discipline with data science that focuses on analyzing existing structured data to answer specific and immediate questions. Data analysts interpret data, identify trends, and provide actionable insights using tools like SQL and Excel. They often work in specific departments like marketing and sales. While their skill set is narrower than the data scientists, they have a deep understanding of their particular business's area. Essentially, data scientists create a big picture framework, while data analysts zoom in specific elements within that framework to optimize current operation. Let's talk about the skill set comparison. Skills for data analyst. proficiency in business intelligence tools, strong statistical analytical skills, intermediate programming skills in SQL and Python, expertise in data visualization tools like Tableau and Power BI. Next, let's discuss the skills for data scientist. To be a data scientist, you must know advanced knowledge of machine learning and AI. You must have experience with big data platforms such as Hadoop and Apache Spark, strong programming skills in Python and R, proficiency in predictive modeling and data mining techniques. Let's discuss the workflow comparison. Now, let's compare the workflows of data analyst and data scientist. The workflow of data analysts typically begins with data collection, where they gather data from various sources to ensure they have all the necessary information. Next comes data cleaning, a crucial step where they remove any errors and redundancies from the dataset to ensure accuracy. Following this, they perform data analysis, using statistical methods to interpret the data and uncover patterns and trends. To present their findings effectively, data analysts then engage in data visualization, creating charts and graphs that make complex data more understandable. Finally, they provide actionable insights, offering recommendations that can be implemented immediately to improve business operations. In contrast, the workflow of a data scientist starts with identifying the problem, where they define a strategic question or opportunity that needs to be addressed. Then they proceed with data mining, extracting relevant data from large data sets to gather the information needed for the analysis. Similar to data analysts, data scientists also perform data cleaning to prepare the data for analysis. However, they take it a step further with data exploration, conducting exploratory analysis to understand the depth of data. Next, we have feature engineering, where they create new features from raw data to enhance their models. And then they build predictive models to forecast future outcomes based on the data. Once the models are ready, they deploy the model into production and start generating insights in real time. The final step is their workflow to monitor and iterate, continuously improving the model based on the new data and ensure it remains accurate and effective. Let's discuss the tools and techniques. Let's explore the tools and techniques used by data analysts and data scientists. Data analysts like Alex uses a variety of tools to handle and analyze data efficiently. They often use Excel for data organization and basic analysis due to their accessibility and functionality. For querying databases, SQL is the go-to language, enabling them to extract and manipulate data effectively. To visualize data and create insightful dashboards, Tableau is commonly employed using robust data visualization capabilities. Additionally, Python is used for more advanced data manipulation and analysis, making it a versatile tool in data analyst toolkit. On the other hand, data scientists like Chris rely on slightly different set of tools to handle their more complex tasks. Python is a staple for data manipulation, machine learning, and artificial intelligence thanks to the extensive libraries and frameworks. R is also a key tool particularly for statistical analysis and visualization, providing powerful statistical techniques. For processing large data sets, Hadoop is indispensable. Enabling scalable and distributed computing, Apache Spark is used for large-scale data processing, offering speed and ease of use for big data analytics. Lastly, we have the TensorFlow, which is important for building and deploying machine learning models, making it essential for AI-related tasks. Let's discuss the application comparison. Let's see how the work of data analysts and data scientists relies in real-world scenarios. Data analysts like Alex plays a vital role in understanding user behavior. For example, they analyze which app features are most popular among users, providing insights that can enhance user experience and app's functionality. In the realm of sales, they identify trends and optimize marketing strategies, ensuring that the company targets its audience effectively and maximizes revenue. Moreover, by analyzing customer feedback, data analysts help improve product features, ensuring the company meets customer needs and expectations. Conversely, data scientists like Chris engage in more predictive and innovative application. They use predictive analysis to forecast future trends and behaviors, allowing companies to make informed strategic decisions. For instance, they build recommendation systems that suggest products or contents to users based on their past behavior, enhancing user engagement and satisfaction. Additionally, they develop AI innovations to improve user experience, such as chatbots or personalized user interfaces, leveraging advanced machine learning models to stay ahead in the competitive tech landscape. At last, we will talk about the career path comparison. Finally, let's discuss the career paths and opportunities and salaries for data analysts and data scientists in both the United States and India. A career in data analyst often begins with marketing or finance. Over time, they can transition into senior analyst role to specialize further in business intelligence. There are also opportunities to move into management positions, overseeing data analysis team and driving strategic decisions based on data insights. In United States, the average salary for a data analyst is around $65,000 per year, with senior roles potentially earning up to $90,000 annually. In India, the average salary for a data analyst is approximately 6 lakh per year, with senior roles earning up to 10 lakh rupees annually. In contrast, a career as a data scientist typically requires advanced degrees and specialized training in data science. As they gain experience, they can progress to senior data scientist roles or lead data science teams, taking on more responsibility and tackling complex challenges. Data scientists also have opportunities to work in cutting-edge fields like AI, machine learning, and big data, where they can innovate and contribute to significant technological advancements. In United States, the average salary of a data scientist is approximately $1,20,000 per year, with senior positions often earning up to $1,50,000 annually. In India, the average salary of a data scientist is around 10 lakh rupees per year, with senior roles earning up to 20 lakh rupees annually. In summary, both data science and data analytics are crucial in today's data-driven world. Data scientists focus on the bigger picture and long-term strategy, while data analysts hone in on specific questions and provide actionable insights. Choosing between the two depends on your interests, career goals, and desired salary.
Today, we will learn data analytics with AI. That's it. If these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Let's get started with the main topic of today's session, which is data analytics with AI. So, before proceeding with data analytics with AI, let's understand what exactly is data analytics. So, data analytics is not just a step where you just give your data to AI and it will be done, right? So, it's a stage-by-stage process. Let's understand all the stages, one after the other. Firstly, you might have different sources. So, before we go ahead with the sources, let's understand the situation. You might be dealing with your client. You might be working with a company as a data analyst. So, before you begin with the data analysis, you might have to have a conversation with your client or the company. You might have to go through something called as requirement gathering, right? So requirement gathering will let you know from where exactly you're getting the data. Is it in the form of a PDF? Is it in the form of an Excel spreadsheet? Or is it going to be cloud or anything like that, right? So you'll be understanding what the source exactly is. And followed by that, you will understand what is the request of your client, what he's looking for, what he wants you to give him, right? The insights of the data, which part of the business he wants you to focus on, and which part of the business he wants to improve, right? And followed by that, you will come up with a time span. Within that time span, you need to use that data, build some insights, and give it to the client or your business owner so that he comes up with a business decision, right? So that's the first requirement gathering step. Once you have the source, you come up with the next step of the data analytics, which is cleaning the data and transforming the data. So it's really obvious for any beginner or an expert who is a data analyst. It is cleaning and transformation what makes or what adds value to your data. Once you clean your data and transform it. So what exactly you mean by clean and transform? So let's say you might have some blank entries or might be some wrong data type Or there might be some places where you might have to split the data. For example, if there is a customer and customer ID mixed up together. Let's say customer ID 1345 hyphen the name of the customer, right? You wanted to split the customer ID and split the customer name. Then comes the data split option. Apart from that, if you want to categorize the data into buckets, let's say you might have a column for customer age. There might be customers starting from 10 and all the way end up to 80, right? In those scenarios, you might want to split the data into buckets. Let's say 10 to 20 are teenagers and above 20 to 30 are youth and above 30 to under 50 are or under 60, like let's say like 59 are adults, and after that maybe senior citizens, right? Then you have a smaller window so that you can capture which category of the age group is bringing you the most of the revenue, right? So these are the parts of cleaning the data and transforming the data. And once you're comfortable with it, then you can choose a platform where you want to analyze your data, which can be Tableau, which can be Power BI, ClickView, or Excel, or any of the tools that you might want to prefer. In our scenario, we want to go with AI, right? So AI can be anything. You can go with the Microsoft's Copilot. You can go with the OpenAI's ChatGPT. You can go with Google's Gemini, or any of the AIs which can perform data analytics. There are some AI tools out there which are dedicated for AI data analytics, right? And once you're done with it, and the final stage is analyzing the outcomes and reporting that to your business owner or client. So I hope I made myself clear with the stages of data analytics and reporting. Now let's look at an example to explain this a little better. So I have the dataset in Excel for now. This is our source, the first part of data analytics. Let's expand the columns. So there you go. I said something about data type. So here you can see we have some different data type which we don't want, which is in general. So we will change this data type to short date to make a little more meaning out of it. And after that, here we have customer ID, right? So what we will do is use data split here. Go to text to columns, delimited. Next. So we have other. So here's the preview. So you will be receiving it in this form. And if you want to format the data as you like, you can go ahead. So I'll leave it as general for now and finalize the data type after the split is finished. So what you can do is add a column, new column here, so that you can get an empty column here to split the data. Go to text to columns once again. Select delimited. Select next. And we have the input other. Next and finish. There you go. You have customer ID and you have customer name, the respective customer name here itself. So proceeding ahead, we have quantity, the quantity of product ordered, and we have traffics, leads, orders, and revenue, right? Cost to company and delivery status. So in case if you wanted to kind of calculate profit, what you can do is add a new column, profit, and here you can do a mathematical calculation equals to revenue minus cost to company, and you can extend this particular column all the way to the end so that you have the profit numbers. And here you can also change the data type to currency and go to home, and here the data type from general to currency, and there you go. And if you want it in rupees, you can go with rupees, or if you want it in dollar, you can also have dollars, right? So that's how you do it. I would like to go with dollars, so more, and here go to currency, and in currency symbol I'll go with the dollar. Then okay, there you go. You can quickly save it. If you want to add some borders to the data, you can also do that. There you go. So far so good. So we are now good data. Now comes the next step, which is loading the data and analyzing it, right? So currently we choose the platform as Excel. So you can do this on Excel, Power BI, and ChatGPT as well. So let's go with the first one, which is Excel's AI. So here you can see analyze data, or also people call it the co-pilot of Excel, right? Now you can just click all the data and click on analyze. Basically what you can do is insert and go to the pivot table option, and here you can insert a pivot table, and after that you can find out the requirements what you want, the sales from the central region, south region, and which category of the products have been sold the highest, and what's the highest grossing product, what are the number of leads, and you can estimate the performance of traffic on a month-on-month basis, right? You can do that all, but if you want to reduce the time, basically I would like to tell you, go to that particular part first. Understand manual process, and after that, go to the analyze data option, which is the automated or AI generated report, right? It will now read your data and it will give you some insights from the data given. Right here you can see the cost to company by order status, and here you can see you can set up a pivot table for that, and here you can see you can insert some graphs and charts here, bar graph, and here you have another one. Now you can see that it has all 24 results, all the insights. Now if I can ask, give me a pie chart of sales and category. Here you go. Here you have so basically what Copilot did is it created a pivot table of sales and category, and out of that pivot table it extracted the pie chart and generated one for you. In this way you can create multiple options. Let's say I want to create a line graph month on month. Enter. Now here it again created a pivot table, and here it generated a line graph on month basis and how many number of traffic or how many number of visitors your website has. Right? In this way you can create a long list of all the required charts and graphs for your website and or the client, and create a dashboard out of it, which is completely interactive. Now this was the Excel's AI. Now if we go to another one, which is Power BI, so here you can see a completely prepared dashboard in Power BI, and we can create this once again, or we can at least understand how it was done, right? Now let's get the data from Excel workbook. So my workbook or my data set is somewhere here, sales data. I would like to go with orders data. Only one file is enough for 2024, and your data will be shortly loaded. Select spreadsheet 1 and load the data. Since we already transformed it, there is no need for transforming it once again. So the data is being loaded successfully. It's going to take some time. 2000 rows loaded. Sheet 1. So we are going to work with sheet 1. Now you can select the visualization you want. Like I want to create a line graph here. Repeat. Like I want to create a line graph here. Select. And for this particular line graph, you will have fields, x-axis and y-axis. Now what I'll do is I'll drag and drop date to x-axis field, and traffic to y-axis field. Now here in x-axis, I would eliminate year, I would eliminate quarter, I will eliminate date. I just want month on month, right? Here you have a clear month on month traffic line graph. Right now, let's quickly delete it. We don't want this now. And remove it. Now, what if I tell you there is an option where you can just double click and or right click and you will get an option. Here you can query, right? You can just write down the query, line graph, type of graph you require, traffic, write the spellings correctly, month on month. And enter, you will get the graph you are looking for. There you go. Right? So apart from this, let's put the month on month graph here. Apart from this, let's double click once again and category wise sales. Category sale, pie chart. There you go. And now region wise, double click once again. Region wise sales, bar graph. Select the first one and there you go. I think there is a small mistake in the selection spelling. Select the first one once again and there you go. You will have a bar graph in region wise basis. Or we can also go with similarly we can also go with the map chart for states and revenue. Select the first option and you will have all the American states and their revenue details here. Right? So in such way, you can use the artificial intelligence of Power BI and create a completely interactive graph just like this one. So if I select the standard shipment mode, what are the sales reports? And if I select the entire shipment modes, what are the reports? And if I select the home category, what are the sales reports and which part of the nation and and what are the sales and order per month, traffic and everything details here, right? In one go. It is completely interactive. Now, let's move on to the next part of our session for today. So we will be using ChatGPT for our data analytics. So here you go. Now, let's load the data. Before that, let's write a prompt. Some data on sales. Or sales report. Visualization. And now load the data. Upload from computer. And we have the sales data here. The orders data. Select the orders data file and open. The data will be loaded shortly. And since it's loaded, you can just push the command or prompt. It'll first review the contents and understand what exactly is present in your content and the data type along with the data type, right? It has 2000 entries, 17 columns. Here's the brief overview of all the columns. So it's asking you, would you like an overall summary or a specific aspect? So let's go with the specific aspect instead of overall summary. I want region-wise sales as a bar graph. Okay, we didn't have a column as bar sales. It's in turn taking revenue. Yes, there you go. Sales revenue by region as a bar graph. Now, pie chart for category revenue. Okay, so there is some limit for analysis. Okay, that's not a problem. We can change the account and try to do it once again, or I should have chosen the overall summary, right? But if you go to the ChatGPT Plus edition, you can get that. Let's try the Plus edition once. So we are on the Plus edition now. So it generated some visualizations, which is completely downloadable here. You can go with that as well. So the prompt is still running. Let's wait for a couple of more minutes and see what exactly ChatGPT is up to. So here we have a profit by category, which was our second request, which did not get successfully authorized because we didn't have a +1. So now we can see revenue versus cost to company in top 10 products. So which are the top 10 products which are giving the maximum revenue? And here is a detailed report. And if you would like to continue with a few more reports like we did before in Power BI and Excel, like traffic versus month on month is a line graph. Let's try that. There you go. So we have a line graph of traffic on a month-on-month basis. So that's how you can conduct some data analytics using different AIs on different platforms. So there are many number of platforms: Tableau, Power BI, ClickView, Excel, SQL, ChatGPT, Gemini, and a few more dedicated artificial intelligence tools which are for AI data analytics. And that brings us to the next part of data analytics with AI. So how does data analytics and AI work? So first, basically, once you load the data, AI will start preparing and processing your data, right? So the transformations, what you do, are also can be possible in AI as well. If you request AI to do the transformations, it can do itself. But I would recommend you perform the transformations because you know what the exact requirements are. Once your data is completely transformed, you can load it and get the reports. The next part of it is pattern recognition. As you have already seen, ChatGPT recognizes each and every aspect of the data, from the data type to the minute details like currency and everything. It understands the data first, and then it will request you. It will ask you if you want a complete summary or if you are looking for a particular aspect, right? Machine learning algorithms can identify patterns, trends, and relationships that may not be apparent to human analysts. And there is a possibility that ChatGPT can even identify a few more insights that you never expected to have, right? And moving on to the next part, predictive analytics. AI can also perform some predictive analytics and give you the forecast of what exactly is going to happen in the upcoming future in your business. That may or may not happen. If you find something is about to go down, you can prevent it by taking some predictive steps or measurable steps which can avoid that loss, right? And automated insights and reports. You can also request ChatGPT, right? In Excel, there is something called as Power Query. It acts like a macro or Excel VBA where it stores each and every transformation step you apply. In a similar way, each and every transformation or step that you apply to modify or try to add value to your data and teach that to your AI so that it can also understand that particular automated transformation steps and report to you on a month-on-month basis, right? So this will stop your month-on-month activity of cleaning your data, transforming your data, loading your data, analyzing, extracting some insights, and then creating a strategy. So all these steps will be eliminated because ChatGPT or any other AI will take care of it, and you can focus on implementing some business strategies. And we have decision making. So AI can also help you with some critical business strategies and also help you in decision making. AI algorithms can optimize complex processes and decision making by evaluating multiple variables and multiple scenarios. Now, last but not least, continuous learning. So AI is capable to adapt and learn new things in your business, like how it processes, how it functions, and what's the data source, and most of the aspects in which are involved in business and data analytics. AI systems have the ability to continuously learn and adapt based on the new data and feedback.
I wondered what those people with fancy charts on their computers are doing. They are probably business analysts. So, what's a business analyst? Think of them as the Sherlock Holmes of the business world. They look at lots of information and figure out how to make companies run better. And guess what? It's a pretty cool job right now. Lots of companies are trying to hire these folks. Want to know how much they make? On average, about $85,000 per year. Some of them even make over $120,000. Not bad, right? But here's the thing, to be really good at this job, you need to know some special words. It's like learning the secret code of business. And in today's video, we are going to look at the 10 important words every business analyst should know. And by the time we are done, you will be talking like a pro. So let's start with a little story. Meet John. John works at a company and is always overwhelmed by all the data terms his colleagues use during meetings. So words like KPIs, data warehouse, and analytics were thrown around, and John often felt lost. He knew understanding these terms was crucial for his career growth, so he decided to dive into learning about business intelligence. John started by learning what business intelligence actually means. He discovered that BI involves strategies and technologies that help companies analyze and manage their data. For example, if he worked at Spotify, BI could tell him which songs are getting the most plays, when people listen the most, and even predict the next big hit. This realization made John see how powerful BI could be for making informed business decisions. Alright, so let's dive in and let's understand what business intelligence actually is. Imagine you're running a popular ice cream shop, and business intelligence is like having a super smart helper that tells you everything about your business. Cool, right? So, what exactly is business intelligence? It's all the tricks and tools companies use to understand their data better. It helps them make smart choices based on facts, not just guesses. For example, let's say you use a tool like Power BI in your ice cream shop. It might show you which flavors sell the most on hot days, what time your shop is busiest, and which toppings are most popular with kids. This info helps you make smart decisions like stocking up on popular flavors or hiring extra staff for busy times. Business intelligence is super important because it turns boring numbers into useful information that helps businesses grow and succeed. It's like having X-ray vision for your company. Next, let's talk about data visualization. So data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. For example, a bar chart showing the most popular pizza toppings in a delivery app. This is crucial for presenting data in an easy to understand format. Moving on, we have analytics. So analytics involves the systematic computational analysis of data. For example, using analytics to understand which times of day are busiest for a pizza delivery app. This term is important because it helps in making sense of large amounts of data and aids in decision making. Next up is KPI, that is key performance indicator. So a KPI is a measurable value that demonstrates how effectively a company is achieving key business objectives. For example, tracking the number of pizzas sold each month as a KPI to measure business performance. KPIs are essential for measuring performance and progress towards strategic goals. Now let's discuss data warehouse. So a data warehouse is a centralized repository for storing large volumes of structured data from multiple sources. For example, storing customer data from different gym branches in one place for analysis. It is used for reporting and data analysis and is a core component of business intelligence. Data warehouses are important for consolidating data from different sources and making it available for analysis. Next, we have database. So database is an organized collection of data generally stored and accessed electronically from a computer system. For example, a database storing member records for a gym. Databases are foundational for storing and managing data efficiently and are critical for any business intelligence processes. Moving forward, let's introduce data mining. So data mining is the process of discovering patterns and knowledge from large amounts of data. For example, a gym analyzing member attendance to identify the most popular class times. Data mining is important for extracting useful information from large data sets. Next, let's talk about dashboard. So dashboard is a business intelligence tool that allows users to track key metrics and KPIs. For example, a dashboard for a gym showing daily attendance, most used equipment, and membership growth. It provides a visual representation of data and helps in monitoring performance at a glance. Dashboards are crucial for real-time data monitoring and decision making. Next up is reporting. Reporting refers to the process of organizing data into informational summaries to monitor how different areas of a business are performing. For example, a monthly financial report summarizing income and expenses for a gym. Reports are essential for tracking progress, identifying trends, and making informed decisions. Finally, let's discuss SQL, that is Structured Query Language. So SQL is a standard programming language for managing and manipulating databases. For example, writing an SQL query to retrieve all gym members who joined last month. It is used to query, insert, update, and modify data. SQL is fundamental for anyone working with databases and business intelligence tools. Remember, whether you are running a multi-million-dollar corporation or a neighborhood lemonade stand, these BI tools and concepts can help you make smarter decisions and grow your business. They turn raw data into valuable insights, helping you understand your customer better, optimize your operations, and stay ahead of the competition. So with that guys, we have come to the end of this session. I hope this video has helped demystify some key business intelligence terms for you. If you found this video helpful, don't forget to give it a thumbs up and subscribe to our channel for more business and tech insights. If you have questions about BI or want to share your opinion, you can comment down in the comment section below.
Who is a data analyst? A data analyst collects, analyzes, and interprets data. A data analyst will convert raw data into useful information. Data analysts are in high demand because every industry uses data analysis. Work of a data analyst. As a data analyst, you will work closely with the raw data and generate valuable insights to help companies decide their future goal. If you like thinking out of the box, you are the perfect fit for this domain. Data analysts help maximize output when it comes to generating revenue, working closely with both business and data. Nevertheless, this field boasts handsome salaries for all levels of expertise. Can you become a data analyst without prior experience? Yes, anyone can become a data analyst if they enjoy solving real-world problems, have a strong background in statistics, and have a creative mind. If you feel you don't have it, you can definitely develop it. So let us know the skills in detail. What are the basic skill sets required for a data analyst? Data analyst must know basic mathematics and statistics, programming skills, machine learning, and also data visualizations tools. So let us know what are the basics that you need to learn as a data analyst. Mathematics. It is always better to know basic mathematics like linear algebra and probability fundamentals. Linear algebra is used in data pre-processing and transformation, which is the critical process of every data analyst. Statistics, a branch of mathematics that deals with collection, analysis, presentation, and implementation. Probability. We know that probability is the study of how likely something will happen, which is essential for concluding. Both probability and statistics are the backbones of data analysis. It is feasible to become a data analyst with only a basic understanding of these three areas of mathematics. But in order to remain relevant and grow as a data analyst, one's mathematical knowledge should not be restricted. Compulsorily use some of the tools as a data analyst. What are that? First is Microsoft Excel. It is the most well-known spreadsheet software in the world. It also has computation and graphing features that are excellent for data analysts. No matter your area of expertise or additional software you might want, Excel is a standard in the industry. Its useful built-in features include form design tools and pivot table. It also generates a wide range of additional features that help simplify data manipulation. As a programming language, every data analyst should know Python. It is easy to learn and has a simple syntax. Python is quite adaptable and includes a vast variety of resource libraries that are appropriate for a wide range of diverse data analytics activities. These libraries help in numerical and data computation. The Pandas and NumPy libraries, for instance, are excellent for supporting standard data processing and streamlining highly computational operations. You can also choose between Python or R. R is a well-known open source programming language much like Python. Data visualization tool. As we previously mentioned, data visualization tool is also necessary to become a data analyst. Power BI is a user-friendly interface, makes building interactive visual reports and dashboards simple. Its most vital selling point is its superb data integration. It works flawlessly with cloud sources like Google and Facebook Analytics, as well as text files, SQL servers, and Excel. Tableau is one of the best commercial data analysis tool available. It handles huge amounts of data better than many other BI tools and is effortless. It has a visual drag and drop interface. However, because it has no scripting layer, there is a limit to what Tableau can do. For example, it could be better for pre-processing data or building more complex calculations. You might have heard about MySQL a lot of time. It is a standard language for interacting with databases, and it is very helpful when working with structured data. SQL creates user-friendly dashboards that may present in various data ways since it is so simple to send complex commands to databases and change data in seconds. It has commands like add, edit, delete data. In addition, SQL is an excellent tool for creating data warehouses because of its simplicity, clarity, and interactivity. Overall, I would suggest that to become a data analyst, you should work on programming languages like Python or R plus MySQL to work on databases, adding to that Excel plus visualization tools like Tableau or Power BI. You now know what are the skills are and how it is used. What are you up to in an organization as a data analyst? To create and evaluate the report using automated tools like Tableau or Power BI. To troubleshoot the reporting database environment and reports. Data analyst, you will use statistical method to analyze data sets and spot any valuable trends that may develop over time. Evaluate companies' functional and non-functional requirements. Data analyst assess data warehousing in inspecting and reporting needs. These are all the responsibility of a data analyst in an organization. Coming to companies hiring a data analyst. IBM, Accenture, Capgemini, TCS, Facebook, Amazon, Flipkart, Meta. These are the top companies hiring a data analyst. But data suggests that every small and medium-sized company needs a data analyst. Therefore, demand of a data analyst is in every company. So, there is no need to worry. Job and salary of a data analyst. This is the final part. The salary of a data analyst is high all over the world. When it comes to the USA, the average salary for a data analyst as a beginner is going as high as $70,000 plus per annum. For experienced professional, it is going as high as $120,000 per annum. In India, for a fresher, it is going as high as 8 lakh per annum, and for experienced professionals, it is 20 lakh plus per annum. Such is the demand for data analyst. Now that we have covered every important skill, it's time for you to start working on it.
So, sky's the limit on what you use it for. Let's take a look at types of data analytics. And this can be broken up in so many ways, but we're going to start with looking at the most basic questions that you're going to be asking in data analytics. And the first one is you want descriptive analytics. What has happened? Hindsight. How many sales per call ratio coming out of the call center? If we have 500 tourists in a forest and you have a certain temperature, how many fires were started? How many times did the police have to show up to certain houses? All that's descriptive. The next one is predictive. Predictive analytics is what will happen next. We want to predict. This is great if you have an ice cream store and you want to predict how many people to work at the ice cream store on a certain day based on the temperature coming up in the time of the year. And then one of the biggest growing and most important parts of the industry is now prescriptive analytics. And you can think of that as combining the first two. We have descriptive and we have predictive, and then you get prescriptive analytics. How can we make it happen? Foresight. What can we change to make this work better? In all the industries we looked at before, we can start asking questions, especially in city development. There's a good one. if we want to have our city generate more income, and we want that income to be commercial based, what kind of commercial buildings do we need to build in that area that are going to bring people over? Do we need huge warehouse cells, Costco sales buildings, or do we need little mom and pop joints that are going to bring in people from the country to come shop there? Or do you want an industrial setup? What do you need to bring that industry in there? Is there a car industry available in that area? If it's not a car industry, what other industries are in that area? All those things are prescriptive. We're guessing. We're guessing what can we do to fix it? What can we do to fix crime in an area with education? What kind of education are we going to use to help people understand what's going on so that we lower the rate of crime and we help our communities grow better? That's all prescriptive. It's all guessing. We want foresight into how can we make it happen? How can we make this better? And we really can't not go into enough detail on these three, because a lot of people stumble on this when they come in and are doing analytics. Whether you're the manager, shareholder, or the data scientist coming in, you really need to understand the descriptive analytics, where you're studying the total units of furniture sold and the profit that was made in the past. Here we go into predictive analytics, predicting the total units that would sell and the profit we can expect in the future, gear up for how many employees we need, how much money we're going to make, and prescriptive analytics, finding ways to improve the sales and the profit so we can sell maybe a different kind of furniture. We're going to guess at what the area is looking for and how that marketing is going to change.
Hello everyone, we welcome you all to this video by Simplilearn. In today's session, we will learn a really interesting topic, that is the top 10 skills to become a data analyst in 2022. In today's digital world, data is being generated by companies and individuals every second, so the role of a data analyst holds supreme importance. So if you're looking for a career in data analytics, this video will help you learn what a data analyst does and the various skills you need to possess to become a data analyst in 2022. Before we get started, make sure you subscribe to the Simplilearn channel and hit the bell icon to never miss an update from us. Let's look at the agenda for this video. First, we will understand who a data analyst is. Then we will understand the top 10 data analyst skills for 2022. Moving on, we will look at the salary of a data analyst. And finally, we will look at the companies hiring data analysts. So now let's understand who is a data analyst. A data analyst is a professional who collects business data from various sources, interprets it, and uses various statistical tools and techniques to extract insights and useful information from it. They acquire data from primary or secondary data sources and maintain databases. They also recognize and understand the organization's goal and collaborate with different team members such as programmers, business analysts, and data scientists to build an effective solution to a business problem. Now, with this basic understanding of who a data analyst is, let's learn the top 10 data analyst skills for 2022. At number 1, we have Structured Query Language or SQL. SQL is a top skill that every data analyst should have. Data analysts use SQL commands and functions to store, process, analyze, and manipulate structured data using relational and NoSQL databases. They also build data models and write complex SQL queries and scripts to gather and extract information from several databases and data warehouses. Some of the popular databases a data analyst should be familiar with are Microsoft SQL Server, MySQL, PostgreSQL, and IBM DB2. The second important skill for a data analyst is Microsoft Excel. Microsoft Excel is one of the most popular and oldest spreadsheet applications for creating reports, performing calculations, and analyzing data. Data analysts need to know how to handle tabular data in Excel. So, they should be aware of features like sorting, filtering, conditional formatting, pivot tables, what-if analysis, and functions such as SUMIFS and COUNTIFs. The third crucial data analyst skill for 2022 is data cleaning and wrangling. Usually, the data collected by analysts from various heterogeneous sources is often messy and contains a lot of missing values. So, it is always crucial to clean the data and remove noise, missing, or erroneous elements. It is also important to format data using tools and methods before using it for analysis. They are responsible for data mining as well. The data mined from various sources are organized in order to obtain new information from it. Some of the tools you need to know for data cleaning and wrangling are Excel, Power Query, and OpenRefine. The fourth skill on our list is mathematics and statistics. Data analysts often work on data for higher dimensions that are greater than 3. In order to interpret such data, they need to be good at linear algebra and calculus. They also build predictive models and statistical models such as linear regression, logistic regression, naive Bayes, and k-means clustering. In order to understand the working of these algorithms, they must have knowledge about statistics and probability. Coming to the fifth important skill for a data analyst in 2022, we have programming. Data analysts need to master at least one programming language, preferably Python or R. In order to work with complex business problems, analysts need to write scripts and user-defined functions to automate tedious tasks. Python and R language provide a collection of different libraries and packages such as NumPy, Pandas, dplyr, matplotlib, ggplot, which data analysts can use to discover trends and patterns from complex data sets. After this, we have data visualization as our sixth skill. Another data analyst job role is to visualize large volumes of data and prepare summary reports and dashboards for the leadership team and clients so that they can make timely business decisions. To do this, data analysts use various data visualization tools such as Power BI, Tableau, and QlikView. Using these tools, data analysts can integrate various data sets, apply joint conditions, sort and filter data, as well create different visualizations using charts and graphs. The seventh skill for a data analyst is industry knowledge. Data analysts should have good knowledge and understanding of the industry or domain they are working in. For example, if you're working in a healthcare domain, you need to know how healthcare analytics can be applied to improve patient care. You should have knowledge about the challenges faced in healthcare and how you can leverage data and analytics to solve the issues. Only if you have strong industry knowledge can you try to improve the business. The eighth skill that is important for a data analyst in 2022 is problem solving. A business deals with several problems on a daily basis. Data analysts should be ready to face those challenges. Data analysts are expected to use their problem-solving skills, work with the team, troubleshoot what went wrong, and provide an effective solution via data analysis. A data analyst with good problem-solving skills can help a business identify current and potential issues and determine a viable solution based on the data it collects. The ninth skill on our list is analytical thinking. Data analysts need analytical thinking ability to break down a complex problem into simple components and resolve these components one by one. It is a must-have skill for data analysts. Analytical thinking includes deciding the parameters that need to be considered for defining data sets, analyzing them from different perspectives, and determining variable dependencies. Coming to the 10th skill among the top 10 skills for a data analyst in 2022, we have communication. Data analysts don't just interact with computers and programs, they also interact with team members, stakeholders, and data suppliers. So, good communication skills are essential. Data analysts also present their findings in front of an audience who might not be familiar with the analytical methods and processes, so they need to clearly translate their findings and insights into non-technical terms. So, those were the top 10 skills a data analyst needs to possess in 2022. Do you think we missed out on any skills? Then please put your answers in the comment section below. Now, let's look at the salary of a data analyst. According to Glassdoor, the average annual salary for a data analyst in the United States is $69,517, while in India, you can earn nearly 7 lakh rupees per annum. Finally, let's look at the top companies that are hiring data analysts in 2022. Here we have the consultancy and Big Four giant Deloitte and the pharmaceutical company Cerner Corporation. Then we have the tech giant IBM, retail company Walmart, and the e-commerce leader Amazon. To achieve the goals of data analysis, we use a number of data analysis tools. Companies rely on these tools to gather and transform their data into meaningful insights. So which tool should you choose to analyze your data? Which tool should you learn if you want to make a career in this field? We will answer that in this session. After extensive research, we have come up with these top 10 data analysis tools. Here, we will look at the features of each of these tools and the companies using them. So let's start off. At number 10, we have Microsoft Excel. All of us would have used Microsoft Excel at some point, right? It is easy to use and one of the best tools for data analysis. Developed by Microsoft, Excel is basically a spreadsheet program. Using Excel, you can create grids of numbers, text, and formulae. It is one of the widely used tools, be it in a small or large setup. The interface of Microsoft Excel looks like this. Let's now move on to the features of Excel. Firstly, Excel works with the Windows version of Excel supports programming through Microsoft's Visual Basic for Applications (VBA). Programming with VBA allows spreadsheet manipulation that is difficult with standard spreadsheet techniques. In addition to this, the user can automate tasks such as formatting or data organization in VBA. One of the biggest benefits of Excel is its ability to organize large amounts of data into orderly, logical spreadsheets and charts. By doing so, it's a lot easier to analyze data, especially while creating graphs and other visual data representations. The visualization can be generated from a specified group of cells. Those were few of the features of Microsoft Excel. Let's now have a look at the companies using it. Most of the organizations today use Excel. Few of them that use it for analysis are the UK-based company Ernst & Young. Then we have Urban Pro, Wipro, and Amazon. Moving on to our next data analysis tool, at number 9, we have RapidMiner. A data science software platform, RapidMiner provides an integrated environment for data preparation, analysis, machine learning, and deep learning. It is used in almost every business and commercial sector. RapidMiner also supports all the steps of the machine learning process. Seen on your screens is the interface of RapidMiner. Moving on to the features of RapidMiner. Firstly, it offers the ability to drag and drop. It is very convenient to just drag drop some columns as you are exploring a data set and working on some analysis. RapidMiner allows the usage of any data, and it also gives an opportunity to create models which are used as a basis for decision making and formulation of strategies. It has data exploration features such as graphs, descriptive statistics, and visualization, which allows users to get valuable insights. It also has more than 1,500 operators for every data transformation and analysis task. Let's now have a look at the companies using RapidMiner. We have the Caribbean airline Leeward Islands Air Transport. Next, we have the United Health Group, the American online payment company PayPal, and the Austrian telecom company Mobilcom. So that was all about RapidMiner. Now let's see which tool we have at number 8. We have Talent at number 8. Talent is an open source software platform which offers data integration and management. It specializes in big data integration. Talent is available both in open source and premium versions. It is one of the best tools for cloud computing and big data integration. The interface of Talent is as seen on your screens. Moving on to the features of Talent. Firstly, automation is one of the great boons Talent offers. It even maintains the tasks for the users. This helps with quick deployment and development. It also offers open source tools. Talent lets you download these tools for free. The development costs reduce significantly as the processes gradually speed up. Talent provides a unified platform. It allows you to integrate with many databases, SaaS, and other technologies. With the help of the data integration platform, you can build flat files, relational databases, and cloud apps 10 times faster. Those were the features of Talent. The companies using Talent are Air France, L'Oreal, Capgemini, and the American multinational pizza restaurant chain Domino's. Next on the list at 7 we have KNIME. Constance Information Miner or KNIME is a free and open source data analytics, reporting and integration platform. It can integrate various components for machine learning and data mining through its modular data pipelining concept. KNIME has been used in pharmaceutical research and other areas like CRM customer data analysis, business intelligence, text mining, and financial data analysis. Here is how the interface of KNIME application looks like. Now coming to the KNIME features. KNIME provides an interactive graphical user interface to create visual workflows using the drag and drop feature. Use of JDBC allows assembly of nodes blending different data sources, including pre-processing such as ETL, that is extraction, transformation, loading, for modeling, data analysis, and visualization with minimal programming. It supports multi-threaded in-memory data processing. KNIME allows users to visually create data flows, selectively execute some or all analysis steps, and later inspect the results, models, and interactive views. KNIME Server automates workflow execution and supports team-based collaboration. KNIME integrates various other open source projects such as machine learning algorithms from Beca, H2O, Keras, Spark, and our project. KNIME allows analysis of 300 million custom addresses, 20 million cell images, and 10 million molecular structures. Some of the companies hiring for KNIME are United Health Group, ASML, Fractal Analytics, Atos, and Lego Group. Let's now move on to the next tool. We have SAS at number 6. SAS facilitates analysis, reporting, and predictive modeling with the help of powerful visualizations and dashboards. In SAS, data is extracted and categorized, which helps in identifying and analyzing data patterns. As you can see on your screens, this is how the interface looks like. Moving on to the features of SAS. Using SAS, better analysis of data is achieved by using automatic code generation and SAS SQL. SAS allows you to access through Microsoft Office by letting you create reports using it and by distributing them through it. SAS helps with an easy understanding of complex data and allows you to create interactive dashboards and reports. Let's now have a look at the companies using SAS. We have companies like Genpact, IQVIA, Accenture, and IBM to name a few. That was all about SAS. So for all those who joined in late, let me just quickly repeat our list. At number 10, we have Microsoft Excel. Then at number 9, we have RapidMiner. At number 8, we have Talent. At number 7, we have KNIME. And at number 6, we have SAS. So far, do you all agree with this list? Let us know in the comment section below. Let's now move on to the next 5 tools in our list. So at number 5, we have both R and Python. Yes, we have 2 of them in the 5th position. R is a programming language which is used for analysis as well. It has traditionally been used in academics and research. Python is a high-level programming language which has a Python data analysis library. It is used for everything starting from importing data from Excel spreadsheets to processing them for analysis. This is the interface of R. Next up is the interface of the Python Jupyter Notebook. Let's now move on to the features of both R and Python. When it comes to the availability of R and Python, it is very easy. Both R and Python are completely free, hence it can be used without any license. R used to compute everything in memory and hence the computations were limited, but now it has changed. Both R and Python have options for parallel computations and good data handling capabilities. As mentioned earlier, as both R and Python are open in nature, all the latest features are available without any delay. Moving on to the companies using R, we have Uber, Google, Facebook, to name a few. Python is used by many companies. Again, to name a few, we have Amazon, Google, and the American photo and video sharing social networking service, Instagram. That was all about R and Python. number 4, we have Apache Spark. Apache Spark is an open source engine developed specifically for handling large-scale data processing and analytics. Spark offers the ability to access data in a variety of sources, including Hadoop Distributed File System HDFS, OpenStack Swift, Amazon S3, and Cassandra. It allows you to store and process data in real time across various clusters of computers using simple programming constructs. Apache Spark is designed to accelerate analytics on Hadoop while providing a complete suite of complementary tools that include a fully featured machine learning library, a graph processing engine, and stream processing. So this is how the interface of Apache Spark looks like. Now let's look at the important features of Apache Spark. Spark stores data in the RAM, hence it can access the data quickly and accelerate the speed of analytics. Spark helps to run an application in a Hadoop cluster up to 100 times faster in memory and 10 times faster when running on disk. It supports multiple languages and allows the developers to write applications in Java, Scala, R, or Python. Spark comes up with 80 high-level operators for interactive querying. Spark code for batch processing, join stream against historical data, or run ad hoc queries on stream state. Analytics can be performed better as Spark has a rich set of SQL queries, machine learning algorithms, complex analytics, etc. Apache Spark provides fault tolerance through Spark RDD. Spark resilient distributed data sets are designed to handle the failure of any worker node in the cluster. Thus, it ensures that the loss of data reduces to 0. Conviva, Netflix, IQVIA, Lockheed Martin, and eBay are some of the companies that use Apache Spark on a daily basis. At number 3, we have another important growing data analysis tool, that is ClickView. ClickView software is a product of Qlik for business intelligence and data visualization. ClickView is a business discovery platform that provides self-service BI for all business users and organizations. With ClickView, you can analyze data and use your data discoveries to support decision-making. ClickView is a leading business intelligence and analytics platform in Gartner Magic Quadrant. On the screen, you can see how the interface of ClickView looks like. Now talking about its features. ClickView provides interactive guided analytics with in-memory storage technology. During the process of data discovery and interpretation of collected data, the ClickView software helps the user by suggesting possible interpretations. ClickView uses a new patent in-memory architecture for data storage. All the data from the different sources is loaded in the RAM of the system and it is ready to be retrieved from there. It has the capability of efficient social and mobile data discovery. Social data discovery offers to share individual data insights within groups or out of it. A user can add annotations as an addition to someone else's insights on a particular data report. ClickView supports mobile data discovery within an HTML5-enabled touch feature which lets the user search the data and conduct data discovery interactively and explore other server-based applications. ClickView performs OLAP and ETL features to perform analytical operations, extract data from multiple sources, transform it for usage, and load it to a data warehouse. The companies that can help you start your career in ClickView are Mercedes-Benz, Capgemini, Citibank, Cognizant, and Accenture, to name a few. At number 2, we have Power BI. Power BI is a business analytics solution that lets you visualize your data and share insights across your organization or embed them in your app or website. It can connect to hundreds of data sources and bring your data to life with live dashboards and reports. Power BI is the collective name for a combination of cloud-based apps and services that help organizations collate, manage, and analyze data from a variety of sources through a user-friendly interface. Power BI is built on the foundation of Microsoft Excel and has several components such as Windows desktop application called Power BI Desktop, and online software as a service called Power BI Service, mobile Power BI apps available on Windows phones and tablets, as well as for iOS and Android devices. Here is how the Power BI interface looks like. As you can see, there is a visually interactive sales report with different charts and graphs. Moving on to the features of Power BI, it has an easy drag and drop functionality with features that make data visually appealing. You can create reports without having the knowledge of any programming language. Power BI helps users see not only what's happened in the past and what's happening in the present, but also what might happen in the future. It offers a wide range of detailed and attractive visualizations to create reports and dashboards. You can select several charts and graphs from the visualization pane. Power BI has machine learning capabilities with which it can spot patterns in data and use those patterns to make informed predictions and run what-if scenarios. Power BI supports multiple data sources such as Excel, text CSV, Oracle, SQL Server PDF, and XML files. The platform integrates with other popular business management tools like SharePoint, Office 365, and Dynamics 365, as well as other non-Microsoft products like Spark, Hadoop, Google Analytics, SAP, Salesforce, and MailChimp. Some of the companies using Power BI are Adobe, AXA, Carlsberg, Capgemini, and Nestle. Moving on to the next tool. So any guesses as to what we have at number 1? You can comment in the chat section below. Finally, on the top of the pyramid, we have Tableau. Gartner's Magic Quadrant of 2020 classified Tableau as a leader in business intelligence and data analysis. Tableau Interactive Data Visualization Software Company was founded in Jan 2003 in Mountain View, California. Tableau is a data visualization software that is used for data science and business intelligence. It can create a wide range of different visualization to interactively present the data and showcase insights. The important products of Tableau are Tableau Desktop, Tableau Public, Tableau Server, Tableau Online, and Tableau Reader. This is how the interface of Tableau Desktop looks like. Now, coming to the features of Tableau. Data analysis is very fast with Tableau, and the visualizations created are in the form of dashboards and worksheets. Tableau delivers interactive dashboards that support insights on the fly. It can translate queries to visualizations and import all ranges and sizes of data. Writing simple SQL queries can help join multiple data sets and then build reports out of it. You can create transparent filters, parameters, and highlighters. Tableau allows you to ask questions, spot trends, and identify opportunities. With the help of Tableau Online, you can connect with cloud databases, Amazon Redshift, and Google BigQuery. The companies using Tableau are Deloitte, Adobe, Cisco, LinkedIn, and the American e-commerce giant Amazon, to name a few. And there you go, those are the top 10 data analysis tools.
R is a statistical programming language and environment that integrates statistical computing and graphics. R is powerful and stable software. Python can also be called as a general-purpose programming language for data analysis and scientific computing. Python can be considered as the best player in machine learning. Python is an expressive language with many built-in functions. Both are open source software and platform independent. And they are platform neutral and also compatible with all major operating systems including Unix, Windows, and Mac. Next, we will be covering different parameters. We will be covering learning preferability, mathematical fundamentals, speed of both the languages, visualization and graphics, data handling capacity, demand, community and customer support, employment possibility in both the languages. Let us cover it one by one. First one is learning preferability or ease of learning. Python is renowned for its ease of use. Python's notebooks offer excellent tools for sharing and documentation, despite the fact that there are currently no GUIs for them. Programmers find R as difficult language as a beginner. This implies that the programmers must devote a significant amount of time to learn and comprehending R coding. Coming to mathematical fundamentals required. Coming to Python, understanding descriptive analysis is very important. In layman's terms, descriptive statistics often refers to the process of explaining using certain representative techniques such as charts, tables, Excel files, etc. Python statistics is a built-in library for descriptive statistics. If your data sets are not too big or if you can't rely on importing other libraries, you can use Python. On the other hand, R requires basic statistics. From basic statistics, what I mean is mean, mode, and median are the terms used most frequently in basic statistics. It is referred to as measures of central tendency. Probability statistics plays an important role in handling various types of probability distribution. It includes binomial and normal distribution. Next parameter is speed. Python is an interpreted language with dynamic typing. Python always executes slowly because the code is executed line by line. Compared to MATLAB and Python, R language is significantly slower. R packages are substantially slower than those for other languages. Now that we have covered speed, coming to data visualization and data collection in Python. When selecting data analysis tools, visualization are crucial and Python has some incredible visualization tools. In Python, to large and varied scatter plots using regression lines, we can use ggplot2 and ggplot tools. Compared to raw values, visualized data is easier to comprehend. Therefore, R has many packages that offers sophisticated graphic features. In R, we can use tools like matplotlib, Seaborn, etc. Data handling capability in both Python and R. The new releases in Python have resolved the issue with the Python packages for data analysis. R is useful for analysis because of the abundance of packages, accessibility of the test, and benefit of employing formulas. However, simple data analysis can also be done using the need to install many packages. Crucial part of parameter, that is tools and libraries in Python and R. As a Python developer, one needs to be well versed in the best libraries because Python has a lot of libraries that have many different uses. Libraries like TensorFlow, Scikit-learn, NumPy plays an important role in solving many Python-related problems. Libraries perform a wide variety of tasks in R that are very beneficial for data science operations. Example for that is dplyr, bioconductor, etc. Community and customer support index offered by Python and R. Compared to R, Python has a larger community. For assistance, we can contact www.python.org. For any queries regarding Python and help, you can you can visit support.realpython.com. For any help and queries, R offers you with RStudio community. R provides assistance through its official website. For queries and community-related issues, we can contact www.r-project.org. Next is job opportunities in Python and R. Recent survey from Indeed.com predicts that at least 55,000 Python jobs in the USA with exponential pay rates are available. Big tech companies like Google, Amazon, Twitter, Facebook requires Python developer to handle massive amount of data. Position provided for a Python developer is software engineer, data analyst, data scientist, and many more. Career in R is an excellent job opportunity for you as a beginner. Big tech companies like Google, Twitter, Facebook are using R. Position provided by companies as a R developer is data scientist, data analyst, data visualization analyst, etc. Moving on, let us wrap up an important topic: which language to be used between R and Python. There is no right or wrong way to study both Python or R. Both are in demand skills that will enable you to complete almost any data analytics work you come across. It ultimately depends on your background, interest, and career objectives that which one is better for you. But compared to R, Python is easy to learn. Let's compare its strengths and weaknesses. It is used to handle large amount of data. Python performs non-statistical functions and it is best suitable for programming. However, Python is better when it comes to coding. Whereas R is used in data visualization graphics, R is a widespread language in the statistical community. It is used to accomplish many mathematical tasks. So before concluding the topic, let me answer the query that I have asked regarding R and Python. Do you guys remember the question? The query was, R language is superficially related to which language? So the answer for the question is C language.
Today's topic, which is about how to create Power BI dashboard in a few minutes. Yes, you heard me right. You can create a complete Power BI dashboard, or also known as a report, in just a few clicks and a few minutes. Now, in this particular video, we are minimizing the time in creating dashboard because sometimes data cleaning process, you already know. If you're an expert or if you're a beginner in data analytics, you already know there are steps in data report or a dashboard, right? First, you load the data from a source. It can be cloud, PDF, Excel workbook, CSV, or anything. And after that, you do some data cleaning, right? You split the columns, or you eliminate some blank rows, blank columns, and some irrelevant data which does not fit, or some for more reference on data cleaning, you can also refer to the video which is linked in the description box below. And so, right, that's the process. So basically, you import the data from the source, clean it, transform it, and then load it, and then create a dashboard, right? So in this particular video, we have the completely cleaned data set, which is really available for creating report, which will be also linked in the description box below if you want to follow us along. So with that, let's get started, right? So that's how it goes. Now let's have a look at our data. So our data has some row ID, order ID, order date, ship date. So basically, you can totally understand this particular data set is about sales report, right? Let's say I'm working with XYZ company, which is based on data analytics, and I get an email from my client that he or she wants to know how exactly the sales are performing, in what exact states or countries, and what exact regions, and what category of products or subcategory of products, and what's the sales quantity, order, profit, right? So let's say you have a one category or subcategory or a product which is giving you high number of sales and profit, right? You want to improve more, you can increase the price. Or let's say you have some product which is not performing so well, right? So you can offer some discounts, let's say like 50% off, so that you can move out the product from your store, right? So some basically, if you analyze the data and you come up to a decision where which product is performing in which region or state or country, and which product is performing in not performing in which region, state or country, right? You can come up with a strategy for sales and improve your revenue. So that's the entire process, right? So with that said, so this is the data we have, and let's quickly jump onto Power BI and get going with creating a report or dashboard within a few minutes, right? So here we are on the Power BI desktop. So here, absolutely, you can see you can import data from Excel, you can import data from SQL Server, you can import data from a blank table, or use some sample data. Apart from that, you can also get data from a different sources as well, right? See, we will be trying to do some automation, right? So regarding the automation, we can also go through another video from Simplilearn, which will help you understand how to automate the process of data transformation, cleaning, and uploading. So you can just give the file location here, the folder. So I'm going with the folder here. So it will give me a new window. You can go to browse, and I think I have my folder in downloads and Excel datasets. Excel. I think I'll be having that named as sales report. Yes, just click OK, and you have the sales report here. You can have a quick preview of the data. So here you have the options: combine, load, transform data, right? You can just directly load, because I've said you that this particular data set is completely clean and is ready for reports, right? So you can just select the data you want and just load, right? I'm doing it this way because let's say we have the data here in a form in such a form that the data is from last 3 to 4 years, right? So let me select it this way. So in this case as well, it will take the Excel file, and even if you add some more data to it, it will apply the changes to it, right? So let's say we have the data for the last 4 years, 2020, 2019, 2021, 2, and 3. And since 2024 is not completed yet, we are not taking that data. Let's say we enter into 2025, then the new data for 2024 gets updated and loaded onto the same data table. And you don't have to process the data once again, clean it, transform it, load it. No, that's not gonna happen. You can just load the data, you can just drop the data on the Excel spreadsheet, and your dashboard or report will reflect the new changes automatically just by refreshing your dashboard, right? That's the automation you can do. So what exactly automation is? The process where human effort is not involved, and the computer or your any tool does the job for you is called as automation, which reduces a lot of time of yours, and you can use that valuable time to plan on the strategies to improve your revenue, right? That's the overall motto of data analytics. Now that's the preview of the data. I'm just going to directly load it. I'm not going to transform it because it's completely clean and transformed data and ready for reports. So here you go, and you can close. If there are minute errors, you can just close it. And if you want to check your data, you can go to your data here, and you can have the sample data right here, right? If you check the R date, not ship date, sorry, ship date can enter into 2023 as well, right? So here you have 2020 and the other dates, right? So you will have, okay, let's go to the data filter. So you basically have 4 years, not 2024, right? So that's the way. If you just add the 2024 data, it will automatically reflect in the visualization. Now, all that we need is create a dashboard or report which will help us analyze some data, right? So let's get started. Just double click on the report section, and here you'll have icon or wizard which will ask you what exactly you're looking for. Preparing Q&A. So I want region-wise sales, and I want it in a bar graph. There you go. You have the region-wise sales in bar graph. Press on OK, and you have it. And you can place it somewhere in the corner. Then if you want another one, double click, and you want category-wise category sales And let's take that in pie chart. Category sales pie, and here you have it. Press on agree and accept, and you have it over here. And year-on-year sales in a line graph, sales by date, or sales by date line graph. Here you have it. Accept that, so that you can identify which is the peak performance year or peak performance date for us, which gave us the highest number of sales in a certain region, right? So here we have it. You can place it, you can customize it, right? And now let's go for subcategory. Double click and subcategory. I think we have a hyphen or space there. Sales. The type of chart you want, you can go with the donut one. Select that and agree. So you have a subcategory wise sale, and now let's go with region wise. I mean the country wise, right? So let's go to the data again here. So here we have segment city, state, country. Okay, let's go with country now, right? Country sales map chart. So whenever you have a region or state or a country involved, go with map charts. It's the best way to represent, right? So we have considered European nations over here. So for that reason, we have the European states here. And now we can let's go with the data once again and have a look what else we can do. And shipment mode, right? So you have the shipment mode as well. So you can identify what type of shipment mode customers are majorly preferring. Shipment mode, bar graph, agree. So basically, I think we have 3 types of shipment mode. Let's check the column name of shipment mode properly. Ship mode. It's not shipment mode, it's ship mode, right? So let's type again. Ship mode, bar graph. Okay, shipment mode sales, bar graph. There you go. So agree, accept it. So you have standard shipment is the most preferred one. Now we have this, so let's add some KPIs here. So KPI of sales, you will adjust that, agree, there you go. And let's add a KPI for profit, and you have it, agree. KPI for revenue, double click. Let's check if we have a column called revenue. Quantity, discount, profit, right? So let's go with quantity and discount. So revenue is not added, so it's okay. So you can identify which product or subcategory is highly selling in number of quantities. So you'll have the sum of profit, sum of sales, sum of quantity, and what else we left? The last one, discount and rate. Sales, discount, profit. So let's identify if we have offered any. Okay, so let's add a KPI of rate as well. If we are completely focusing on a single product, a single category, we must be having a KPI for rate as well. Double click somewhere, KPI on rate. There you go. Accept it. And you have the completely formatted dashboard or sales report ready for a meeting. Let's close all these so that we have a better visualization, and you can just go to the slideshare mode or fit to the page mode where you can have it. That's good. So this is how you create a completely fully functional sales report or sales dashboard just within a few clicks and just within a few minutes. Let's say I want the sales report only for central region. Click that and it's completely interactive. And let's say we don't want that, click outside and you will have everything back to the normal, right? And let's say I wanted to focus on a particular category, technology category alone. I have these sales happening and the subcategory of sales and what are the products over here, right? You'll have that, and which is the country happening to ship the most of them, and what's the shipment more preferred by them, and highest performing date or year. So here you can see 2022 June was the highest performance for sales, and the lowest one is somewhere here in March 2020 or something, right? So that's how you can create a fully interactive dashboard or report based on sales data in a few minutes and in a few clicks. And that brings us to the end of this tutorial on the topic how to create a completely functional sales report or sales dashboard in a few clicks and in a few minutes.
Welcome to Simplilearn. In this video, we are focusing on ChatGPT and its groundbreaking role in data analytics. In a world where data is the new gold, understanding and analyzing this wealth of information is crucial. But as the volume of data grows exponentially, traditional analysis methods are being pushed to their limits. Enter ChatGPT, a revolutionary AI developed by OpenAI that's transforming how we approach data analytics. But what makes ChatGPT stand out in the crowded field of data analytics tools? How can it not only streamline complex processes, but also uncover insights that were previously hidden in plain sight? Stay tuned as we unravel the capabilities of ChatGPT, share real-world applications, and show you how it's being used by analysts and businesses alike to make smarter, data-driven decisions. And whether you are a data scientist, a business professional, or just a tech enthusiast, curious about the future of AI in data analytics, this video is for you. So let's dive in and discover how ChatGPT is not just revolutionizing data analytics, but also how we understand and interact with the vast universe of data. And don't forget to hit that like button, subscribe, and ring the bell to stay updated on all our future explorations into the fascinating world of technology. Now let's get started and unlock the potential of ChatGPT for data analytics together. So guys, an Excel data analyst always looks for ways to improve their efficiency and gain deeper insights from the data. That's where ChatGPT comes in handy. So ChatGPT is an AI-powered language model that can assist you in various tasks, including Excel-based data analysis. And for that data analysis, let's dive into some demos to see how it works. So guys, as you can see, this is the ChatGPT 4, and you could see this has the support of DALL-E, browsing and analysis, and usage limits may apply. Like we have the version that has some usage limits. And for the data, I have downloaded the data from the Kaggle. I will provide you the link in the description. If you want to download the same data, you can. And I have that in my downloads. So this is the data that we'll be using. So the first thing we'll be doing is data cleaning and preparation. So firstly, let's explore data cleaning and preparation. Before diving into analysis, it's essential to ensure our data is clean and ready for processing. So for that, we will write a prompt in ChatGPT and ask him to clean the data. ChatGPT has the feature to insert the files, provide the Excel file to the ChatGPT, and we'll ask him that can you help me identify and remove duplicates in this Excel spreadsheet. So let's ask him, can you help me identify and remove duplicates? Duplicates from this Excel spreadsheet, from the provided Excel spreadsheet. So you could see that ChatGPT has started generating the response, and he is telling us that he can definitely help us with that, and he is analyzing that. So you could see that ChatGPT has provided us the response. So let's first go to our spreadsheet. So this is the spreadsheet. Order number, quantity ordered, price of each quantity, and order lines. So you could see that first ChatGPT has encountered an error, and that is with the character and coding mismatch. and then he has loaded the spreadsheet successfully with the second attempt. And you could see that he has provided like the smaller or the briefer version of the spreadsheet. That is, the dataset consists of sales data with columns such as order number, quantity, order, price each, order line, sales, order date, status. So he's asking us, could you specify how you would like to identify duplicates? For example, should we consider a row a duplicate if all its values match another row exactly, or are there specifically columns we should focus on to determine duplicates? So we should, or here we will be focusing on the column section. So here we want to identify column section. So is asking which columns they should identify duplicates. So we want the duplicates in order number. So the ChatGPT has started analyzing the spreadsheet. So you could see that ChatGPT has produced the response that they have identified a total of 2,807 rows in the spreadsheet that have duplicates based on the order number column. So this indicates that multiple rows share the same order number, suggesting there might be different items or transactions within the same order. Would you like to proceed by removing these duplicates while keeping either the first or last occurrence of each order number, or do you have another approach in mind for handling these duplicates? So before identifying the duplicates, what we'll do is we'll first get rid of the extra spaces. So we'll ask ChatGPT that first find the extra spaces in the spreadsheet and help us remove them. So you could see that it has started analyzing it. So he is asking us that would you like to proceed with any further cleaning or data manipulation? Yes, we want to proceed further with data cleaning only. And now we will treat all the blank cells if there are any. Now treat all the blank cells if there are any. So the spreadsheet contains blank cells in the following columns with their respective counts of blank entries. That is, address line 2 has 2521 blank cells, then the state. So depending on your preference or the requirements of your data analysis, we can treat these blank cells in several ways, such as filling them with a placeholder value that is not provided using a specific value that makes sense for data. That is, example, a default state or territory, but potentially leaving them as if blanks carry meaningful information in the context of your data. So what we will do, we will provide a placeholder. Provide a placeholder instead, that is not provided or not applicable. Okay. So you would see that ChatGPT has responded that it has replaced the blank cells in the columns, that is address line 2, state, postal code and territory, with the placeholder not provided. So you could see there's a verification sample showing the updates. So this is how you could clean the data. And now with ChatGPT, you can quickly identify and eliminate duplicates in your Excel spreadsheet using built-in functions and formulas, saving your time and effort. So that would be done by the ChatGPT, and you can download the Excel file from the ChatGPT only. After that, you can just ask him that provide me the output or the resulted spreadsheet. So if we talk about now data analysis and visualization, let's delve into that. So Excel offers powerful tools for analyzing and visualizing data, and ChatGPT can help you make the most of them. So for this also we'll write a prompt to the ChatGPT, and we'll write, for example, we'll write, please create a pivot table and a corresponding chart to analyze sales performance by region. So let's see, like this prompt, what output does ChatGPT show to us? So let's ask him, please create a pivot table and a corresponding chart to analyze sales performance by region. So you could see that ChatGPT has started analyzing the data and the spreadsheet, and you could see that the pivot table below shows the sales performance by region or the territory. So this table indicates that the EMEA region has the highest sales performance, followed by regions where the territory was not provided, then APAC, and finally Japan. So now let's create a chart to visually represent this sales performance by region. You could see that it has provided a chart, that is a bar chart illustrating the sales performance by territory. So you could see the guys that it has provided us the analysis, and ChatGPT can guide you through the process of creating pivot tables, charts, and other visualizations in Excel, enabling you to gain valuable insights from your data with ease. So let's move to advanced analysis and automation. So lastly, we will explore advanced analysis and automation. So Excel capabilities extend beyond basic functions, and ChatGPT can help you leverage its full potential. And for this also, we'll write a prompt to the ChatGPT that can you assist me in building a forecasting model to predict future sales based on historical data present in the spreadsheet. So let's see what ChatGPT respond to us. So let's ask him, can you assist me in building a forecasting model to predict future sales based on historical data. So let's see what ChatGPT respond to us. So you could see that building a forecasting model to predict future sales based on historical data involves several steps. So for this, you have to prepare the data, select a model, train the model, evaluate the model, and make predictions. So let's start by preparing the data. We'll aggregate sales by order date to create a time series of total daily sales. Then we'll choose a model based on data's characteristics. So we will grant the permission to ChatGPT to proceed with the steps. So he has started analyzing the data. So you could see that the data has been prepared into a time series of total daily sales. And before choosing a forecasting model, it's helpful to visualize the sales time series to understand its characteristics such as trend and seasonality. So ChatGPT has plotted a daily sales data, and then he has given the visual trends and the possible seasonal patterns. And the next steps would include testing for stationarity, model selection and parameter tuning, model training, and then forecasting. So you could follow all these steps with the help of ChatGPT and could create a forecasting model. If you want, we can move to the next step. So you could provide a prompt to the ChatGPT that move to or proceed with next step. So step by step, ChatGPT will provide you a forecasting model, or it will help you create a forecasting model. As you can see, it has started analyzing it. So the augmented Dickey-Fuller, that is ADF test, gives up a p-value of approximately 0.0033. Since this p-value is less than the common significance level of 0.05, we can reject the null hypothesis that the time series has a unit root, meaning the time series is stationary. So you could see that he is asking us, shall we proceed with the SARIMA model parameter selection? Yes, here is the model parameter selection. So you could select any based on the trends and the bar graphs plotted by the ChatGPT. So you could see guys that the ChatGPT has analyzed the spreadsheet and provided the response that the grid search for the optimal SARIMA parameters based on the lower ACALI information criterion, such as the best fit model uses the parameter 011 and for ARIMA and 01112, that is for the seasonal component. So you could see that it has provided the model and the parameters. Now it's asking us, shall we move on to forecasting future sales with this model? Yes, proceed with that. So you could see that with ChatGPT's assistance, you can build complex forecasting models in Excel, allowing you to make informed decisions and plan for the future effectively. So ChatGPT is a valuable tool for Excel users and data analysis, offering assistance in data cleaning, analysis, visualization, and automation. And by integrating ChatGPT in your Excel workflows, you can enhance your productivity and uncover new insights from your data. So you can try ChatGPT for Excel data analytics today and take your Excel skills to the new level. And you could see that there's an error in the analyzing, and he has encountered an error while trying to plot the forecast with its confidence intervals. So this type of error can occur due to data type issues, particularly when handling data indices and forecast. And despite this hiccup, the forecasting process using the Cinema model was completed and we were able to generate forecast for the next 12 months. Unfortunately, due to the plotting issue, we couldn't visually display it. So we'll ask him, can you try once again? So you could see that this time ChatGPT has provided us the forecast for the next 12 months. That is, the forecast have been successfully plotted along with the historical daily data. So here we have our forecast model, and with the ChatGPT's assistance, we can move with other analysis also.
Since this is data analysis with Python, we got to ask the question, why Python for data analytics? I mean, there's C++, there's Java, there's .NET from Microsoft. Why do people go to Python for it? So the number of reasons. One, it's easy to learn with simple syntax. You don't have a very high typeset like you do in Java and other coding, so it allows you to kind of be a little lazy in your programming. That doesn't mean that it can't be set that way and that you don't have to be careful. It just means you can spin up a code much quicker in Python. The same amount of code to do something in Python a lot of times is 1, 2, or 3 or 4 lines, where when I did the same thing, say in Java, I found myself with 10, 12, 13, 20 lines, depending on what it was. It's very scalable and flexible. So there's our flexibility because you can do a lot with it, and you can easily scale it up. You can go from something on your machine to using PySpark into the Spark environment and spread that across hundreds, if not thousands of servers across terabytes of data or petabytes of data. So it's very scalable. There's a huge collection of libraries. This one's always interesting because Java has a huge collection of libraries. C has a huge collection of libraries. .NET does, and they're always in competition to get those libraries out. Scala for your Spark. All those have huge collections of libraries. This is always changing, but because Python's open source, you almost always have easy to access libraries that anybody can use. You don't have to go check your licensing and have special licensing like you do in some packages. Graphics and visualization, they have a really powerful package for that, so it makes it easy to create nice displays for people to read. And community support. Because Python is open source, it has a huge community that supports it. You can do a quick Google and probably find a solution for almost anything you're working on. Python libraries. Let's bring it together. We have data analytics and we have Python. So when we're talking data analytics, we're talking Python libraries for data analytics. And the big 5 players are NumPy, Pandas, Matplot library, SciPy, which is going to be in the background, so we're not going to talk too much about the scientific formulas in SciPy, and scikit. So NumPy supports n-dimensional arrays, provides numerical computing tools useful for linear algebra and Fourier transform. And you can think of this as just a grid of numbers. And you can even have a grid inside a grid, or data. It's not even numbers because you can also put words and characters and just about anything into that array. But you can think of a grid, and then you can have a grid inside a grid, and you end up with a nice 3-dimensional array. If you want to talk 3-dimensional array, you can think of images. You have your 3 channels of color, 4 if you have an alpha, and then you have your XY coordinates for the image we're looking at. So you can go X, Y, and then what are the 3 channels to generate that color. And NumPy isn't restricted to 3 dimensions. You could imagine watching a movie. Well, now you have your movie clips, and they each have their X number of frames, and each of those frames have X number of XY coordinates for the pictures in each frame, and then you have your 3 dimensions for the colors. So NumPy is just a great way to work with n-dimensional arrays. Now closely with NumPy is Pandas. Useful for handling missing data, perform mathematical operations, provides functions to manipulate data. Pandas is becoming huge because it is basically a data frame. And if you're working with big data and you're working in Spark or any of the other major packages out there, you realize that the data frame is very central to a lot of that. And you can look at it as a Excel spreadsheet. You have your columns, you have your rows or indexes, and you can do all kinds of different manipulations of the data within, including filling in missing data, which is a big thing when you're dealing with large pools or lakes of data where they might be collected differently from different locations. And Matplot library. We did kick over the SciPy, which is a lot of mathematical computations, which usually runs in the background of NumPy and Pandas. Although you do use them, they're useful for a lot of other things in there. But the Matplot library, that's the final part. That's what you want to show people. And this is your plotting library in Python. Several toolkits extend Matplot library functionality. There's like 100 different toolkits to extend Matplot library, which range from how to properly display star constellations from astronomy. There's a very specific one built just for that, all the way to some very generic ones. We'll actually add Seaborn in when we do the labs in a minute. Several toolkits extend Matplot library functionality, and it creates interactive visualization. So there's all kinds of cool things you can do as far as just displaying graphs, and there's even some that you can create interactive graphs. We won't do the interactive graphs, but you'll see, you'll get a pretty good grasp of some of the different things you can do in Matplot library. Let's jump over to the demo, which is my favorite. Roll up our sleeves and get our hands in on what we're doing. Now, there's a lot of options when we're dealing with Python. You can use PyCharm as a really popular one. And you'll see this all over the place. So it's one of the main ones that's out there, and there's a lot of other ones. I used to use NetBeans, which has kind of lost favor. Don't even have it installed on my new computer. But the most popular one right now for data science. Now, PyCharm is really popular for Python general development. For data science, we usually go to Jupyter Notebook or Anaconda. And we're going to jump into Anaconda because that's my favorite one to go to because it has a lot of external tools for us. We're not going to dig into those, but we will pop in there so you can see what it looks like. So with Anaconda, we have our Jupyter Lab, we have our notebook. These are identical. Jupyter Lab is an upgrade to the notebooks with multiple tabs. That's all it is. And we'll be using the notebook. And you can see that PyCharm is so popular with Python that we even have it highlighted here in Anaconda as part of the setup. Jupyter Notebook can also be a standalone. So we're actually going to be running Jupyter Notebook. And then you have your different environments. We're going to be under main Py36. There's a root one. And I usually label it Py36. The reason is currently as of writing this, TensorFlow only works in 3.6 and not in 3.7 or 3.8 for doing neural networks. But you can actually have multiple environments, which is nice. They separate the kernels, so it helps protect your computer when you're doing development. And this is just a great way to do a display or a demo, especially if you're looking for that job. Pull up your laptop, open it up. Or if you're doing a meeting, get it broadcast up to the big screen so that the CEO can see what you're looking at. And when we launch the notebook, it actually opens up a file browser in whatever web browser you have. This happens to be Chrome. And then you can just go under New. There's a lot of different options depending on what you have installed. Python 3. And this just creates an untitled version of this. And you can see here I'm actually in a Simplilearn folder for other work I've done for Simplilearn. And that's where I save all my stuff and I can browse through other folders, making it real easy to jump from one project to another. And under here, we'll go ahead and change the name of this, and we'll go ahead and rename it Data Analytics. Data Analytics. Just so I can remember what I was doing. Which is probably about 50 of the folders in here, or files in here right now. So let's go ahead and jump in there and take a look at some of these different tools that we were looking at. And as we go through the demo, let's start with the NumPy. The least visually exciting. And I'm going to zoom in here so you can see what we're doing. And the first thing we want to do is import NumPy. And we'll import it as NP. That is the most common NumPy terminology. And let's go ahead and change the view so we also have the line numbers. I don't know why, we probably won't need them, but I like it for easy reference. And then we'll create a one-dimensional array. We'll just call this array1, and it equals np.array, and you put your array information in here. In this case, we'll spell it out. You can actually do like a range and other ways. There's lots of ways to generate these arrays. But we'll just do 1, 2, 3, so 3 integers. And if we print our array1, we can go ahead and run this. And you can see right here it prints 1, 2, 3. You can see why this is a really nice interface to show other people what you're doing with the Jupyter Notebook. So this is the basic. We've created an array. This is a one-dimensional array, and then the array is 1, 2, 3. One of the nice things about the Jupyter Notebook is whatever ran in this first setup is still running. It's still in the kernel. So it still has the numpy imported as np, and it still has our variable arr1 for array1 equal to np array of 1, 2, 3. So when we go to the next cell, we can check the type of the array. We're just going to print. We say, hey, what is this setup in here? And we want type, and then we want, what is the type of array1? And let's go ahead and run that. And it says class numpy nd array. So it's its own class. That's all we're doing is checking to see what that class is. And if you're going to look at the array class, probably the biggest thing you do, I don't know how many times I find myself doing this because I forget what I'm working on, and I forget I'm working with a 3-dimensional or 4-dimensional array. And I have to reformat somehow so it works with whatever other things I have. And so we do the array shape. The array shape is just 3 because it has 3 members and it's a one-dimensional array. That's all that is. And with the numpy array, we can easily access, stick with the print statement. If you actually put a variable in Jupyter Notebook and it's the last one in the cell, it will be the same as a print statement. So if I do this, where array1 of 2, it's the same as doing print array of 2. Those are identical statements in our Jupyter Notebook. We'll go and stick with the print on this one. And it's 3. So there's our print space 2. And we have 0, 1, 2. 2 equals 3. We can easily change that. So we have array 1 of place 2 equals 5. And then if we print our array 1, you can see right down here when it comes out, it's 1, 2, and 5. And there I left the print statement off because it's the last variable in the list. It'll always print the variable if you just put it in like that. That's a Jupyter Notebook thing. Don't do that in PyCharm. I've forgotten before doing a demo. And we talked about multiple dimensions, so we'll do an array, 2-dimensional array. And this is again a numpy array. And in the numpy array, we need our first dimension. We'll do 1, 2, 3, and our second dimension 3, 4, 5. And you can see right here that when we hit the, we'll do this. We'll just do array 2. And we can run that, and there's our array 2, 1, 2, 3, 3, 4, 5. We can also do array 2 of 1. And then we can do, let's do 0. Doesn't really matter which one. Actually, let's do 2. There we go. And if I run this, it'll print out 5. Because here we are. This is 0. 0, 1, 2, 3 is on our 0 row. 3, 4, 5 is on our 1 row. I always start with 0. And then the 2, 0, 1, 2 goes to the 5. And then maybe we forgot what we were working with. So we'll go do array2.shape. And if we do array 2 of shape, we'll go and run that. We'll see we have 2 rows, and each row has 3 elements. 2-dimensional array, 2, 3. If you looked up here when we did it before, it just had 3 comma nothing. When you have a single entity, it always saves it as a tuple with a blank space. But you can see right here we have 2 comma 3. And if you remember from up here, we just did this array 2 of, let's go, what is it, 1 comma 2. We run that, we get the 5. you can also count backwards. This is kind of fun. And you'll see I just kind of switched something on you because you can also do 1, 2 to get to the same spot. Now 2 is the last one, 0, 1, 2. It's the last one in there. We can count backwards and do -1. And if we run this, we get the same answer. Whether we count it as, let's go back up here. Whether we count this as 0, 1, 2, or we count backwards as -1, -2, -3. And you can see that if I change this -1 to a -2 and run that, I get 4, which is going backwards, -1, -2. So there's a lot of different ways to reference what we're working on inside the NumPy array. It's really a cool tool. It's got a lot of things you can do with it. And we talked about the fact that it can also hold things that are not values. And we'll call this array ask for strings equals np.array. Put our setup in there, our brackets, and let's go China, India, USA, Mexico. It doesn't matter, we can make whatever we want on here. And if we print that out, we run this, you can see that we get our NumPy array, China, India, USA, Mexico. It even gives us our D type of a U6. And a lot of times when you're messing with data, we'll call this array R for range, just to kind of keep it uniform. np.arange. So this is a command inside NumPy to create a range of numbers. And if you're testing data, maybe you want, maybe you have equal time increments that are spaced a certain point apart. But in this case, we're just going to do integers. And we're going to do a setup from 0, 20, skipping every other one. And we'll print it out and see what that looks like. And you can see here we have 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. Like you expected, it skips every one. And just a quick note, there's no 20 on here. Why? Well, this starts at 0 and counts up to 20. So if you're used to another language where it explicitly says less than or less than equal to 20, like for x equals 0, x plus plus, x is less than 20. That's what this is. It just assumes x is less than 20 on here. And if we want to create a very uniform set, 0, 2, 4, 6, what happens if I want to create numbers from 0 to 10, but I need 20 increments in there? We can do that with line space. So we can create an R, we'll call this L, equals, I don't think we'll actually use any of this again, so I don't know why I'm creating unique identifiers for it. But we'll do np lin space, and we're going to do 0 to 10, or 0 to 9. Remember, it goes up to 10. And then we want to, let's say we have 20 different increments in there. So we're creating we have a data set, and we know it's over a certain time period, and we need to divide that time period by 20. And it happens to just have 10 pieces in it. And here we go. You can see right here, we have 20, or it has 20 pieces in it, but it's over 10 years. And we got to divide it in the middle. And you can see it goes 0.52. Remember, yeah, there's our 10 on the end, so it goes up to 10. And then we can also do random. There's np.random. If you're doing neural networks, usually you start it by seeding it with random numbers. And we'll just do np.random, and we'll just call this array. We'll stop giving it unique numbers. We'll print that one out and run it. And you can see we have random numbers. They are 0 to 1. So you'll see that all of these numbers are under 1. And you can easily alter that by multiplying them out or something like that if you want to do like 0 to 100. You can also round them up if it's integers 0 to 100. There's all kinds of things you can do, but it generates a random float between 0 and 1. And you have a couple options. You could reshape that, or you can just generate them in whatever shape you want. And so we can see here, we did 3 and 4, and so you can see 3 rows by 4 variables. Same thing as doing a reshape of 12 variables to 3 and 4. And if you're going to do that, you might need an empty data set. I have had this come up many times. or I need to start off with 0, and I don't know, because I'm going to be adding stuff in there, or it might be 0 and 1, where 1 is, if you're removing the background of an image, you might want the background is 0, and then you figure out where the image is, and you set all those boxes to 1, and you create a mask. So creating masks over images is really big, and doing that with a numpy array of 0. And we can also give it a space. And we'll just do this all in one shot this time. And we'll do the same thing like we did before, zeros. And in this case, we'll do 2, 3. And so when we run this, forgot the asterisks around it. I knew I was forgetting something. There we go. So when we run this, you can see here we have our 10 zeros in a row, and maybe this is a mask for an image, and so it has 2 rows of 3 digits in it. So it's a very small image, little tiny pixel. And maybe you're looking to do something the opposite way. Instead of creating a mask of zeros and filling in with ones, maybe you want to create a mask of ones and fill them in with zeros. And we'll just do, just like we did before, we'll do 3, 4. And when we run this, you'll see it's all ones. And we could even do this even, we'll do it this way. Let's do 10 by 10 icon, and then you have your 3 colors. And you can, so it creates quite a large array there for doing pictures and stuff like that when you add that 3rd dimension in. If we take that off, it's a little bit easier to see. We'll do 10 again. And you can easily see how we have 10 rows of 10 ones. And you can also do something like create an array. And we'll do 0, 1, 2. And then in this array, we actually, we'll print it right out. We want a repeat. And so you can actually do a repeat of the array, and maybe you need this array, let's repeat it 3 times. So there's our repeat of an array, repeat 3 times. And if we run this, you'll see we have 0, 0, 0, 1, 1, 1, 2, 2, 2. And whenever I think of a repeat, I don't really think of repeating being the first digit 3 times, the second digit. I really always think of it as 0, 1, 2, 0, 1, 2, 0, 1, 2. It catches me every time. But the actual code for that one is going to be tile. And again, if we do arrange 3 and we run this, you can see how you can generate 0, 1, 2, 0, 1, 2, 0, 1, 2. And if you're dealing with an identity matrix, we can do that also if you're big on doing your matrices. And we'll just identity. I guess we'll go ahead and spell it out today. Matrix. And the command we're looking for is EYE. And we'll do 3. And then we'll just go ahead and print this out. There we go. There's our identity matrix. And it comes out by a 3 by 3 array, because there's our matrix. And then it puts the ones down the middle and for doing your different matrix math. And we can manipulate that a little bit too. We talk about matrices. We might not want ones across the middle, in which case we now have the diagonal. So we can do an np.diagonal. And we do a diagonal. Let's put in the diagonal 1, 2, 3, 4, 5. And when we run this, again, this generates a value. And by just putting that value in, there's the same as putting print around it, or putting array equals and then print array. And you can see it generates a diagonal 1, 2, 3, 4, 5, and there's your beginning of your matrix array for working with matrices. And we can actually go in reverse. Let's create an array equals, remember our random.random, and we'll do a 5 by 5 array. Oops, there we go. 5 by 5. And just so you can see what that looks like. Helps if I don't mistype the numbers. which in this case I just need to take out the brackets. And there you go. You have your 5x5 array set up in there. And we can now, because we're working with matrices, we might want to do this in reverse and extract the diagonals, which would be the 0.79, the 0.678, and so on. And we simply type in np.diagonal. We put our array in there. And this will, of course, print it out because it returns it as a variable. And you can see here, here's our diagonal going across from our matrix. And we did talk about shape earlier. If you remember, you can do print the shape out. You can also do the dimensions. So in dimensions, very similar to shape, it comes out and just has 2 dimensions. We can also look at the size. So if we do size on here, we can run that. And you can see it has a size of 25, 2 dimensions, and of course 5x5. And that was from the shape from earlier that we looked at. There's our 5x5 shape. And if you remember earlier we did random, well, you can also do random. I talked a little bit about manipulating 0 to 1 and how you can get different answers. You can also do straight for the integer part, and we'll do minus 10 to 10, 4. And so we're going to generate random integers between minus 10 to 10. We're going to generate 4 of those. And so when we run that, we have 7, minus 3, minus 6, minus 3. They're all between minus 10 and 10, and there's 4 of them. And now we jump into some of the functionality of arrays, which is really great, because this is where they come in. Here's your array, and you can add 10 to it. And if I run this, there it takes my original array from up here with the integers and adds 10 to all of those values. So now we have, oh, this is the decimal, that's right. This is a random decimal I had stored in an array. But this takes the random numbers I had from 0 to 1 and adds 10 to them. And we can just as easily do minus 10. We could even do times 2. And we could do divide by 2. And it'll take that random number we generated and cut it in half. So now all these numbers are under 0.5. Another way you can change the numbers to what you need on there. And as you dig deeper into NumPy, we can also do exponential. So as an exponential function, which should generate some interesting numbers off of the random. So we're taking them to the power, I don't even remember what the original numbers in the array were, because we did the random numbers up there. Here's our original numbers, and if you build an exponential on there, this is where you get e to the x on this. And just like you can do e to the x, you can also do the log. So if you're doing logarithmic functions, that reinforced learning, you might be doing some kind of log setup on there, and you can see the logarithmic of these different array numbers. And if you're working with log base 2, you can just change it in there, np log 2. You have to look it up, because this is not log 1, 2, 3, 4, 5. It is log and log 2. So just a quick note, that's not a variable going in. That is an actual command. There's a number of them in there, and you'll have to go look and see what the documentation is. But you can also do log 10. So here's log value 10. Some other really cool functions you can do with this is your sine. So we can take a sine value of all of our different values in there. And if you have sine, you of course have cosine. We can run that. So here's the cosine of those. And if you're doing activations in your NumPy array and you're doing a tangent activation, there's your tangent for that. And the tangent activation is actually from neural networks. That's one of the ways you can activate it, because it forms a nice curve between from whether you're generating 1 to -1 with some discrepancy in the middle. Just jumping a little bit in there into neural networks. And then we get into, let me just put the array back out there so that we can see it while we're doing this. As we're getting into this, you can also sum the values. So we have np sum, and you can do a summation of all the values in this array. And you'll see that if you added all these together, they'd equal 12.519, so on. I don't know what the whole setup is in there. But you can see right here, the summation of this, one of the things you can also do is by axes. So we could do axes equals 0. And if we run the summation of the axes equals 0, and you can think of that in NumPy as the rows. So that would be, or you can think of that in NumPy as being the columns. We're summing these columns going across. And you can also change this to 1, and now we're summing the rows. And so that is the summation of this row, and so forth going down. And maybe you don't need to know the summation. Maybe what you're looking for is the minimum. So here's our minimal. You're looking for, and this comes up a lot because you have like your errors. We want to find the minimal error inside of this array. And just like the other one, we can do axes equals 0. And you can see here 0.0645 is the smallest number in this first column is 0.0645 and so on. And if you have a minimum, well, you might also want to know the max. Maybe we're looking for the maximum profit. And here we go. You can see maximum 0.79 is the maximum on this first column. And just like we did before, you can change this to a 1 on axes. You can take the axes out of here and just find the max value for the whole array. And the max value in here was 0.8344, so on and so on. And since we're talking data analytics, we want to go ahead and look at the mean. Pretty much the same as the average. This is the mean across the whole thing. And just like we did before, we could also do axes equals 0. And then you'll see this is the mean of this axis and so on. And we have mean. We might want to know the median. And there's our median, our most common numbers. If we have median, we might want to know the standard deviation. Or if we have the average, a lot of times you do the means and the standard deviation. We can run that, and there's our standard deviations along the axes. We can also do it across the whole array. If we're going to do standard deviations, there's also variance, which is your VAR. And there's our variance across the different levels. And so if we looked at that, we looked at variance, we looked at standard deviation, the median, and the means. There's more, but those are the most common ones used with data analytics. And then going through your data and figuring out what you're going to present to the shareholders. And some other things we can do is we can actually take slices. You'll hear that terminology. And a slice might be, like we have a 5 by 5 array, but maybe we don't want the whole array. Maybe we want from 1 on, we don't want the 0 in there. So we got up to 4. And maybe on the second part, we just want 2 to row 3. And so this notation right here says 1 to the end. And if we run this, you can see how that generates a single row to the end, and then row 2 and 3. Now remember, it doesn't include 3. That's why we only get the 1 column. So if you wanted 2 and 3, you would need to go ahead and go 2 to 4. So it goes up to 4. We could also do this in reverse. Just like we learned earlier, we can go -1. Whoops. And when we go to -1, it's the same thing because we have 0, 1, 2, 3, 4. This is the same thing as 2 to 4. It goes 2 to the last one. Also very common with arrays is you're going to want to sort them. So we still have our array up here that we randomly generated, and we might want to sort it, and we'll go and throw an axis back in there. Axis equals 1. If we run this, you can see from the axes that it sorts it, the 0.2 being the lowest value to the highest value by the row. We can also change this, of course, to axis 0 if you're sorting it by columns. So maybe your values are based on columns. And then, of course, you can do the whole array, and we can sort that. Don't usually do that, but I guess sometimes that might come up. And so you can see right here we have a nice sorted array. Something else, let's just go ahead and reprint our array so we can look at it again. Starting to get too many boxes up there. Something else you can do with an array is we can take and transpose it. This comes up more than you would think. When you transpose it, you'll see that the rows in the column are transposed. So where 0.79, 0.57, 0.064 is the column, now we've switched it and we have 0.79, 0.42 as the index. You can see this really more dramatic if we take a slice, and we'll just do a slice of the first couple, and then we'll just do all the other, the full rows, and if we run this, you can see how it comes up a little bit different. And we'll just do the same slice up here so you can see how those two look next to each other. There we go, there's our slice, run. And so you can see the slice comes up and it has 1, 2, 3, 4, 5 columns. Now we have 1, 2, 3, 4, 5 rows and 3 columns versus 3 rows. And the original version, when they first started putting this together, was a function. So the original version was transpose, and this still works. You can still see it generates the same value as just a capital T. So many times we flip this data because we'll have an XY value or we'll have an image or something like that, and it's being read one way into the next process, and the next one needs it the opposite. So this actually happens a lot. You need to know how to transpose the data really quick. And we can go ahead, let's just take, here's our transpose. We'll just stick with the transpose on here. And instead of doing it this way, we might need to do something called flattening. Why would you flatten your data? If this is an array going into a neural network, you might want to send it in as one set of values instead of 2 rows. And you can see here is all the values as a single array. It just flattens it down into one array. So we covered our scientific means, transpose, median, some different variations on here. Some of the other things we want to do is what happens if we want to append to our array. So let's create a new array. I'm getting tired of looking at the same set of random numbers we generated earlier. So we'll go ahead and create a new array here, something a little simpler so it's easier to see what we're doing. And 4, 5, 6, 7, 8. That's good enough. We'll just do 4, 5, 6, 7, 8. And if we print this array, there it is, 4, 5, 6, 7, 8. And we might want to append something to the array. So we have our array, we need to extend it. You got to be very careful about appending things to your array, and there's a number of reasons for that. One is runtime. Because of the way the NumPy array is set up, a lot of times you build your data and then push it into the NumPy array instead of continually adding on to the array. And then it also it automatically generates a copy for protecting your data. So there's a lot of reasons to be careful about appending this way. But you can certainly do it. And we can just take our array, we're going to create a new array, array 1. And if we print array 1 and we append 8 to it, you'll see 4, 5, 6, 7, and then there's our 8 appended on to the end. And if you want to append something to an array, you'd probably also want to, whoops, array 1. Let's try that again. There we go. Now we have the 8 appended onto the end. So you can see 4, 5, 6, 7, 8, and then we appended another 8 on there. And if you're going to append something, you might want to go ahead and insert. Instead of appending, it might be you need to keep a certain order. And we can do the same thing. We can do our array, and we're going to append or insert at the beginning. And let's go ahead and insert 1, 2, 3. 1, 2, 3. And we go ahead and print our array 2, and we run it, and you can see 1, 2, 3 is inserted at the beginning. Insert's a lot more powerful in that you can put it anywhere in the array. We can move it to the 1 spot, and there we go, 1, 2, 3. We can do a -1 just for fun, and you'll see it comes up 1, 2, 3, and we're counting backwards by 1. I imagine you can do a -0 and run this, and it turns out that -0 puts it back at the beginning because that's how it registers as 0, just takes a minus sign off. And just like we add numbers on, we might want to delete numbers. And so let's do an np.delete. Well, let's keep it a little bit, make it a little easy here to watch. We'll go ahead and create an array 3, and we'll do np delete. We were just working with array 2, and what we want to do is delete 0 space. So if you look at this, here's our array 2. Array 2 starts with 1. And when we delete the space on here and print that out, we deleted the 1 right out of there. And we can also do something like this, where we can do it as a slice. And we can do, let's do 1, 3. And if we run 1, 3, you'll see we've deleted the 1 space and the 3 space out, which deleted our 2 and 4. Now, keep in mind, when you're messing with adding lines and deleting lines, you have to be really careful, because there's a time element involved as far as where the data is coming from, and it's really easy to delete the wrong data and corrupt what you're working on, or to insert stuff where you don't want it. So there's always a warning when we talk about manipulating NumPy arrays. And just like anything else we're doing, we'll create an array C, which equals, we'll just do our NumPy array that we just created, our NumPy array 3, and we can do copy. So you can make a copy of it. Maybe you want to protect your original data, or maybe you're making a mask, and so you copy the array, and then the new array make all these alterations and change it from values to 0 to 1 to mask over the first one. And of course, if we do array C, since it equals a copy of array 3, it's the same thing, 1, 3, 5, 6, 7, 8. And now we're getting into combine and split arrays. I end up doing a lot of this, and I don't know how many times I end up fiddling with this and having a mess. But you do it a lot. You know, you combine your arrays, you split them. You might need one set of data for one thing, another set of data for the other. So let's go ahead and create 2 arrays, array 1, array 2. And I want you to note, and the terminology we're going to look for is concatenate. And what that means is we're going to take, we'll call this array cat. I like array cat. There we go. Our array cat, our concatenated array, we're taking array 1 and 2, and it's very important to really pay attention to your axes and your counts. I can't merge 2 arrays that have, like, if their axes are messed up and I'm merging on axis 0, it's going to give me an error and I'll have to reshape them. So you got to make sure that whatever you're concatenating together works. And what that means, as you can see here, we have 1, 2, 3, 4, 1, 2, 3, 4, and then 5, 6, 7, 8, 5, 6, 7, 8 along the 0 axis. These each are 4 values. So it's a 2 by 4 value. And if we go ahead and switch this to 1, you can see how that flips it a little bit. So now we have 1, 2, 3, 4, 5, 6, 7, 8. It's interesting that we chose that one. If I did something like this, where this is now, there we go, and we concatenate it, run this, and it gives me an answer okay, because I have 2 by 2, and I'm using axis 1. But if I switch this to axis 0, where now it's got 3 and 5, it gives me an error. So you got to be really careful on that to make sure that your whatever axes you are putting together, that they match. So like I said, this one, oops, axis 1. Axis 1 has 2 entities, and since we're going on axis 1, or by row, you can see that it lets it merge it right onto the end there. And you could imagine this, if this was a XY plot of value, or the X value going in and the predicted Y value coming out, and then you have another prediction and you want to combine them, this works really easy for that. And we'll go back, and let's just put this back to where we had it. Oops, I forgot how many changes I made. There we go. We'll just put it, whoops, I messed up in my concatenation order here. There we go. Okay, so you can see that we went through the different concatenation. Axes is really important when you're doing your concatenation values on here. And we'll switch this back to 1 just because I like the looks of that better. There we go. 2 rows. Now, there are other commands in here. So we can do cat v equals np v stack. This is nothing more than your concatenation, but instead we don't have to put the axes in there because v stands for vertical. And so if we print out cat v and we run this, you can see we get the 1, 2, 3, 4, 1, 2, 3, 4, and that would be the same as making this axis 0 for vertical stack. And if you're going to have a vertical stack, you can also have an H stack. So if we change this from V stack to, oops, here we go, H stack, and we'll just change this from cat to cat, and I run this, it's the same as doing axis 0. The process is identical in the background. This is like a legacy setup, your V stack and your H stack. Most people just use concatenate and then put the axes in there because it's has a lot more clarity and is more commonly used nowadays. The last section in NumPy we're going to cover is kind of data exploration, and that'll make a little bit more sense in just a moment. Sometimes they call them set operations. But let's say we have an array, 1, 2, 3, 4, 5, 6, 3, whatever it is. You can see we generate a nice little array here. And what I want to go ahead and do is find the unique values in that array. So maybe I'm generating what they call a one-hot encoder. And so these values then all become, I need to know how long my bit array is going to be. So each word, each word is represented by a number, and then I want to know just how many of those words are in there. If we're doing word count, very popular thing to do. And you can see here when we do unique, we have 1, 2, 3, 4, 5, 6. Those are our unique values. Some of the things we can do with the unique values is we can also, instead of doing just unique, we can do uniques, our unique values, and counts of each unique value. And this is very similar to what we just did up here, where we're doing NP unique, but we're going to add a little bit more into there. And it's just part of the arguments in this. And we want to do return counts equals true. So instead of just returning the unique values, we want to know how many of those unique values are in each one. And we'll go ahead and print our uniques and print our counts. When we run that, you can see here we have our unique value 1, 2, 3, 4, 5, 6, just like we had before. And then there's two of the first of 2 1s, 2 2s, 2 3s, 2 4s, 1 5, 2 6s, and so on. And you can go through and actually look at that if you want to count them. But a quick way to find out your distribution of different values. So you might want to know how often the word the is used versus the word and, if each word is represented as a unique number. And along the set variables, we might want to know, let me just put a note up here. We're going to start looking at intersection, and we might want to also know differentiation, and neither. So when we're, neighbor, neither. So when we're looking at now is we want to know, hey, where do these two arrays intersect? And we have 1, 2, 3, 4, 5, 3, 4, 5, 6, 7. We might want to know what is common between the two arrays. And so when we do that, we have NP intersect, and it's a 1D array, one-dimensional array. And then we need to go ahead and put array 1, array 2. And if we run this, we can see they intersect at 3, 4, 5. That's what they have common. And because we're going to go ahead and go through these and look at a couple different options, let's change this from intersect 1D. And we'll do the same thing. We'll go ahead and print this. So we might want to know the intersection where they have commonalities. Another unique word is union of 1D. So instead of intersect, we want to know all the values that are in both of them. So here's our union of 1D. When we run that, you can see we have 1, 2, 3, 4, 5, 6, 7. So it's all the different values in there. And one of the last words, we have 2 more to go, is we want to know what the set difference is. And so that's where you'll see that, if you remember set, we talked about that being what they call these things. So the set difference of a 1D array, when we run that, you can see that 1 is only in one array and 2 is only in one array. And if we want to know what's in array 1 but not in array 2, we might want to know what is in array 1 but not 2 and what's in 2 but not 1. And this would be the set X OR 1D on here. So we have the 4 different options here where we can do an intersection. What do they both have in common? We can do a union. What are all the unique values in both arrays? We can see the difference, what's in array 1 but not array 2, so set diff 1D. And then set X OR, what is not in 1 but is in 2, and what is not in 2 but in 1. So we dug a lot in NumPy because we were talking, there's a lot of different little mathematical things going on in NumPy. A lot of this can also be done in pandas, although usually the heavy lifting is left for NumPy because that's what it's designed for. Let's go ahead and open up another Python 3 setup in here. And so we want to explore what happens when you want to display this. This is where it starts getting, in my opinion, a little fun because you're actually playing with it and you have something to show people. And we'll go ahead and rename this. We're going to call this pandas and pyplot. So pandas pyplot, just so I can remember for next time. And we want to go ahead and import the necessary libraries. We're going to import pandas as PD. Now remember, this is a data frame, so we're talking rows and columns, and you'll see how pandas work so nicely when you're actually showing data to people. And then we're going to have NumPy in the background. NumPy works with pandas, so a lot of times you just import them by default. Seaborn sits on top of the matplot library. So sometimes we use the Seaborn because it kind of extends. It's one of the 100 packages that extends the matplot library. Probably the most common used because it has a lot of built-in functionality. Almost by default, I usually just put Seaborn in there in case I need it. And of course we have matplot library as pyplot, as PLT. And note we have as PD, as NP, as SNS, as PLT. Those are pretty standard. So when you're doing your imports, I would probably keep those just so other people can read your code and it makes sense to them. That's pretty much a standard nowadays. And then we have the strange line here. It says ampersand matplot library inline. That is for Jupyter Notebook only. So if you're running this in a different package, you'll have a pop-up when it goes to display the matplot library. You can, with the most current version of Jupyter, usually leave that out and it will still display it right on the page as we go. And we'll see what that looks like. And then we're going to go ahead and just do the Seaborn, the SNS.set, and we're going to set the color codes equals true. Let them just keep the default ones so we don't have to think about it too much. And we of course have to run this. The reason we run this is because these values are all set. If we don't run this and I access one of these afterward, it'll crash. The cool thing about Jupyter Notebooks is if you forgot to import one of these, you forgot to install it, because you do have to install this under your Anaconda setup or whatever setup you're in, you can flip over to Anaconda and run your install for these. And then just come back and run it. You don't have to close anything out. And we'll go ahead and paste this one in here real quick where we have car equals pd.read_CSV. And then we have the actual path. This path, of course, will vary depending on what you are working with. So it's wherever you save the file at. And you can see here I have like my OneDrive documents, Simplilearn, Python, data analytic, using Python, / car CSV. It's quite a long file. When we open that up, what we get is we get a CSV file, and we have the make, the model, the year, the engine, fuel type, engine horsepower, cylinders, and so on. And this is just a comma separated file. So each row is like a row of data. Think of it as a spreadsheet. And then each one is a column of data on here. And as you can see right here, it has the make, model. So it has columns for a header on here. Now, your Pandas just does an excellent job of automatically pulling a lot of this in. So when you start seeing the Pandas on here, you realize that you are already like halfway done with getting your data in. I just love Pandas for that reason. NumPy also has it. You can load a CSV directly into NumPy, but we're working with Pandas, and this is where it really gets cool, is I can come down here and I can print, you remember our print statement, we can actually get rid of it. And we're just going to do car head because it's going to print that out. The head is going to print the top values of that data file we just ran in. And so you can see right here, it does a nice printout. It's all nice and in line because we're in Jupyter Notebook. I can scroll back and forth and look at the different data. And just like we expected, we have our column, and it brought the header right in. One thing to note is the index. It automatically created an index 0, 1, 2, 3, 4, and so on. And we're just looking at the head. So we got 0, 1, 2, 3, 4. You can change this. You might want to just look at the top two. We can run that. There's our top two BMWs. Another thing we can do is instead of head, we can do tail. And look at the last three values that are in that data file. And you can see right here, it numbered them all the way up to 11,913. Oh my goodness, they put a lot of data in this file. I didn't even look to see how big the file was. So you can really easily get through and view the different data in here. When you're talking about big data, you almost never just print out car. In fact, let's see what happens when we do. If we run this and we just run the car, it's huge. In fact, it's so big that the pandas automatically truncates it and just does head plus tail, so you can see the two. So we really don't want to look at the whole thing. We'll go ahead and go back to, let's stick with the head, displaying our data. There we go. So there's the head of our data. It gives us a quick look to see what's actually in there. I can zoom out if we want, so you can actually get a better view. Although we'll keep it zoomed in so you can see the code I'm working on. And then from the data standpoint, we of course want to look at data types. What's going on with our data? What does it look like? Now this, you show when you're talking to your shareholders, they like to see these nice, easy to read charts. They look like a spreadsheet. So it's a nice way of displaying pieces of the chart. When we talk about the data types, now we're getting into the data science side of it. What are we working with? Well, we have make model, we have an integer 64 for the year. Engine fuel type is an object. If we go up here, you can see that most of them are it's a set manual, rear wheel drive. So they might be very limited number of types in there. And so forth. And it's either going to be a float 64, an integer, or an object is the way it's going to read it on here. And the next thing you're going to know is like your columns. And since it loaded the columns automatically, we have here the make, the model, the year, the engine, the size, all the way up to the MSRP. And just out of something you'll see come up a lot is whenever you're in pandas and you type in .values, it converts it from a pandas list to a numpy array. And that's true of any of these. So then you end up in a numpy array. So you'll see a little switch in there in the way that the data is actually stored. And that's true of any of these. In this case, we want car.columns. You have a total list of your car columns. And like any good data scientist, we want to start looking at analytical summary of the data set. What's going on with our data? So we can start trying to piecemeal it together. So we can do car, describe, and then what we'll do include equals all. So a nice panda command is to describe your data. If you're working with R, this should start looking familiar. And we come down here and you can see count. There's the make, the model, the year, how many of each one, how many unique values of each one, the top value of each one, what's most common, the frequency, the mean. Clearly on some of these it's an object, so it really can't tell you what the average is. It'd just be the top one's the average, I guess. The year, what's the average year on there? All this stuff comes down here. Your standard deviation, your minimum value, your maximum value, what's in the lower quarter, 50% mark, where's that line at, and what's in the upper 75%, the top 25% going into the max. Now, this next part is just cool. This is what we always wanted computers to be back like in the 90s instead of 5,000 lines of code to do this. Maybe not 5,000. All right, I built my own plot library back in 95, and the amount of code for doing a simple plot was, I don't know, probably about 100 lines of code. This is being done in 1 line of code. We have our car, which is our pandas. We generated that. It's our data frame. And we have .hist for histogram. That is the power of Seaborn. Now, it's still going to generate a numpy graph, but Seaborn sits on top, and then we can do the figure size. This is just so it fits nicely on the paper on here. And we do something simple like this, and you can see here where it comes up, and it does say matplot library and does subplots and everything. But we're looking at a histogram of all the different pieces in our database. And we have our engine cylinders. That's always a good one because you can see like they have some that they had a null on there, so they came out as 0. Maybe one of them had a 2-cylinder engine way back when. 4 is a common, 6 a little less common, and then you see the 8-cylinder, 12-cylinder engines. Boy, that's got to be a speedster or something. But you can see right here, it just breaks it down. So now you have how many cars with how many, whatever it is, cylinders, horsepower, and so on. And it does a nice job displaying it. You can see if you're working with your, you're going into your demo, it's really nice just to be able to type that in and boom, there it is. They can see it all the way across. And we might want to zero in and use like a box plot. And this time we'll go ahead and call the Seaborn, SNS, box plot. And we're going to go ahead and do vehicle size versus engine horsepower XY plot. And the data comes from the car. So if we run this, we end up with a nice box plot. You see our mid-size, compact, and large. You can see the variation. There's our outlier showing up there on the compact. That must be a high-end sports car. Large car might have a couple engines, and again, we have all these outliers and then your deviation on them. Very powerful and quick way to zero in on one small piece of data and display it for people who need to have it reduced to something they can see and look at and understand. And that's our Seaborn box plot, or our SNS.boxplot. And then if we're going to back out and we want a quick look at what they call pair plotting, we can run that, and you can see with the Seaborn, it just does all the work for you. It takes it just a moment for it to pull the data in and compile it. And once it does, it creates a nice grid. And this grid, if you look at this one space here, which is, you might not be able to see the small number, it says engine horsepower. This is engine horsepower to the year it was built, and it's just flipped. So everything to the right of the middle diagonal is just the rotation of what's on the left. And as you expect, the engine horsepower gets bigger and bigger and bigger as time goes on. So the year it was built, the further up in the year, the more likely you are to have a heavy horsepower engine. And you can quickly look at trends with our pair plot coming up. And look how fast that was. It took it a moment to process, but right away I get a nice view of all these different information, which I can look at visually and kind of see how things group and look. Now, if I was doing a meeting, I probably wouldn't show all the data. One of the things I've learned over the years is people, myself included, love to show all our work. You know, we were taught in school, show all your work, prove what you know. The CEO doesn't want to see a huge grid of graphs, I guarantee it. So what we want to do is we want to go ahead and drop the stuff that might not be interested in. And I'm not really a car person. Our guy in the back is, obviously. So you have your engine fuel type. We're going to drop that. We're going to drop market category, vehicle style, popularity, number of doors, vehicle size. And we have the axes in here. If you remember from NumPy, we have to include that axes to make it clear what we're working on. That's also true with pandas. And then we'll look at just what it looks like from the head. And you can see that we dropped out those categories, and now we have the make, model, year, and so forth. And we took out the engine fuel type, market category, etc. And this should look familiar to you now. When you start working with pandas, I just love pandas for this reason. Look how easy it is. It just displays it as a nice spreadsheet for you. You can just look at it and view it very easily. It's also the same kind of view you're going to get if you're working in Spark or PySpark, which is Python for Spark, across big data. This is the kind of thing that they come up with, and this is why pandas is so powerful. And we may look at this and decide we don't like these columns. And so you can go in here and we can actually rename the columns. Simple command, car equals car, rename. Columns equals engine horsepower equals horsepower. This is just your standard Python dictionary. So it just maps them out. And instead of having like the lengthy here, we had engine horsepower. We just want horsepower. We don't need to know it's the engine horsepower. Engine cylinders, we don't need to know that it's for the engine, because there's only one thing we're describing if we're talking about cars, and that's cylinders. And we'll go ahead and just run this. And again, here's our car head, and you can see how that changed. We have model year and horsepower versus model year, engine horsepower, engine cylinders, and just cylinders. Again, we want to keep reducing this so it's more and more readable. The more readable you get it, the better. And of course, we can also adjust the size a little bit so that when it prints out, instead of splitting it on 2 lines, we get like a single line. We can do that also. That's just your control mouse up or plus sign you use in Chrome. That's a Chrome command. And if you remember from NumPy, we had shape. Well, Pandas works the same way. We can look at the shape of the data. So we now have 11,914 rows and 10 columns. So you see some similarities because Pandas is built on NumPy. And questions that come up just like you did in NumPy, we might want to know duplicate rows. And so we can do car. And look at this switch here. We're doing a selection. This is a Pandas selection with the brackets. But we want to select it based on car.duplicated. So how many duplicates on there? So it's starting to look a little bit different as far as how we access some of the data on here. This can be a logical statement. And we get the number of duplicate rows. We have 989 rows by 10 columns again. And this is one of those troubleshooting things that we end up doing a lot, more than we really feel like we should. We might go ahead and do like a car count just to see how many rows we're dealing with. And then right after that, we might want to go ahead and say, hey, let's drop duplicates. So remember we did all the duplicates on there. So car equals car dot drop duplicates. And then we can print the head again. We'll just do car head here. And you can see the data on there looks the same as before. And just note that we did car equals car dot duplicates. There are commands in here where you can do, where it changes the actual value. And it works on some of them and not on others depending on what you're doing. But by default, it always returns a copy. So when we do this, we're reassigning it to car. And you can see it's the same header, but we want to go ahead and do count and see how the count changes. Let's go ahead and run this. And you can see here, instead of 11,914, we have 10,925. So we've removed about 100 cars that were duplicated, just slightly under 100 there. And then as we're prepping our data, we might want to know car is null. So it's going to count the values of null, and then we want to sum that up. And when we do that, we do the car is null function dot sum. We end up with HP, the horsepower is 69 have null values, and 30 have cylinders have null values. Now, if you don't put the sum at the end, it's just going to return a mask with the true false of is it null or is it not, by 0 and 1. So you're summing up the ones underneath each column. And this, of course, then you have to decide what you're going to do with the null values. There's a lot of different options. It might be that you need to put in the average or means. Maybe you want to put in the median value. There's a lot of different ways to fill it. Usually when you first start out with the data, a lot of them you just drop your null values. And you can see here car.drop NA, which is equal to all. And then we're going to go ahead and count it. And you can see that we've dropped almost another 100 values. So from 10,925 to 10,827, maybe 75 or so values. So we cleaned this is really a big part of cleaning data. You need to know how to get rid of your null values, or at least count them and what to do with them. And of course, if we go back to counting our null values, we should now have null values. There we go. And you'll see there's 0 null values. I don't know how many times I've been running a model that doesn't take null values and it crashes, and I just sit there and look at it trying to get, why did that crash? It should have worked. It's because I forgot to remove the null values. So we've been jumping around a lot. We're going to go back to finding outliers. And let's go ahead and bring that back into our Seaborn. And if you remember, we did a box plot earlier. This time we're going to do a box plot just on the price. And you can see here our price value, and we have the deviation with the two thinner bars on each side of the main value. And then as we get up here, we have all these outliers. In fact, we have one way out here that's probably a really expensive high-end car is what we're looking at. If you were doing fraud analysis, you would be jumping on all over these outliers. Why are these deviation from the standard? What are these people doing? Again, this is probably, like I said, a really high-end expensive car out here. That's what we're looking at. And we can also look at the box plot for the horsepower. We'll put that in down here and run that. And you can see again, here's our horsepower, and it just jumps, and there's these really odd, huge muscle cars out here that are outliers. And we're going to jump into making this a little bit more, as you start displaying your data or your information to your shareholders. We're going to look at plotting a histogram for the number of cars per brand. And the first thing we want to go ahead and do is we have with our car, go back over here, here we go. We have our make value counts, largest plot, and we want to do a kind equals bar, figure size 10.5. And right off the bat, we jump up here and we see Chevrolet, it's going against, what was it? It's figure ratio, the value counts, and we want the largest value. So here's our value counts and compared to what the different cars are. Chevrolet puts out a lot of different kinds of cars. I didn't realize that they made that many cars or different types. And then for readability, let's go ahead and add a title, number of cars by make, number of cars, and make. If you had looked at this the first time, you would have been like, well, what the heck am I looking at? Well, we're looking at the number of cars by make. And then you can see here, now we're talking about the type of cars and the different ones were put out. Lotus, I guess, only had a few different kinds of cars over there. Very high-end cars. And then as doing data analytics and as a data scientist, one of the things I am most interested in is the relationship between the variables. So this is always a place to start. We want to know what's going on with our variables and how they connect with each other. So the first thing we're going to do is we're going to go ahead and set a figure size because we want to make sure it fits our graph. We'll just go ahead and set this one plot figure set to figure size 2010. If you never use the matplot library, which is sitting behind Seaborn, whatever is in the PLT, this is what's loaded. It's like a canvas you're painting on. So the second you load that PyPlot as PLT, anything you do to that is affecting everything on it. And then we want to go ahead, since we're using Seaborn, we'll go ahead and create a variable C for relationships or correspondence, and car.corr. That's a correlation in Seaborn on top of pandas. Again, one line and you get the whole correlation on there. And because we're working with Seaborn, let's put it into a nice heat map. If you're not familiar with heat maps, that means we're just using color as part of our setup. So we have a nice visual. And we can see here that the Seaborn connected to the pandas prints out a nice chart. We'll talk a little bit about the color here in a second. It prints out a nice chart. This is a chart I look at. As a data scientist, these are the numbers I want to look at. And we'll just highlight one of them. Here's cylinders versus horsepower. The closer to 1, the higher the correlation. So 0.788. Pretty high correlation between the number of cylinders and how heavy the horsepower is. I'm betting if you looked at the year versus horsepower, we can just look at that one. Here's year and horsepower. 0.314, not as so much, but if you combine them, you don't actually add them. But if you combine them, you'll start to see an increase in horsepower per year and cylinders. You could probably get a correlation there. And just like 0.78 is a positive correlation, you might notice if we look at cylinders, or let's look at horsepower and mileage. So if we go here to horsepower to mileage, you get a nice negative. We'll do cylinders, that's a bigger number. With cylinders to the miles per gallon, it's a minus 0.6. So it's a negative correlation. The closer to -1, the more the negative correlation is. And then the chart you would actually show people is a nice heat map. This is all our colors, and it's just those numbers put into a heat map. The darker the color, the higher the correlation. You can see straight down the middle, obviously the year correlates directly with the year, horsepower with horsepower, and so on. That's why it's a 1. The closer to the 1, the higher the correlation between the two pieces of data. Now, this is a good introduction. Pandas goes way beyond this. Most of the functionality in NumPy, since Pandas sits on it, is also in Pandas, and then it even has additional features in it. And we use Seaborn pretty extensively sitting on top over our PyPlot. So keep in mind that our PyPlot has a ton of other features in it that we didn't even touch on in here. We couldn't, even if you had a sole course in it, there's just so many things hidden in there depending on what your domain you're working on. But you can see here, here's our Seaborn and here's our Matplot library. That's all our graphics that we did. And then the Seaborn works really nicely with the pandas. We really like that. So that wraps up our demo part for today.
Let's learn about data manipulation in R. And here we will learn about dplyr package. And when we talk about this dplyr package, it is much faster and much easier to read than base R. So dplyr package is used to transform and summarize tabular data with rows and columns. You might be working on a data frame, or you might be getting in a inbuilt R data set, which can then be converted into a data frame. So we can get this package dplyr by just calling in library function. And this can be used for grouping by data, summarizing the data, adding new variables, selecting different set of columns, filtering our data sets, sorting it, selecting it, arranging it, or even mutating. That is basically creating new columns using functions on existing variables. So let's see how we work with dplyr. Now here I can basically get the package here. So I can just say install.packages dplyr. Now we already see the package here, which is showing up. So I will just select this one. I can do a control enter, and that will basically set up the package dplyr successfully unpacked. So that is done. Now you can start using this package by just doing a library dplyr, and this was built. It shows me my version of R. So let's also use a inbuilt data set, that is New York flights 13. So we can do install.packages, and that will search and get that relevant data set. I can again call it by using library function. Now once that is done, we can look at some sample data here by just doing view flights, and that shows me the data in a neat and a tabular format, which shows me year, month, day, departure time, scheduled departure time, and so on. Now we can also do a head to look at some initial data, which can help us in understanding the data better. So what is this data about? How many columns we have? What are the data types or object types here? It shows me how many variables we have. So this is fine. Now we can start using dplyr, and in that we can use, say, filter function if we would want to look in for specific value. Now here we have the column as month, so I will do a filter. Now I'm creating a variable f1. I'm using the filter function on flights, which we already have. And then what we can do is we can basically look at the month, where the month value is 07. So let's look at that. And this one, you can do a view on F1, which shows me the data wherein you have filtered out all the data based on month being 7. So this is a simple usage of filter. We can take some other example. We may want to include multiple columns. So we can say F2 filter flights, and here we will say month is equal to 7, day is 3, and then look at the value of F2 if you are interested in seeing this. And that tells you the month is 7 and day is 3. You could also look into a more readable format by using view on F2, and that gives me my selected result. So we are just extracting in some specific value. We can keep extending this. So here we can say flights is what we would want to work on. I'm using the filter function, so I can straight away instead of creating a variable and then doing a view, I can also do a view in this way. I can just pass in my filter within the view, and within this I'm saying filter. I would want to look at the flights, month being 09, day being 2, and origin being LGA, and then that shows me the value here. And obviously you can scroll and look at all the columns, and if you see the origin column, it shows the selected value. So now we have filtered our data based on values in 3 different columns. Now what we can also do is we can use and, or we can use or operators. So I could have done this in a little different way. So I could have said head, which shows me initial result. I will do a flights. So within my head function, I'm passing in this. And what does that contain? So you are saying flights. And in this flights data set, you would want to pick up the month being the column. So we use the dollar symbol here. We give in a value, and I'll say and I'll again say flights, wherein I will select the day being 2 and remember, when you talk about and, it is going to check if all the values are met true. So then you say flights origin LGA and you look at the value. So in this way I can filter out specifically multiple values by specifying columns. Now we could have done it in this way. We could have created a view, or we could have assigned this to a variable and then done a view on that, where we could have selected month being day and origin. Or you can be more specific in specifying all the columns. It makes the code more readable. So let's look at the values, and here you are looking at head, which shows me based on month, day, and then you can look for further columns for other variables, that is origin being LGA. Now what we can also do is we can do some slicing here to select rows by particular position. So I can say slice, and I would want to look at rows 1 to 5, and I can do this. So you can always assign or look at the view of this. I can just do here. So when I did a slice 1:5, it shows me my entries for 1 to 5. Now similarly, we can do a slice 5 to 10, and now you're looking at 5 to 10 values. So you can always look at the complete data, and then you can slice out particular data. Now mutate is usually a function which is used when you would want to apply some variable on a particular data set, and then you would want to add it to your existing data frame, or you would want to add a new column. So this is where you use mutate, which is mainly used to add new variables. So let's see how you work on mutate. So it's pretty simple. So you create a variable over delay. Now I would want to do a mutate so that it adds a new column. So I'm selecting my data, which is flights. I will call the new column as overall delay, and then basically I can look at overall delay being arrival delay minus departure delay. So let's create this, and let's look at view of this, which shows me, or which should show me, my new column, which is overall delay, which was not in my original data set. So you can anytime do a head on this one to compare the value. So this one shows me arrival delay, and then there are many other variables. What you can also do is you can do a view, and you could have just look at flights if you would want to compare. So you can look at the flights, and this one would not have any overall delay column. So it basically shows me 19 columns only, what we see here. And if you do a view on overall delay, then that basically shows me 20 columns. So we know that the new column has been added to this overall delay. So if you would want to work with 20 columns, you will use overall delay. If you would want to work with your original data set, you will use flights. Now you can also use a transmute function, which is used to show only the new column. So we can do an overall delay, and at this time we will say transmute, we will say flights, overall delay. The computation remains same, but at this time, if I look at view on overall delay, it only shows me the new column. So sometimes we may want to compute result based on two variables or two columns and just look at the new value, and then we can decide if we would want to add it to our existing structure. Now you can also use summarize, and summarize basically helps us in getting a summary based on certain criteria. So we can always do a summarize, and what we can do is we can look at our data and we can say on what basis we would want to summarize this particular data. So we can do a summarize function. Now summarize on flights, I will say average air time, and I would want to calculate an average. So for that I'm using an inbuilt function called mean. I will do that on airtime column. So let's look at flights once again, and here we can see there is arrival time, not airtime, sorry, arrival time, and we would want to do some average on this particular data. We would want to summarize this. So what I'll do is I will use the summarize function. I will say average airtime, and this one I will look at mean of airtime. So let's see if there is a airtime column. I might be, let's look at this one, arrival delay, and yes, we have an airtime. So we were actually looking at summarizing based on airtime, not the arrival time. So airtime is how much time it takes in air for this particular flight, and we will want to use the summarize function, not the transmute. So summarize flights, average airtime, and this one we will calculate the mean of average airtime, and I will also do a NA removal, which is I'm saying true. So let's do this, and that basically shows me the average airtime is 151. I can also do a total airtime where I'm doing a summation of values, or I can get the standard deviation, or I can basically get multiple values such as mean. I can say total airtime where I'm doing a summation, and then I can look at other values, which is if you would want to put in standard deviation here, you could do that. So let's look at the result of this summarize, and this basically allows me to get some useful information which is summarized based on a particular function such as mean, sum, standard deviation, or all three of them. Now let's look at grouping by. So sometimes we may be interested in summarizing the data by groups, and that's where we use the group by function. So we can always use the group by clause. Now here we are taking a different data set. So we will say, for example, let's look at head of empty cars, and that is basically my data set on empty cars. Now that shows me the model of the car, it shows me mileage, cylinder power, and your horsepower, and various other characteristics or variables in this particular data set. So here we can say let's do a grouping by gear. So there is a column called gear, so I will call it by gear. I will look at my data set, and then what I'm using here, which you see with these percentage and greater symbol, is called piping. So that basically feeds your previous data frame into next one. So this is sometimes useful, and you can get this by just saying Control Shift and M, and you can then use this. So we are going to have piping. So I'm saying empty cars. Now this is my original data set where I did a head, or I could have done a view on this one if you would want to see it in a more readable format, and that basically shows me the data. So we are using a different data set, so I want to group it by the gear column. So I'm going to call it by gear, and this one takes my data that is empty cars. I'm using the piping, and then I'm saying group the data based on gear column. That's done. Now let's look at the value of by gear, or you can always do a view. So remember, whenever you're doing a group by, it is giving you a internal object where your data is grouped based on a particular column. So we can look at the values here. You can do a view that shows you your data grouped based on a particular column. Now I can again use the summarize function where I would want to now work on the new one where it was grouped based on gear. So I'm doing a summarize, and here I'm going to say gear 1, which will be having the value of summation on the gear column. And then I'm saying gear 2, which is mean. Well, you could give some meaningful names to this. And let's look at the value of this one, where we are basically now looking at the values, which is sum and mean values based on the gear. Similarly, we can look at different example. So we can say by gear, and I'm again using piping. But earlier we had taken gear, we had grouped the data, and we called it by gear. So we took our original data set empty cars, but now within this particular data, which was grouped by gear, I will take this data set, I will use the piping, and I will summarize it where I am saying within this particular data set, I would want to get the sum or I would want to get the mean, and then you can look at the values. So what you're doing is you are either looking at your original data set or you're looking at the data which was already grouped, and then you can look at the values. Now here what we can do is we can group by cylinder. Say might be you are interested in looking at data which is summarized based on the cylinder column. You can do that. And then for this by cylinder, I'm doing a piping where I'm using the summarize function, and summarizing will then be done based on the mean values of the gear column or the horsepower. So let's do this, and then you can basically look at the value. At any point you may want to look at the data set again, so just do a head and you can look at what does the value contain, and by cylinder or by gear, and do a head, and it gives you the value. So you can always do some summarizing or grouping in these ways. Now here we are going to use sample underscore n function and sample underscore fraction for creating samples. So for this, let's take the flights data set again, and we would want to get 15 random values. Now that is done, and it shows me 15 rows with some random values from the data. What you can also do is you can do a portion of data by using sample underscore fraction, and here I'll say flights, I'll say 0.4, which will return 40% of the total data. So this can be useful when you are building your machine learning, where you would want to split your data into training and test. Might be you are interested in some portion of the data, so you can do this, which is very useful function, and then you can look at the value of that. Now what we can also do is we can use a range function. So like we were doing a grouping by, or we were trying to pull out a particular column. So in the same way, we can use a range, which is a convenient way of sorting than your base R sorting. So for a range function, let's do a view based on a range. So we will work on the flights data set which we have, and here what we would want to do is we would want to arrange the flights data set which is based on year and departure time, and we are doing a view out of it. So that basically gives me the data which is arranged based on your year and departure time. Now I can do a head to give me some highlighting of that data. Now the piping operator, what we are using, can be used in these ways also. So here I will say df, I will just assign the data set empty cars to it. Let's look at the df, which has basically your different models. You can obviously look at the head or view of it to look at useful information. We can also go for nesting options, which can be useful. So we are creating a variable called result here. Now that has the arrange function. So what does this arrange function do? So when we would want to use arrange to sort the data, so I would want to sort the data, but what data would I sort? So I will use sample n, which will give me some portion of the data or some sample data. Now, what is that sample data? So here we are using nesting. That is, earlier when we did a sample, we just said data and how many random samples we want. But instead of giving that, what we are going to do is we are going to use filter here. Now this filter will work on DF. So filtering will happen based on the mileage, which is greater than 20. I will say size is 5, and I would want to basically arrange this in a descending order. So I'm using the des on this particular mileage column. By default, it is always ascending. So let's get the result out of this, which will basically show me the mileage details in a descending order. So this is my data frame, and now we can look at the result, what we have created. So just do a view or do a head and look at the view. So here you see mileage, where the highest value is on the top, and we were only interested in 5 values in our random sample. So that's why when you did a view, it shows your 5 values, and it shows in a descending order based on mileage. So we have not only used an inbuilt function, we have not only arranged the data, that is, we have sorted the data, but we have sorted the data based on a descending order on a particular column. We have said the value should be greater than 20, and we have also said we just need 5 random samples. Now let's look at some other examples. So you can always do a multi-assignment. So I can say filter, wherein I'm going to use DF, which was assigned empty cars. I'm going to say mileage should be greater than 20. Then I say B, which is going to get a sample out of A, and I just want 5 random values. So let's look at that. So we have B, which is going to get a set of 5 values from A. Now I will create a result variable which will arrange B, which is sample data, in a descending order. Now let's look at the result of this, and that basically shows me what we were seeing earlier. So you can do a multi-assignment where you can create a variable, get a sample out of it, and then basically whatever is that result, you can arrange that or sort that in a descending or by default ascending order. So same thing, we can do it using pipe operator. So piping. So here I will say result. I'm passing in my DF, that's the data set. I'm using piping, and which basically tells what you need to do on this particular data set. So I'm going to filter out the data based on mileage 20. Then I'm going to push that or forward it to get the random sample, and whatever is this random sample is going to be pushed. So you are arranging this in a descending order. So this is one more way of doing it, and then basically you can look at the result. So these are some simple examples where you can use your dplyr with multiple assignments, or using your nesting to filter out the data. You can also do a range, which is to sort the data. You can get some random samples out of it. You can summarize the data. You can also summarize the data based on 1 or 2 or multiple columns. And you can use some inbuilt functions to summarize the data based on some functions which are applied on the variables or on the columns. You can transmute it, where you would be interested in only looking at one column. You can mutate it, where you want to add a new column. You can slice it, and you can give the conditions where you can say and or to filter out the data. So what we can also do is, on this particular data set which we have, say for example DF, where I have my data. Let's look at this one, and if I just do a DF at this point, it shows me my data set. And if you would be interested only in particular column, then your dplyr also allows you to, either we can do a filter or we can simply do a select. Now for selecting, we can choose our data. So for example, I'll say df underscore, I'm interested in mileage, I'm interested in horsepower, might be I'm interested in your cylinders in this, And for this one, what I can do is when I would want to do a select, I can basically say selected df. Let's call it some name. I can say Control Shift M, which is for piping. And then basically what you can do is you can do a select and you can choose your columns. So I was interested in mileage, I was interested in horsepower, I was interested in cylinder, and here what I'm doing is I'm using a select where I can look at the new data frame. So let's do this, and I'm sorry, here we will have to give it df. This is where you are passing in your data. Yeah, now this one is done, and we can look at the value of this one by just doing a df or head on df underscore mileage horsepower cylinder and look at the selected result. So you can be looking at selective columns. I could have done this filter, but filter will always look for a condition. Say your mileage is greater than 20, or might be your cylinders are more than 4 or something else. But when you do a select, you are selecting specific columns. So view always gives you all the columns, head gives you highlight, but then select can be useful when we are interested in looking at only specific data. So this is how you can use dplyr for manipulation, for your data transformation, for basically filtering out the data by selecting particular data and then working on it.
Imagine you are trying to figure out what most people in your neighborhood love to eat for dessert. You could ask everyone, right? But how do you make sense of all of these answers? That's where statistics comes in. It's like your personal data detective, helping you gather, organize, and analyze all the information to spot patterns and trends. With statistics, you can easily discover if most people love ice cream or if brownies are the hidden favorite. All about turning numbers and facts into useful insights, helping you make smarter decisions and understand the bigger picture. Hello guys, welcome back to Simplilearn's YouTube channel. And today I will walk you through the basic understanding of descriptive statistics, inferential statistics, frequency statistics, and kurtosis statistics, and more. Then I will take you through the differences among the various types. By the end of the video, you will know all you want to know about statistics and its types. Without any further delay, let's get into the video. First things first, let us understand what statistics actually is. Statistics is a branch of mathematics that help us collect, organize, and analyze data, understand patterns, trends, and make decisions. It's like having a big group of information and breaking it down to learn something useful. For example, if we survey 100 people about their favorite fruit, statistics help us figure out what most people like, what fruit is least liked, and how confident we are about these results here. After we have a basic idea of statistics, let us get into the various types of statistics. The first one is descriptive statistics. Descriptive statistics is a branch of statistics that focuses on summarizing and describing the main features of a dataset. This is further divided into measures of central tendency, measures of spread, and data distribution. Let's start with measures of central tendency, and this is further divided into three types. The first one is mean, the average of all data points. The second one is median, the middle value when data is arranged in order. The third one is mode, the most frequently occurring value. Let's break down the measures of central tendency, mean, median, and mode with an example. Imagine you have the following scores from a math test taken by 7 students: 72, 85, 91, 89, 85, 76, and 90. Now you want to calculate the mean. Now, to calculate the mean, you have to add up all the scores and divide by the number of students. Therefore, the mean is 84. It means the average scores of the students is 84. Now, moving on to find the median. To find the median, we need to take the same example and we have to arrange the scores in ascending order. The median is the middle value, so in this case, the middle value is 85, since it is the fourth number in a list of 7. So, half of the students scored above 85 and half scored below 85. Now, moving on, the next is to calculate the mode. The mode is a score that appears most often. So we take the same example and we see that 85 occurs twice more than any other score. So the most common score in the test is 85. Now moving on to the next, that is the measures of spread. Unlike central tendency, which tells you whether the data is centered, spread tells you how scattered the data is. It has three components: range, variance, and standard deviation. Range, it is the difference between the highest and the lowest values in the set. And variance, it measures how much each score deviates from the mean. And standard deviation, it is the square root of variance. Let's use an example to understand measures of spread, range, variance, and standard deviation, which help us understand how spread out or dispersed the data is. Consider the test scores of 5 students. Now, we want to find the range. Therefore, the range is the difference between the highest and the lowest values in the dataset. That is, 85 minus 65 is equal to 20. The scores span a range of 20 points from 65 to 85. Now moving on, we want to find the variance for the same example. The variance measures how much each score deviates from the mean on average squared. First, we calculate the mean. So to calculate the mean, we take the total of the scores divided by the total number of scores, and that is equal to 75. Next, we find the square differences from the mean for each score. And here it is. 65 minus 75 whole square is equal to minus 10 whole square, and that is equal to 100. And in this way, we perform the same for each score. Now, the sum of these square differences divided by the number of data points is the variance. And that is taking the total of the squared differences divided by 5, that is equal to 50. The variance is 50, meaning that on average the square differences from the mean are 50. Now moving on to find the standard deviation. The standard deviation is the square root of the variance. It tells us how spread out the data is in the same units as the original data. The standard deviation is the root over of 50, that is approximately equal to 7.07. Now moving on, the third measures of division is data distribution. Let us use an example to explain data distribution, which tells us how data points are spread or organized across a range of values. Imagine you have the following test scores for 20 students. One way to understand data distribution is by creating a histogram. The histogram groups the scores into ranges or beans and shows how many scores fall into each range. For this dataset, we could create bins like 50 to 60, there are 3 students. 61 to 70, there are 7 students. And 71 to 80, we have 5 students. And in this way, 81 to 90, we have 3 students. And 91 to 100, we have 2 students. Now moving on to the normal distribution, the second one under the data distribution. In some cases, data follows a normal distribution which forms a bell-shaped curve. And this means most data points are around the mean with fewer data points as you move away from the mean in either direction. And normal distribution curve, it means most data points are around the mean with fewer data points as you move away from the mean in either direction. In a normal distribution, the mean, median, and mode are the same. Data is symmetrically spread around the center. Now moving on, in our example, the scores are somewhat concentrated around 70 to 80, but the distribution is not perfectly normal because there are more students scoring higher, that is the right skew. Therefore, skewed distribution, if a data set is not symmetrical, we have skewed distribution. And that is further divided into two: the right skew, that is the positive skew, and the left skew, that is the negative skew. In right skew, more data points are on the lower side with fewer higher values. And in the left skew, more data points are on the higher side with fewer low values. Moving on, in our test score example, we have a slightly right skew distribution because there are more students with lower scores, that is to 55 to 70, compared to higher scores, that is 90 to 100. And this is known as right skew distribution. Now, moving on to the second type of statistics, that is inferential statistics. It uses sample data to make predictions and generalizations about a larger population, allowing researchers to draw conclusions beyond the immediate dataset. Inferential statistics comprises several techniques for drawing conclusions. Here are some common types. hypothesis testing, second one is confidence intervals, and the third one is regression analysis. Now moving on to hypothesis testing. Hypothesis testing is a statistical method used to determine whether there is enough evidence in a sample of data to support a specific claim about a population. Let's work through the process of testing whether a new teaching method improves student test scores, breaking it down step by step with some explanations to make it easier to follow. Step number 1 is hypothesis. We always start by stating what we want to test. In this case, we want to see if the new teaching method helps students score better compared to the traditional one. To do this, we set up two hypotheses. H0, that is the null hypothesis, and that is the average test score with the new method is equal to 75. This means that the new method has no impact and there is no improvement in the test scores. H1, that is the alternative hypothesis. The average test score with the new method is greater than 75. This suggests that the new method does improve test scores. In simple terms, we are trying to figure out if the new method makes any difference compared to what we normally expect, which is a score of 75. Now moving on to the next step, that is significance level. Next, we need to decide how confident we want to be in our conclusion. The significance level helps us measure this. It tells us the probability of mistakenly rejecting the null hypothesis when it's actually true. Type 1 error. A common choice for this significance level is 0.05 or 5%. This means we are willing to accept a 5% chance of making a mistake by rejecting the null hypothesis when it is true. So we said alpha is equal to 0.05. Step 3. Collect data. Now we need some actual data to test. Let's say we taught 30 students using the new method and their average test score came out to be 78. This is our sample data and we will compare it to the population mean, which is 75, the traditional method score. Now moving on to the next step, that is perform statistical test, the t-test. With the data in hand, we need to perform a statistical test. For this test, we will use a t-test which will help us compare the sample mean 78 to the population mean 75. The t-test checks if the difference between the two means is significant or if it could just be due to random chance. Moving on to the next step, that is the p-value. The p-value from the t-test is the number that tells us the probability of getting the sample data if the null hypothesis is true. Let's say the t-test gives us a p-value of 0.03. This means there is 3% chance of seeing this level of improvement if the new method doesn't actually improve scores. Now moving on to the last step, that is decision. Now we compare the p-value to our significant level alpha. If the p-value is smaller than 0.05, it means the results are statistically significant and we can reject the null hypothesis. In our case, the p-value is 0.03, which is less than 0.05. So we reject the null hypothesis. Now moving on to the second part, that is confidence interval. A confidence interval is a range that tells us how sure we are about an estimate from sample data. It gives a range of values whether the true member likely false. For example, suppose you survey 100 men in a city to estimate the average height. The average height from your sample is 175 centimeter and the standard deviation is 10 centimeter. You want to calculate 95% confidence interval to estimate the true average height of all men in the city. Now let's move on to the steps. Sample mean. The sample average is 175 centimeter. The standard error is calculated as 10 by root over of 100, that is equal to 1. Now, the confidence interval formula for a 95% confidence level use the critical value 1.96. The confidence interval is 175 plus minus 1.96 into 1. That is equal to 175 plus minus 1.96. The result, the 95% confidence interval is 173.04, 176.96. You can be 95% confident that the true average height of all men in the city is 173.04 centimeter and 176.96 centimeter. Now moving on to the third one, that is regression analysis. Regression analysis is a way to understand how one thing affects another. For example, if you own a shop and want to know if spending more on advertising increases your sales, you can use regression analysis. In this case, advertising spending is a thing you control, that is the independent variable, and sales is what you want to predict. By analyzing the past data, regression helps finding a pattern or relationship. For example, you might discover that for every $100 you spend on advertising, your sales increase by $200. This means you are positive relationship between advertising and sales. Now, if you plan to spend $500 on advertising, you can predict an increase in the sales by applying that relationship. Regression analysis gives you a formula or model to make such predictions based on the pattern you identified. In short, regression helps you logically predict how changes in one factor affect another. Next, I will be talking about is frequency statistics. In statistics, frequency refers to how often something occurs in a dataset. It simply counts how many times each value or event appears. Frequency is useful for understanding the distribution or pattern of data. Let's say you surveyed 10 people about their favorite food and the results were 4 people chose apples, 3 people chose bananas, 2 people chose oranges, and 1 person chose grapes. Here's how frequency works. Apples have a frequency of 4 as 4% chose it. Bananas have a frequency of 3, oranges have a frequency of 2, and grape has a frequency of 1. In this simple example, frequency helps you see that apples were the most popular fruit choice, while grapes were the least popular. Last but not the least, let's talk about kurtosis statistics. Kurtosis is a statistical term that describes the shape of the distribution of data, especially how the data is concentrated in the tails. It helps us understand if the data has more or fewer extreme values compared to a normal distribution. It is further divided into high kurtosis and low kurtosis. High kurtosis has more extreme values, and in low kurtosis, the data has fewer extreme values. In short, high kurtosis means more extreme heights, while low kurtosis means more consistent, evenly spread heights. By now, you be curious to know about the differences among all the types of statistics. So here we go. Differentiating them on the basis of purpose. Descriptive statistics summarizes the main features of a dataset, for example, mean, median, and standard deviation. Inferential statistics makes predictions or generalizations about a population based on sample data. Frequency statistics counts when specific values or events occur in the dataset. Kurtosis describes the shape of the distribution, focusing on the tails and extreme values, differentiating them on the basis of data focus. Descriptive statistics deals with the entire dataset at hand. Inferential statistics uses a sample to infer conclusions about a larger population. Statistics focuses on the frequency of individual values or categories. Kurtosis focuses on whether the data has many or few extreme values. Now differentiating them on the basis of common metrics. In descriptive statistics is the mean, median, mode, and standard deviation and range. In inferential statistics, it is hypothesis testing, confidential intervals, regression analysis. In statistics, it is frequency counts, frequency tables, histograms, bars, and charts. In kurtosis value, high kurtosis is equal to more extreme values and low kurtosis is equal to fewer extremes. Now, differentiating on the basis of complexity. Complexity in descriptive statistics is simple and straightforward, summarizes the observed data, and in inferential statistics it is more complex, and in statistics it is simple counting and displaying of occurrences. Kurtosis requires statistical analysis to determine the distribution's tailedness. Now finally, differentiating them on the basis of visualization. Descriptive statistics, it is the box plots, pie charts, and summary tables. Inferential statistics, it is confidence intervals, regression lines, p-values, and more. And in statistics, it is bar charts, histograms, frequency tables. And kurtosis, it is histograms, distribution plots to visualize outliers. So here is a question for you guys. I hope everyone will comment your answers in the chat section and let's see how many of you really understood the topic. So the question is, which of the following is not a measure of central tendency? And the options are mean, median, mode, and standard deviation. Participate in the quiz and I hope to see your answers in the comment section. We will reply to whoever provides the correct answer, and the wrong answers will be corrected for sure. I will provide you 1 minute to write your answers in the comment section.
So window, here we have some data set. So we have row ID, order date, ship date, etc. So these are the rows over here. Let's quickly select the entire data set and remove any filters that we have. So the filters is gone, and at the last you can see country, region, product, category, subcategory, and extending further we have sales data, quantity ordered, discount, and profit. So now let's proceed and try to build one single dashboard. Okay, now imagine yourself in a situation where you're working for this particular store or a company which sells products, and you have a team meeting with leadership, and you are supposed to be hunting for simplicities in complexities, and you need to present an interactive dashboard which gives a visual representation of what exactly is happening with the company, the sales, the quantity ordered, profit, etc. Right? And if you show this particular data set as it is in the form of named rows and columns, your leadership might not be able to understand it, or they might not be able to justify what exactly needs to be done in the future to keep the numbers same or improve the sales, right? So in that scenario, an interactive dashboard could be beneficial. So in today's session, we're going to create the same and creating a chart, that is an interactive chart, or a dashboard which is interactive. Everything lies on one single point, that is the pivot tables and pivot charts. If you're good with pivot tables and pivot charts, you can create interactive charts, you can create interactive dashboards, and much more. So the process is simple, but in case if you need a quick overview of how exactly a pivot table is created or performed, then you can check out the link in the description box below, which will give you a complete detailed description and to understand how to create a pivot table and a pivot chart in real time and move further. Right? Now we will continue with this particular topic for today, which is creating a dashboard. Now click anywhere in the cell, select the entire dataset using Ctrl A, and go to Insert option over here and choose Pivot Table. Right? From the table range should be the option. Here you can see the table range has been selected, and you also have two more options which will help you understand where exactly to create your pivot table. So we will be creating that in a new worksheet. So click on a new worksheet and press OK. There you go. You have the pivot table here. And let's say we want a few charts. So here we have a region-wise sales, country-wise sales, and shipment majorly used, subcategory, category, segment, and let's say we also want quantity wise, country and quantity, right? Or let's say, okay, country and quantity. So how many number of orders basically you receive from each country, right? So let's say we want all these charts. Now how many number of charts do we have? 1, 2, 3, 4, 5, 6, and 7. Remember, creating a chart which is interactive relies on pivot table. Now, so far we have created one pivot table or one pivot chart or one pivot sheet, but we want 7 pivot charts. How to do that? It's really simple. Just hold Ctrl and drag that sheet, and you have a new pivot chart, right? You can do that few more times. 7. So we have 7 pivot tables as we required. There you go. And now let's get back to the first sheet and let's see the first option we are looking for. So we want region-wise sales, right? We have 5 different regions: North, South, East, West, and Central. And we want region-wise sales in a pictorial way. For that, let's go to the options over here. We have the row names or the metadata. You can drag region into either columns or rows, wherever you want. I'll choose, you can just drag and drop it in the columns. And now go back to sales, and you can drag sales to rows, sales in each region, right? Now you can go back to this particular pivot table, go to home, eliminate any, and go to pivot table analyze, and here you can see pivot chart. Click on that, and now you have all charts window on your desktop, screen. You can choose the one which you feel is good, right? So I'll prefer a bar chart, column chart here. Click on OK, and there you go. Now you can edit this particular data set and chart, and you can also remove any of the things you don't want. So for example, I don't want legends, so I'll remove legends, and this is what I have here. You can also edit from a few more things, right? Now I can simply copy this particular chart and go to the dashboard. So let's create a new sheet and name it as dashboard. Margin center. You can add a color. So now here you can paste the first chart. Now you can rename this chart title. So you can rename this as region wise sales. So therefore you have that first chart over here. You can also increase or decrease the size of the chart by just dragging the corner points. And let's go to the second pivot table. We have the second pivot table right here. What was our second request? So the second request was country wise, right? Now close this. Choose the country and drag it to columns or rows. Let's go with rows this time, and sales. So go to pivot table, analyze, pivot table chart, and here you can choose a pie chart since you're going with the country wise, and click OK. Now you have the pie chart over here. You can rename that as country wise. You can copy this and paste it onto the dashboard. In case you want to, keep the size of the pie chart and the column chart in the same, width and height, you can do that. Just go to format. Here you can 5.6 and it can be 9.9, and similarly you can go with 5.6. This can be 9.9, just so that you can accommodate a few more charts in the dashboard. You can align them. There you go. Right now our next request is subcategory shipment. So go to shipment. So this is the fifth sheet, so we need to go to the third spreadsheet where we have the pivot table. So close the format shape, and we have shipment here, ship mode. So select the ship mode, drag it to rows or columns, sales to here, and we have or you can count it, right? You can change it to count. Okay, so you have standard class with the highest number of sales happening. So many sales which are happening in your store, choose the standard class of shipment, right? So very least people choose first class or same day shipment, which is highly expensive, and the standard shipment will take minimum pricing, and most of the customers have chosen that. Now you can choose the same data here. Go to pivot table, analyze, and here we have pivot charts, and out of this you can select any one. Let's say if you want to go with the tree map, or if you want to go with the bar, or any one, you can go with that. So let's go with the bar graph. You press OK, and here you create it. Now rename this particular chart as ship mode. Now you can copy the same chart and paste it onto the dashboard. You can close that. If you go to format, you can do the same setting, 5.9 and 9.9, 5.6 and 9.9. There you go. You have everything lined up. And this space that we have over here, we can add a few more things which will come under slicers and filters. So we'll have to wait for that until we can finish the rest of the charts. Now we will go to the fourth sheet. So what was the fourth request? Let's check our list here. So subcategory wise sales. Now we can check the categories, subcategories over here. Yeah, we have the subcategory. Select that and drag to rows or columns and sales to values. Okay, and there you go. And if you want to sort, you can also sort by right clicking and sort it to minimum and smallest to largest to smallest. There you go. So the highest number of sales are happening through mobile phones. Next comes the bookcases, next come copiers, etc., etc. Now select this and go to pivot table analyze, pivot chart, and you can choose any one of those. We can go bar chart or the column chart, and you can also rename this as subcategory wise. You can copy it, paste it on the dashboard, and you can also make few arrangements if you want. You can resize it 5.6 and this will be 9.9. The next request is about the category wise sales and segment. So we have the category here, drag it to rows and sales here. You can keep it the way it is, or you can go to pivot analyze and here go to charts, choose the one you want and proceed. Copy it and go to dashboard. You can paste it over here. There you go. Country wise and segment quantity. So now you have country over here. I got country to rows and sales to columns, or you can, yeah, let's go with sales. Since this is a sales dashboard, this should be beneficial. Now we have, we can also sort it again, sort to largest to smallest, and we have France with the highest number of sales. I can copy that or go to pivot table analyze and here pivot chart. I can go with pie chart. You can rename it as country wise. So there you go, and copy this, paste it on the dashboard. I think we already did a country wise sales, so I think we can proceed with the next type of chart, which is segment wise. Let's go to the same sheet where we created the country wise sales and close the format, delete the chart. Instead of country, we can select segment. So which segment has the highest number of sales? Paste it over here. Format to adjust the size of the chart. There you go. So we have region-wise sales, country-wise sales, ship mode, subcategory-wise, category-wise, and segment-wise sales. Now we have a dashboard, but to make it a little more interactive, we might require a few filter-like options, which are also called as slices. So when you add slices onto the sheet or the dashboard, what you can do is you can select the options you want. Let's say I want the region-wise sales in Belgium, then you can identify that. Let's say you want Australia's or Austria's shipment modes. What kind of shipment mode is most used in Austria? You can find out it. And let's say you want to find out the Finland segment-wise sales, then you can find out. This is only possible when you try to include a slicer into the dashboard. Now let's go ahead with it. Now, if you select any of the charts, let's say I want to go with the first one. Now go into insert and here you can see filter options, right? So here you want to insert slices. Now here you have a slices right now. Okay, so you can select the slicer you want. So I want the slicer for region. I want the slicer for country. I want the slicer for ship mode, which is right here, and I want subcategory wise slicer. I want country or category wise slicer, So category and segment wise, which is here. So I want 6 slices. There you go. I've got the 6 slices created. Let's minimize to make it look a little more better. There you go. And we will paste the slices right here. You can also, modify the size of the slices. Let's try to make them fit here. And the next one should be right here. There you go. Now let's drag this here. The last slicer in the last section. There you go. Now we have a dashboard, but is it interactive? I guess not. So how to make it completely interactive? So you might have a doubt. Let's say I want to click on my sheets. Now only one out of the 6 charts is reacting. Let's say I want to click on papers. It is giving me the data for phones and etc. And if I click for Belgium, you can see only one chart is being interactive, right? Now what should I do so that every chart which is on the dashboard gets completely interactive and shows all the data in real time? That can be done. All you have to do is select any of the slices, right click and go to the option which says report connections. So select all the pivot table which are present in your chart right now: sheet 1, sheet 2, sheet 3, sheet 4, sheet 5, sheet 6 and sheet 7. Press OK. Now all the charts are interconnected with each other. And now if you click on any one of the options, so let's say I want the data for Austria country, and every data changes. Correct? Report connections. You need to do that with all the slices. Press OK. There you go. Now, if you select Finland, Denmark, Austria, you can see the charts are changing, right? Every chart is now interactive. So that's exactly how you create an interactive dashboard. Now you might be having a doubt. Okay, it's working for the existing data, but what if I add some new data? So here we have data until 2022 and this is the new data until 2023. Now if I add this particular data to the end of this particular data set right here and remove the row headers and go back to dashboard, go to pivot chart. On data dashboard, we need to go to data and here click on refresh all. Then you will get the updated data set. And now you have the updated results as well. And with that, we have come to an end of this session on sales dashboard in Excel or real-time interactive dashboard using Excel.
Hello everyone, I am Mayank and welcome to Simplilearn's YouTube channel. Are you want to get really good at using Excel? Well, Google Gemini can help make it super easy. Excel is all about handling data, organizing it, doing math with it and making it look nice. With Gemini, you can learn all about Excel step by step. Whether you are just starting out or already know a bit, Google Gemini can teach you everything from the basics like how to write formulas to more advanced stuff like analyzing big sets of data. All you have to do is ask Gemini questions or tell it what you want to learn, and it will explain things to you in a way that makes sense. Plus, you can practice right there in the chat by following along with the examples. So if you want to get really good at Excel without any hustle, just start chatting with Gemini and you will be an Excel wizard in no time. So yeah guys, this is our Gemini prompt. So here first we will write how to learn Excel using Gemini, right? Just for the clarification. Okay, so it will give some prompt. See, here you can see there seems to be slight misunderstanding. Gemini is the large language model you can interact with. Okay, so learn Excel basics. You can do you can learn data analysis with Power Query and like this. So here we will write give me week wise Excel syllabus. Okay, so it will give you week wise Excel syllabus. So okay, so this is week by week Excel syllabus, basic to intermediate. Okay, not advanced. You can learn advanced too. So in week 1, what you can do, you can object and navigate Excel interface, understand basic spreadsheet topics. You can learn introduction to Excel environment, working to cell rows, and even you can just particular modify the selected text. So in week 1, you can learn these type of things, entering data, text, number, dates, and these. And in week 2, you can learn building formulas with references related and absolute, and you can learn lookup functions, VLOOKUP, index match. Okay, in week 3, you can learn conditional formatting, and in week 4, you can learn a little bit of data analysis like this. Okay, so here we can write. So this is like you are chatting with someone. Okay, so you can write here, give me brief about the week 1 syllabus briefly for the same. Okay, so see, it elaborate particular thing for you. So see, master the interface, data entry and editing, formatting fundamental, formula fun. Okay, so what if you want to learn particular only logical function? Okay, or you want to learn building formulas with references, or you want to learn lookup function, or you want to learn date and time function particularly. So here you can ask Gemini, give how to work with date function in Excel, explain me with example. Okay, so till then let me open the Excel file for you, a rough. Okay, so yeah, so see, the date function is Excel is a handy tool for creating specific dates or working with existing ones. So here is a background. So year, month, day, example, right? So enter today date in a cell, let's say cell 1, A1. Okay, so Excel is now here. Okay, so what he's saying, so what it's saying, enter today's date in a cell, let's say cell A1. You can type directly, that is 2024, this. Okay, let me copy it directly. Okay, and paste it here. Okay, why it is not? Okay, or use today function. Yeah. Okay, fine. Or else you can write today function, right, like this. So if I want to write here equals to today, enter. See, you can see the same date, exact date. Or in another cell, that is B1, either enter the following formula. You can use this formula, date, year, A1, month, this. Okay, so what it will do? So this part extract the year cell from A1, which has already did this, then month from cell this, from cell this. So this is how you can learn any formula using Excel. Okay, so I will write, give me example of data in which I can learn basic formulas of Excel. Okay, so we will sort some try to formulas of Excel. So this is our particular data set. So as you can see, export to sheets. So either you can go directly to the sheets, and you can say sheets and this Excel are both same. Okay, so after that what you can do, you can, okay, first let me try to copy it. Okay, if possible. Okay, I'm not sure. No, it came in one cell only. Okay, so I can directly, so it's creating a spreadsheet. Fine. open sheets. So yeah, so this is the data. So now what learning with formulas. So this data allows you to learn practice. Okay, what I will do, I will just copy everything. We copy it and paste it here. Fine. So now the thing is that I want to learn sum function. So calculate the total quantity of each product sold by using the sum function on the quantity sold column. Okay. So what you have to do, formula in cell E2 for choco chips cake, right, equals to sum B2. Okay. So I can write here in which column? E2 column. E2 column equals to sum B2. B2. Enter. It's 50. As you can see, 50 is here. Okay, so this is how you can learn. You can learn average function. Okay, let me copy it directly from here, and you can paste it anywhere. Okay. Okay. Average of C2. Let's see if I'm okay. Fine. Why it's coming like this? Okay. E5. Okay, I will write here. See what's the issue. Okay, what if I can do equals to average of average. Okay, my bad. Average of this, comma this, comma this, comma this. Okay. Okay, so because of dollar, it's happening. Okay, so this is how you can learn. Or you can find across all using a function on the price per unit column, formula in cell E5. 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 If I will copy it. So this is how you can. Okay, because of dollar, it's happening. Okay, see how it will work now. See, because of dollar, it's happening. So now the average of C2 to C5 is 2. Okay, so this is how you can learn. You can multiply, you can apply VLOOKUP. So these are some additional tips from the Gemini. Okay, so I want to create a chart. Give me, explain me with example. Okay, so this will give you some data. See, data is a export sheet. So we'll copy later. Okay, fine. So these are some additional tips are here. So these are the data. Okay, copy it and paste it here. Okay, so now what can I do is, see, select the data, highlight the data you want to include in chart. This typically includes category, labels, product names. Okay, in our example, select cells A to D5, A2 to D5, from here to D5. Okay, it's mean all. Right, select data. Then what you can do, you can choose a chart. Go to Insert tab on the Excel ribbon and locate the chart section. Go to Insert. Then, okay, these are some charts. So what you can do, I want this chart. Okay, 2D column chart. Okay, I selected this. The best chart depends on the data, but you want to work. Here are some options: column chart, line chart. Okay, let's select column chart. Okay, insert. Where is the chart? Where are you? Column chart. Okay, so here you can choose recommended section. Okay, so these are some recommended by Excel itself. Okay, so stack chart is there, clustered column chart is here, and this stack bar is here, then clustered bar is here. So we will choose this stack column. Okay. So as you can see, this is your data is ready. Okay. Chocolate chip cookie, cupcake, bread lovers, muffin. So this is how you can learn Excel using Gemini. You can ask anything from beginner level to advanced level from Gemini. It will give you through. It will explain you with example. Okay.
So, Microsoft 365 Copilot is one of the latest AI products launched by Microsoft. So, the Microsoft 365 Copilot will be your AI assistant for all your Office suites from Microsoft. So, it can help you ease up your process of making PowerPoint presentations. It can help you write down the notes on Microsoft Word and many more. But today, we will be using this particular 365 Copilot for our data analytics using Excel. So, let me remind you, this particular AI tool works with the versions of Microsoft Office 365 and later, right? Now, there should be a new feature added upon to your Excel on the top right corner of your home button. But again, if it's not, it's completely alright. You can use your Microsoft home button where you can find the Microsoft 365 Copilot. So let's navigate to the home button. Yeah, now I'm on my home button, and here you can see a small icon which is completely new out of nowhere. This is your Copilot, right? And you can just click on it and you can fire your Copilot. And today's point of discussion is about Copilot with Microsoft Excel. So when you are starting Excel, there are some prerequisites when you're working with Copilot. So currently it is in the preview mode, so it is capable of using some dataset which is in the tabular format. I have converted this into a tabular format. It's really simple. Control A to select all the cells, and then Control T to convert this table. The option my dataset has headers, and okay, so your dataset will be converted into a table. And another prerequisite is when you pop up the Microsoft Copilot, it will ask you for a dataset which is under 1000 kilobytes. So my dataset here is about 800 kilobytes, which should be here. So the only process is you just have to click on this particular option which says attachments, go to the dataset that you want to work today. So I'll be selecting my sales EU copy and just press open. It will take a little time because it's completely new, so it might take a little time for that. So the only catch is Microsoft Copilot is a little slow compared to the other competitive Copilots or AI modules. It's not a big deal. They will catch up soon. Let's wait for some time while the dataset loads, and then you can fire some of the commands. Let's say I have given my command here, please help me create a regional-wise sales report for this dataset. And you can also give a few more commands, right? So it's loaded right now. You can see the icon here. Now you can write down, give me country-wise sales report, and just fire the command. You can also perform all your data analytics, what you regularly do, right? When you have a sales data set, you might be wondering what it can do and what it cannot. You just have to build a story about the report, what you want to create, and then just, write it down to the Copilot, and it will generate the report that you are looking for. Currently, it is working on the country-wise sales report, so it should be giving me the report shortly. It's okay. So there are some problems with this. So maybe it's the dataset, data type. So here we have country, and the data is general. So you might want to change that to text format or character format. So you have the text data type here, and just okay. Now save it back. Now you can ask the Copilot once again. Okay, or let's try to do a different one. Okay, now here we have the order date in column C, right? Now let's say I wanted to find out which day did they visit, right? Is it a Friday, is it a Saturday or Monday, right? So just try to ask the Copilot. Let me write it down. Can you help me find out which week of the day was an order placed? We have a column named order date. Column is C. We need a new column that tells me the day of the week when an order was placed. So let's fire the command. Now it should give us a column D, which is an empty column right next to order date, or it should give us the steps to do the same. Just fire the command. It might take a little while. Okay, here we have it. Certainly I'll create a new column D in your dataset. Great, this is what we needed, and so on. Let's try to ask another query. Can you tell me name of the customer with highest sale record in the dataset? So the previous query which we fired at will not be reflected on this particular dataset, but it can be reflected on the dataset that we shared with the Copilot here. So currently I don't have a direct connection with my Excel over here. I think it should be taking some time for getting me that update over here. But anyways, it will be updated in the dataset that it is currently dealing with. That's not a problem. Now let us see what's the answer. I apologize, but it seems that I'm unable to extract any text content from the uploaded file. It's okay. Let's try to file. There are some discrepancies, but it should be resolved soon. But let's try some other thing like region-wise sale. So let's say you are an Excel expert, so you can do it within a few fraction of seconds. You can just apply filters and get that data. But there are a lot of people new to Excel. So for them, the Copilot from Microsoft could be a boon, right? But down the line, there are improvements rolling out. So I could predict that it could be a lot faster and you can have seamless integration with your Microsoft Excel and your Copilot, and things could be a lot easier, right? So far we have the result over here. So it is giving us a few results and it is finding a little difficulty to extract a few. That shouldn't be a problem in a few couple of days where the new updates roll out. So proceeding ahead, let's try to give it another query or so. So let's check the data set. So here we have the categories and subcategories. I think we can give it, okay, can you give me the category wise profits? So here we can identify which category is performing really good and giving us highest number of profits. So I think let's check out if we have a profits column. Yes, we do have a profits column over here. So let's check that. Brilliant, right? So it's giving us distilled reports in one prompt. So that should be helpful for any of the data analysts which are aspiring, right? And which don't have any idea about how Excel really works. Okay, it seems that I'm able to extract text content from uploaded files. Okay, let's try to copy this and write it down as, okay, is it category? Okay, let's copy this as well. I think it's about the case, right? Category, subcategory. Okay, let's fire subcategory. Category sales report. Okay, it's giving us the previous answer to the previous query. Okay, I think this should help. It's unable to extract a lot of answers so far currently. There should be some discrepancy, but down the line it should be fixed. Unable to extract any text content from the uploaded file. Okay, so basically that's how you can work with your Copilot in Microsoft 365 Excel. So there are some discrepancies so far, so it should be fixed down the line. So that's how you can use Copilot in Excel for your data analytics. And with that, we have come to an end of this session on Microsoft 365 Copilot for Excel. And if you have any queries regarding any of the topics covered in this session, or if you require any of the resources that we used in the session, like the dataset that we used, which is in tabular format and under 1000 kilobytes, please do let us know in the comment section below, and our team of experts will be happy to resolve all your queries at the earliest. Let us know your experience working with Copilot in Excel, and we we can learn a thing or two from you as well. So now you can see some data on my spreadsheet. So we have a row ID, order date, and a ship date, ship mode, etc. So this means that this particular data set belongs to a sales data set for a store or something. So what I have done is, if you look out the videos on our channel, we already have created one of the interactive dashboards using the same dataset. So we try to extract month-on-month sales, region, category, subcategory sales, country-wise sales, shipment type sales, etc. Right? So I have kept the data as it is and all the pivot tables as it is. Now let's say we do not know how to create all these pivot tables and pivot charts and slicers, etc. We just know that we have the data and you're new to this and you want to analyze your data. How do you do that? ChatGPT is here for the rescue. So before we get on to ChatGPT, let's quickly remove all our reference pivot tables. About pivot tables, so I'm quickly deleting all these. We're left out with only the data, right? And again, you can do this dashboard using ChatGPT 3.5, or in case if you have a premium version, which is ChatGPT 4, you can directly attach your dataset onto the ChatGPT prompt and ChatGPT will do all the analysis you need, right? But for now, let's experiment using the ChatGPT 3.5 version, which is basically open source and free to use. Now let's quickly hop onto ChatGPT. So there you go. We have ChatGPT version 3.5. We are not switching to 4. So now let's quickly explain what we are up to. Hi ChatGPT. Just keep it simple, as if you're talking to your friend. The data set belongs to Superstore sales, or is about the data set is about a Superstore sales report. And I need to create a dashboard for month-on-month sale. So this is the prompt, and basically I just explained in a brief way. I'm not giving a detailed information, but hope this works. So basically what you are supposed to do is give the requirement one by one, but I'm giving it in a single prompt so that I'll get the results in one single prompt. Let's go for that. So what you're trying to explain ChatGPT is that you have a sales data set and you're using Excel for storing it and for manipulating the data and trying to build some innovative, interactive, visually appealing charts, and you don't know how to do it. So you explain that to your ChatGPT and what are the things you are looking to build. What are the charts you're looking to build? So I'm looking to build a month-on-month sales report, which can be a quarter-on-quarter, month-on-month, year-on-year, date-wise, however the way you like it, right? So make sure that your data is properly formatted first. So here, let's check out that your date column is formatted to date data type, right? Sometimes what happens is the representation of date changes to user by user. Let's say this particular data set or this particular inventory has been allocated to 5 different people to entry the data, right? Somebody might use this type of, here you have, let's create a new sheet and try to, let me elaborate what I'm trying to explain. So let's say person 1, person 3. So let's say I use this type of formatting. 15th December 2025, something like that, and somebody else uses 15/12/2025, and another one uses 15 December 2025. And also sometimes few people also intend or may follow a date pattern which looks something like this: December the 31st, 2025, right? And it's not wrong. So many people will have different conventions of writing their dates. So you need to make some data cleaning. And okay, if you are coming back to data cleaning, we have listed a video in our descriptions for data cleaning in Excel, and that would help you in various data cleaning operations that are used in day-to-day lives of a data analyst. So that should help. So basically what you are looking for is, so instead of general, go back to the data types, and here you can check out the data type options, and you can either give a short date, long date, or in the case you want to go for some additional formatting, you can also go to more formatting, and here you can check out the custom formatting options. Here you can give a customized option. For now, I want to go with date, and the date I want to go with is this particular one, which gives me date, month, and yeah, click on that, and you should be good to go, right? So make sure that all the dates in your spreadsheet are following one single date pattern, so that when it comes to month on month, quarter on quarter, and year by sales, that will help you a lot. Okay, it will just give you a filtered option. It will give you year on year first, then quarter on quarter next, and if you expand the option of quarter on quarter, you will have month on month, and if you expand the month, then you will have date wise. So you will have a better understanding when we perform this operation in a practical way in real time. And then we have the next type of chart where we want to identify country-wise sales. Then we have region-wise sales. So let's say I have one country here. Let's say I want sales from France, and I want to know what are the sales happening in central region of France, north region of France. So you'll have region-wise sales there, and category-wise, which category is giving you the maximum profits or the maximum sales, and inside the category, which is that subcategory or which product is that which is giving you the highest number of sales. You can identify that, and based on that, you can plan a business. You can get up with a business strategy there. And shipment modes. So which type of shipment mode which should you invest in much, so that you can offer better services to your customers. So everything counts. So this is what I want to extract from my data set. So this is my requirement. You have explained this to your ChatGPT through the prompt, and just enter. Now ChatGPT should help you break down the requirements, and ChatGPT should help you how to it'll tell you how to do the process. So here it will tell you the line chart. So basically it's a rule that month on month sales or quarter on quarter sales, basically wherever the time is involved, the line chart is the best to represent your numbers. So now it basically tells you how to represent your charts in what type of chart to be selected. That's good. But now can you help me create
the first chart in Excel. There you go. So it tells you how to create it. Ensure you have a column for dates and other corresponding values. So basically it is telling you to have a properly mentioned or properly defined metadata or column headers. Then select the data, go to the insert tab, choose the line chart. Okay, and let's say you wanted to create an interactive dashboard, right? So to create an interactive dashboard or to basically create a dashboard, you need pivot tables, and you don't know how to create a pivot table. You can ask ChatGPT to help you create a pivot table. Help me create a pivot table for the first type, for all the types, okay, or for the data set. Certainly. So it will mention you the steps to follow to create a pivot table. There you go. So what's the first step? Highlight the range of cells that contain your data set, including headers. And go back to Excel, and you can just click on any cell and Control A. All your data set has been selected, or these days you can just select one of the cells and go to Insert menu and Pivot Table. And now from the table range, Excel will automatically select the entire range of the table you're looking for or you're working on. And in case if you are having any doubts on that, you can just select all the range and go to the same insert option and select the pivot table. Now click on OK in a new worksheet, and there you go. You have your new pivot table. Let's delete this. Now remember, we wanted to create the month-on-month sale for the first pivot table and pivot chart. So, and remember about the date formatting. So we will be looking on that. Now we will drag order date onto rows here, and you can see here. So this is what I was talking about. So Excel has automatically segmented your dates. We have about 10,000 rows in this particular data set, and it has segregated all the 10,000 rows into 4 different years: 2020, 21, 22, and 23. And if you expand the selection of year, it has segregated again into quarter 1, 2, 3, and 4. Right? And if you expand quarter 1, you have month-on-month sales in quarter 1, month-on-month sales in quarter 2, and month-on-month sales in quarter 3, and so on. Right? So this is why I was requesting you to have a proper data formatting for all your dates, right? Which could be really helpful when you want to extract the quarter-on-quarter sales and date-wise sales and year-wise sales, right? So now we wanted to find out month-on-month sales, right? Or year-on-year sales. So where is the sales? Yeah, here we have the sales parameter. Just drag that onto the values, and there you go. Now format this into the currency type. So the currency is dollars, American dollars, and you can eliminate the leading zeros here if you don't want them. There you go. Now you have the whole number here. You can also do the same for this. You can select the entire table. Go to pivot table. Okay, let's check the options provided by ChatGPT. So basically we have created a pivot table. Now we want to create a pivot chart. How do I create a pivot chart? So again, it's making really clear statements and really clear steps. So it's again making sure that you create a pivot table first, right? So we have a pivot table, and highlight pivot table data. Click anywhere on your pivot table to highlight the entire range. Insert pivot chart. With the pivot table selected, go to the Insert tab on the ribbon, and then click on Pivot Chart and open the Insert Chart dialog box. Choose the type you want, and customize the chart, select the chart. So customizing the chart, we'll look onto it. And fields, if you want to keep a few fields, you can, and if you want to eliminate a few fields, you can also do that. Refresh data. Let's say, why refresh data? See, ChatGPT is so brilliant, right? So let's say I have the sales data until 2023, and now we're in 2024. Let's say we update 2024 onto this particular spreadsheet, and now we have that particular data in the original spreadsheet, but that is missing here. In that scenario, what you can do is just go to data, and here you will find the refresh all option. Once you click on this, you can find the 2024 data updated here. For now, we have not added yet, but in case if it's added, all you can do is just refresh your sheet and everything will change. So brilliant suggestion from ChatGPT, and save and share in case if you want to share. So let's follow the same steps. Select any cell in the pivot table, select all the sheets, go to insert tab, and here recommended charts, or go to the charts option and select the chart that you are looking for. So we are dealing with time, so I would go with the line chart. Just click OK. But in case if you want to create an interactive dashboard, just go to pivot table analyze, and here you have the pivot charts. And again, it will give you the same option. Just select the line chart here and press OK. So you have your line chart over here. So again, if you are editing this, so you can remove the legends if you want, remove anything else, or you can customize that. Okay, there you go. And if you want to edit the name of the chart, you can also do that. So I will do this as MOM sales report. Okay, accordingly I'll change the sheet name. There you go. Right, now quickly we will create the other charts as well. So the process is the same. You can hold control and drag this particular sheet, and you have the next sheet. So the next requirement that we had, that we requested ChatGPT, was the country-wise sales. So everything will remain the same. What changes is, okay, let's close this, and here instead of order data, we will have, okay, let's remove this from rows and quarters, months, right, country. So we will drag country into rows, and there you go. Now we have countries. Now country wise, so you can select the cell, go to pivot table analyze, pivot chart, and you can select the bar graph. So it automatically gave you the first suggestion as bar graph. Click on that, and you have the bar graph over here. And you can also edit the chart. You don't want the legends, you can remove them, and edit the name of the chart to country-wise sales. So, and quickly drag and drop the sheet again, new pivot table, and here you wanted category-wise sales or segment-wise sales. Close this particular thing, delete this, and instead of country, you're going to add segment to the rows and remove country, and you have segment wise sales. Select any cell on the pivot table, go to pivot table analyze, pivot chart, and here you can use any of the available charts here. Let me use the funnel chart, or histogram. Bar chart will be better. Press OK, and there you go. You have the bar chart. Same. Edit your, customize your chart. Change the name to segment-wise sales. Hold control and drag the sheet. Now you have subcategory-wise sales. Instead of segment, you will be selecting the subcategory. You can remove segment, and you can see the chart also changed here. And again, you can do the category wise sales. So this was segment wise sales. You can quickly change the segment to category, and you have it. We quickly go back to, so we have done the category wise, subcategory wise, region wise is remaining, and shipment modes. So quickly drag and drop the region, remove subcategory from the list. There you have the region-wise sales. Edit the name. And the last one, which is about the shipment modes. Remove region, and there you go. Now you can create a new dashboard over here and name it as dashboard. You can do some customization to your dashboard, like selecting these cells. Giving it a color. There you go. Now you can quickly copy and paste all these charts to the dashboard. Starting from the month-on-month sales. Copy. And paste. So I'll quickly do all the pastings as soon as possible. There you go. You can also manage the size of these charts so that everything fits onto one sheet. So for now, let's try to unpin this so that we have a little better visual appearance. Okay, not a problem. And now we need some filter, right? So something which can make it a little more interactive. That's when you add slices, And let's say you don't know how to add slices. Back to ChatGPT and ask ChatGPT, how do I add slices to my dashboard? There you go. So it is telling you to add everything in a step-by-step way, and it also is talking about the interactivity, right? It is asking you to connect all the slices. It's telling you to report the connections, right? If you just add the slices based on one single, okay, basically you need to select one of your charts here and select a pivot table or pivot chart, go to the pivot table or chart and associate with the slicer and insert, and go to the insert tab and insert a slicer. I'll tell you that. So basically it's telling you in a very beautiful way, step-by-step manner, right? And even after adding the slicer, it is telling you to connect all the basically all the charts or all the dashboards and charts you created in this particular tutorial, and connect all those charts to that particular slicer using the report connections option, and you can get the interactivity, right? So in a very beautiful manner, it has explained you. Let's try the way it has explained to us. Go to the dashboard, select any one of it, and go to the insert option. And here you have the slicer, right? So now you have all the slices over here. So basically we wanted what type of slices. So I have created a month-on-month chart. So I'll go with order date slicer, which is here. Then I have created segment-wise sales, so I want segment slicer, country-wise slicer, category and subcategory-wise slicers, region-wise, so region slicer. And do I have anything else? Let's scroll down. That's the last one. So where is the shipment here? Yeah, ship mode. Country, region, category, subcategory, segment, order dates, and ship mode. So I will have multiple slices in one go, right? Now you have to arrange your slices in such a way that they are interactive and they look like they are sorted in one place. So let me do that quickly. We have some space left here in the bottom place of the dashboard. You can also keep your slices there. So what basically ChatGPT meant was, if you try to use the slices here, it will, the changes will reflect only in one of the pivot charts, not on all the pivot charts. So to get that interactivity, to get that connectivity between all the charts, you need to do a small setting which is called as report connections. So select one of the slices over here, right click, and here you have something called report connections. So when you report connections, you have all the pivot charts and pivot tables that you just created. You can just select all those pivot tables that you created and press on OK, so that all these pivot tables are connected to that particular slicer. You can just expand this and check if all the pivot tables are selected. Press OK. Do the same for all the slicers. I'll quickly do that. So there you go, we have interconnected all the charts. Now let's say I want to find out the sales that happened in the latest year. Just go to the filters select any of the dates, 2023, and you have the data. And if you want to select any particular country, then you can also do that. I want to go with United Kingdom, and in United Kingdom we have all the data here. Let's say I want to check out only for the phones. There you go. Now you have an interactive dashboard which will tell you the sales that happened on the date of 16th of November 2023 in the region United Kingdom for phones, right? And segment is home or office, shipment mode was standard class, and major sales that happen are from North region, and the category is from technology, right? And that's how you create an interactive dashboard using ChatGPT in Excel. So each and every step has been mentioned very clearly by ChatGPT, and you have all the data in one place. So let's quickly remove all the filters. And there you have the entire dashboard, right?
Welcome to our video on Essential Excel Functions by Simplilearn. If you are new to Excel or looking to improve your skills, learning these functions can really help. Excel isn't just making spreadsheets, it's a powerful tool for analyzing data and managing projects. In this guide, we will cover some basic but important Excel functions like sum, average, if, count, and SUMIF. You'll see how these functions do and learn and how to use them with practical examples. This knowledge will help you with daily tasks and make you more confident in using Excel. So let's explore these functions together and see how they can make handling data easier and more efficient. Let's get going and make the most of your data with Excel. Why learn basic Excel functions and formulas? Functions and formulas are crucial for mastering Excel. By learning even a few essential ones, you can outpace many around you. They are fundamental for daily Excel tasks. To deepen your knowledge or explore advanced functions, consider exploring a comprehensive database of all existing Excel functions. Microsoft consistently updates Excel, introducing new functions like XLOOKUP in Microsoft 365, enhancing your data management capabilities. So now let's move on to the demo part. Okay, so first we will understand the sum function in Excel. As we know, the sum function in Excel is used to add up the numbers. It provides a quick way to calculate the total of several values, whether they are typed into a function directly included within a range of cells. So these are the cells. So you just have to type the numbers in this cell and give the function over here, and it will give you the desired result. Let's check how. So first we will understand the sum function. I'll just write it over here. So the first step is like open your Excel file in your computer and select any column or row. So like here I'm selecting the column. For instance, you might just put them in cells A1 till A5. So in the A1 part I've mentioned sum for your understanding. So we'll start with A2. We'll type all the values over here. So just type any values, like I'm typing 40, then we have 78, then 35, and then we have 67. From A2 till A5 we have typed the values, and using the formula in the formula bar, it will add all the numbers from cell A2 till A5 and it will display in this particular cell. So just select the cell where you want your answer to be shown and just insert the formula over here. The formula for sum function is equal to sum A1 till A5. So we just go back to this bar and just select this particular cell, and here in this bar just type the formula A1 till A5, but then here we have A2, so we're just gonna change it to A2 till A5. All right, and just press enter. So here you get the value 220, which is the sum of all the values which we have mentioned over here. So it was pretty simple, right? Now let us understand the if function in Excel. Okay, so the if function in Excel is used to perform logical tests and return values based on the results of these tests. This function checks whether a condition is true or false and then returns one value for a true result. and another for a false result. It is extremely useful for decision-making process within your dataset. Let us now understand what are the steps to use this if function. So just input your data and put any numeric values in the cells from B2 till B5, okay? So 56, 90, 36, 23, and here I want my result to be shown. So I'll just insert the formula here in the function bar. So, okay, just check out the formula for if function, which is equal to if A1 if greater than 800, above 300, 300 or below. So let's see how it works. We're just gonna enter the formula. Okay, so this will tell Excel to check if the value of B2 is greater than 300. If true, it will display above 300, and if false, it will display 300 or below. Let's check it out. Okay, so there's a mistake. I'm gonna paste the formula here again. So in place of A1, we will mention B2. We'll just type B2 over here. If greater than 300, above 300 or 300 below. Just press enter. So we'll just enter the formula over here, and in place of A1, we will provide B2, alright? So we just type here B2. That's it. And we just press enter. So you can see the result has come to 300 or below because the value is less than 300. And you can also drag and fill handle from B1 down to B5 and apply the same logic in other columns as well, and it will give you the same result. Let us now understand the next function, which is the average function in Excel. The average function. And okay, so what is this average function used for? Basically, the average function in Excel, it will calculate the mean or average of numbers provided to it. This function is particularly useful for quickly finding the central values in a set of data, which can be helpful in various statistical analysis. Let us now understand the steps to use the average function. So the first step is like you just click on the cell wherever you want your value to appear. Alright, so just provide any values. Suppose let's provide some bigger values, like bigger numbers like 430. Here we type 278. Then we have 98. Then we have 79. And here I want my value to be shown. So I'll just insert the average formula, which is, let's check out the formula, which is equal to average. What is the column we have chosen? From C2. So we'll just type C2 over here till C2 till C5. C5. Alright, and we will just press enter. So as you can see, the average function value is shown over here. So after pressing enter, the Excel will compute and display the average of all the cells in the selected cell. The next function is the minimum and maximum functions in Excel. It's very simple. Let's discuss what is the minimum and maximum function used for. The min and the max functions in Excel are used to find the minimum and maximum values within a given range of data. These functions are useful for quickly identifying the smallest and largest numbers in a data set, helping you to analyze different ranges efficiently. So let us now understand what are the steps to use this formula. It's very simple. Just type any values over here, 500. Next we have 389. Then we have 200, 190, 198. And here I want my value to be shown, the minimum value. So in the function bar, I'll just type the function, which is equal to min and in the bracket you just mention the column which is starting from D2, right? So D2 till D5. So just type the formula over here, and after pressing enter you can see the minimum value shown over here is 198, and it's similar for the maximum function as well. So for the max, let's use some different values, and I want my function to be shown here. So same, you have to use the same formula. Just type in place of max in place of minimum we are using the max function. So just type max, and then the column name which is from I think E. So just type. So in place of, we will just write E. Okay, sorry. We just type E2 till, I think it's till E5, right? E5. That's it. And just press enter. So you can see the maximum value shown over here. That is 800. So it's very simple. The Excel will display the largest and the minimum value using min and max functions. The next is to understand the trim function in Excel. Let us now understand the trim function in Excel. So basically, this trim function in Excel is used to remove all the extra spaces from text except for a single space between words. This function is specially used for cleaning up the data that comes from other sources of data that has been entered inconsistently. Let us now understand the steps to use this trim functions. It is same as we have seen for all these functions. The only difference is that this trim function will exclude the spaces. So assume your text data with some extra spaces in cells. Suppose over here I type any sentence, any text, okay, like hello, and then I provide some extra space, everyone. And suppose I want my value to be inserted over here to remove all the extra space, or if you want some bigger text you can do that. But let us now check how this trim functions work for this text. Just click on the cell where you want your clean text to appear, that is F6, and using the function over here just write equal to trim, and then in place of, you just have to mention over here which is F2, which is F2. Just press enter. Now you can see that I've provided some extra spaces over here, but here using the trim function it will remove all the extra space and just make it in a clean manner. So you can also drag the fill handle from B1, like from this F2 down to G2 and all of that, and then you can use the trim function in other column as well to clean up the text. The second function is the concatenate function. So let's discuss the concatenate function over here. Okay. So this concatenate function in Excel is used to join two or more text strings into one string. It helps in combining data from different cells, which can be useful for creating full names from first and last names, combining addresses, or any situation where text needs to be merged. So let us now look the steps how to use this concatenate function. So just assume that you have written your name. Suppose I've written Andrew in this column H2, and here I have written Garfield. Now what if I want to combine Andrew Garfield together? So just by using this concatenate function I can make it happen. Alright, so if I want my result to be shown in this particular cell, I'll just click on this, and then in the function bar I'll just enter the formula which is equal to concatenate, and then I have to mention the cell name which is H2 This is H2, right? H2 till, and this one is I2. So I'll just mention the, yeah. And here, after mentioning, okay, I have to provide some space over here. So I'll just put comma and then some space, then comma, and then here I'll just I2. Alright, and here I'll just press enter. So you can see in this particular row, Andrew Garfield, both name has been combined, concatenated together into a single name. So this is how we use the concatenate function. And the next function we have is the count function in Excel. Let us now understand how to use this count function. Okay, the count function in Excel is used to specifically count the number of cells that contain numbers in a range. It's a crucial function for quickly assessing the numbers density in a dataset, especially when dealing with mixed data types. We'll just assume that you have added transaction counts in column J, starting from column J2 till J5. So the transaction counts are as follows: 7, 89, 90, 100 till J5. And then click on the cell where you want your count to appear, say J6. And then you just go to the formula bar and just enter the formula over there, which is equal to count bracket. This should be J2 till J5. And just press enter. And you can see the Excel will display the number of cells that contain numbers in column J, which is 1, 2, 3, 4. Okay, so this was all for count, concatenate, trim, max, min, average, if, and sum functions. Next we have is the count A function. Let us now understand what is this count A function used for and how is it different from count function. So this count A function in Excel counts the number of cells in a range that are not empty. It is useful for determining the size of data sets that include various types of data, such as numbers, text, or even logical values. So it will just count the number of non-empty cells in a specific column. Just click on the cell where you want the count to appear. Okay, let me just tell you the difference between count and count function is that the count function generally used to count a range of cells containing numbers or dates, excluding blank. Whereas this count A function will count everything, including numbers, dates, text, or a range containing a mixture of these items, but does not count blank cells. So suppose if I enter 56 and I leave it blank, and then I enter 98, and then again I leave it, okay, and then just enter 56, and I want my formula to be shown over here. So I'll just go in this formula bar and just enter equal to count A, and then from K column, this is K column, right? K2 till K5. Okay, and I just press enter. So as you can see, it's showing 3. 1, 2, 3. It will not count the extra space or the empty cell we have left behind. And also one more thing, that we can also type text over here. It's not necessary to type only the numbers. You can also type the text. For example, I type apple. Here I type banana. Okay. Here is the function. Just press enter, it will count 3, which is 1, 2, and 3. So this count A function is used both for text as well as the dates as well as the numeric values, but the count function is only used for the numeric values and a date. It will not count the text over here. Now let us understand the COUNTIF function in Excel. We have now understood count and COUNTIF function and what is the difference between both of these functions. We will now understand the COUNTIF function over here. So let's understand the COUNTIF function. Okay, so this COUNTIF function is used to count the number of cells in a range that meet a specified criteria. This function is valuable for filtering and analyzing data based on specific conditions. To count the number of transactions that exceeds a certain amount of value, a threshold value, for example 5. Just click on the cell and suppose you want your values to appear in column L2. So suppose I type here 89, 7, 3 and 5. And here I will enter the formula which is equal to COUNTIF, and then from L2 till L5. Okay, just close the bracket. And here you just also have to input the threshold value. Suppose I take the threshold value as let's say 3 or let's say 5. Okay, let's take it 5. So this is my threshold value greater than 5. So it will display only the numbers which are greater than 5. And I just press enter. So you can see it's showing 2, okay? Because 7 and 89 are the only two values which are greater than 5. So you can see that using any threshold function, even if I could have written over here, let's say 3, so it will show 3 because the numbers greater than 3 are 5, 7 and 89. So this is how COUNTIF function works. We will now understand the last function, which is the SUMIF function in Excel. So what is the SUMIF function used for? Basically, the SUMIF function in Excel allows you to add up values in a range based on specified criteria. This function is extremely useful for performing conditional sums, where you can want to show the sum numbers that meet certain condition. So to calculate the sum of transactions where the number is greater than 5, click on the cell where you want your total number to appear. Let's say over here I select which is M6, and you just have to enter the formula. Before that, just write any number values like 7, 5, 3 and 10. And over here, just mention the formula which is equal to SUMIF, and the column name is starting from M2 till M5. Value should be greater than 5, comma, this is M2, right? M2 till M5. That's it. And we'll just press enter. So it's showing 17. So based on this formula bar, the formula will check the values from M2 till M5, and if the number is greater than 5 and sum only those number. So as I've mentioned the value 5, so it will only calculate, it will only sum numbers which are greater than 5, which are 10 and 7, which is equal to 17. So this is how the SUMIF function is used. We have come to the end of our video, and this was all for the top 10 most important basic Excel functions.
In this session, we are going to learn about databases, how data is stored in relational databases, and we'll also look at some of the popular databases. Finally, we'll understand various SQL commands on MySQL server. Now let's get started with what is a database. So according to Oracle, a database is an organized collection of structured information or data that is typically stored electronically in a computer system. A database is usually controlled by a database management system or DBMS. So it is a storage system that has a collection of data. Relational databases store data in the form of tables that can be easily retrieved, managed, and updated. You can organize data into tables, rows, columns, and index it to make it easier to find relevant information. Now, talking about some of the popular databases, we have MySQL database. We also have Oracle database. Then we have MongoDB, which is a NoSQL database. Next, we have Microsoft SQL Server. Next, we have Apache Cassandra, which is a free and open source NoSQL database. And finally, we have PostgreSQL. Now, let's learn what is SQL. So SQL is a domain-specific language to communicate with databases. SQL was initially developed by IBM. Most databases use structured query language or SQL for writing and querying data. SQL commands help you to store, process, analyze, and manipulate databases. With this, let's look at what a table is. So this is how a table in a database looks like. So here you can see the name of the table is players. On the top, you can see the column names. So we have the player ID, the player name, the country to which the player belongs to, and we also have the goals scored by each of the players. So these are also known as fields in a database. Here, each row represents a record or a tuple. So you have the player ID, which is 103 here. The name of the player is Daniel. He is from England, and the number of goals he has scored is 7. So you can use SQL commands to query, update, insert records, and do a lot of other tasks.
Now we'll see what the features of SQL are. SQL lets you access any information stored in a relational database. With SQL queries, data is extracted from the database in a very efficient way. The structured query language is compatible with all database systems from Oracle, IBM to Microsoft, and it doesn't require much coding to manage databases. Now we will see applications of SQL. SQL is used to create a database, define its structure, implement it, and lets you perform many functions. SQL is also used for maintaining an already existing database. SQL is a powerful language for entering data, modifying data, and extracting data in a database. SQL is extensively used as a client-server language to connect the front end with the back end, thus supporting the client-server architecture. SQL, when deployed as data control language (DCL), helps protect your database from unauthorized access.
So let's start with what is normalization. Normalization in DBMS is a method used to organize data within database to reduce repetition. By breaking down large data sets into smaller, more manageable tables and ensuring these tables are properly related, normalization helps prevent issues like data redundancy. Data redundancy means the unnecessary repetition or duplication of data within a database. For example, when a same piece of data is stored in multiple places, it can lead to inconsistencies and take up more storage space than needed. For example, data redundancy before normalization. You can see the table mentioned above where we have order ID, customer name, customer address, product, and quantity. You might see some of the data which is being repeated again and again. In the above table, the customer address for John Doe is repeated 3 times. Let's suppose if John Doe moves to a new address, every occurrence of his address in the table must be updated. If any instance is missed during the update, it leads to inconsistencies and errors can occur in the database. The solution is reducing the redundancy through normalization. Let's check it out how. So you can see this is the normalized table we have created. First is the normalized customer table and then we have the order table. So what are the benefits of normalization? The address for John Doe is stored only once in the customer table. If John Doe's address changes, it needs to be updated in one place, ensuring consistency through the database. This reduces the risk of errors and maintains data integrity. The process involves multiple steps that transform data into a tabular format, removing duplicates and establishing clear connections between different tables, making the database more efficient and reducing problems like errors during data insertion, updates, or deletion. Let's now discuss the types of DBMS normal forms. Normalization rules are categorized into different normal forms. The first one is 1NF. For a table to be in first normal form, it must satisfy the 4 rules. Single-valued atomic attributes. Each column should contain only one value per row. This means that there should be no repeating groups or arrays within a single column. Same domain values. All values stored in a specific column should be of the same data type or domain. For example, if a column is meant to store dates, all values in that column should be dates. Then we have unique column names. Each column in the table should have a unique name. This ensures clarity and avoids confusion when referring to a specific column. Then we have order of data, which doesn't matter. The order in which rows are stored in the table should not affect the data or its integrity. Let's check the example of the first normal form. Consider the following unnormalized table: customer ID, customer name, and the phone numbers. As you can see, the phone numbers are repeated twice. The problems with the original table is the non-atomic values. The phone numbers column contains multiple phone numbers separated by commas, which violates the atomicity rule of 1NF. Converting to first normal form, to bring this table into 1NF, we must ensure that each column contains only atomic value. This involves splitting the rows where there are multiple phone numbers. As you can see, we have splitted the data. Each row now has a single phone number, ensuring that the phone number column contains atomic value. Same domain names, all the values in the phone number column are consistent in format and type. All are phone numbers. Then we can see that the unique column names, the columns customer ID, customer name, phone number, which has unique name satisfying the requirement. Order of data, the order in which the rows appear does not matter, as the data's meaning and integrity are preserved. By applying these rules, the table now conforms to the first normal form, eliminating any redundancy related to the phone numbers and ensuring data is stored in a more organized and efficient manner. Let's go through each of these database normal forms step by step with simple examples to help you grasp the concepts more easily. Let's talk about the second normal form. For a table to be in second normal form, it must satisfy the following condition. Number 1, it must be in 1NF. Number 2, no partial dependency. Every non-key attribute should be fully dependent on the entire primary key, not just part of it. This rule applies primarily to tables with composite primary keys. Example of second normal form is, consider the following table that is in 1NF. The order ID, product name, quantity, and the supplier name. The problems with this table is that the partial dependency. The product name and the supplier name depend only on product ID, not the entire primary key, which is order ID and product ID. This violates 2NF. Converting to second normal form, to bring the table into 2NF, we separate the data into two tables to remove partial dependencies: order table and the product table. No partial dependency in the order table. Quantity is fully dependent on both order ID and product ID. In the product table, product name and supplier name are dependent only on the product ID. This ensures that each non-key attribute is fully dependent on the primary key, bringing the tables into 2NF. Let's now talk about the third normal form, 3NF. For a table to be in third normal form, it must satisfy the following condition. Number 1, it must be in 2NF. Number 2, there should be no transitive dependency where non-key attributes depend on other non-key attributes rather than the primary key. Let's check out the example of a third normal form. Consider the following table that is in 2NF. The problems with the 2NF table is that the transitive dependency. The instructor name is dependent on the course name, which is not directly on student ID or course ID, and this violates 3NF. So how do we convert this into 3NF? To achieve 3NF, we split the table to remove the transitive dependency. Student course table and course table. No transitive dependency. Now, the student course table, there are no non-key attributes depending on other non-key attributes. The course table stores the course and instructor information separately. This structure eliminates transitive dependency, ensuring the tables conform to 3NF. Let's now talk about the Boyce Codd normal form, which is BCNF. BCNF is an extension of the third normal form, 3NF. A table is in BCNF if it is in 3NF, and for every functional dependency, A implies to B, A should be a super key. Let's check out the example of a Boyce Codd normal form BCNF. So you can see this table here consisting of employee ID, department, and the manager. The problem with this table is that the BCNF violation. In this table, department determines manager, but department is not a super key, since employee ID is the primary key. This violates BCNF. So how do we convert this to BCNF? To achieve BCNF, we split the table to ensure that every determinant is a super key. As you can see, the employee table and the department table. The super key requirement: in the employee table, employee ID is the primary key, and in the department table, department is now the primary key. The decomposition ensures that every functional dependency is satisfied by a super key, meeting the requirements of BCNF. Let's now talk about the fourth normal form, which is 4NF. A table is said to be in 4NF if it is in BCNF and has no multi-value dependencies. So let's consider an example of a fourth normal form. Consider a table where an employee can have multiple skills and work on multiple projects. As you can see, the employee ID, skill, and the project. The problem with this table is that it is multi-value dependency. An employee skill is independent of the project, but both are stored in the same table. This leads to multi-value dependency, violating 4NF. So, in order to achieve 4NF, we separate the skills and the projects into different tables: the employee skill table and the employee projects table. And now you can see that no multi-value dependency. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the table conform to 4NF. Let's now talk about the fifth normal form, the employee skill table and the employee projects table. So as you can see that no multi-value dependency is there. By separating the skills and the projects, we eliminate multi-value dependencies, ensuring the tables conform to 4NF. Now let's talk about the fifth normal form, which is 5NF. A table is said to be in fifth normal form if it is in 4NF and cannot be decomposed into any smaller tables, losing information, also known as joint dependency. Let's consider an example of a fifth normal form. This is a table here that records the relationship between suppliers, parts, and a project. The problem with this table is that the joint dependency. The table has a complex relationship between suppliers, parts, and projects that can be decomposed further. So how do we convert this into fifth normal form? In order to achieve 5NF, we break the table into smaller related tables: the suppliers part table and the suppliers project table, also parts project table. Eliminating joint dependency, by decomposing the table into 3 smaller tables, we remove the complex relationship and eliminate the joint dependency, ensuring the tables conform to 5NF.
Today, we will learn Python exploratory data analytics. In this tutorial, we will be going through the fundamentals of data analysis with Python that covers the data analysis libraries, data visualizations, and much more. For better understanding, let's go through a simple use case on analyzing student performance so that we can come up with a report to assess improvisation in their academic performance. So here's the context. Let's imagine our client from the educational institute who runs a couple of schools in the city. He and his school administration identified a growing concern about the overall development of their students, realizing that academic focus alone was not yielding in the desired results. To address this issue, they hired a data analyst to investigate key factors influencing student success. The analyst highlighted critical parameters like physical fitness, parental education, rest and recovery, and access to resources as contributors to students' performance. Based on these findings, the school recognized that a holistic approach is needed. They decided to invest in programs that promote overall development by focusing on key areas targeted by the analyst. The school now successfully enhances both academic performance and overall development of their students. The key to this success was Python's exploratory data analysis, using which the analyst deep dived into data about critical aspects of a student's day-to-day schedule. Now, let's go through a similar approach through our demonstration on Python's exploratory data analysis. But before that, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Now, without further delay, let's get started with our Python exploratory data analysis. But before getting started with the demonstration, let's have a brief understanding of exactly what is exploratory analysis. Is this anything different from regular data analysis? Yeah, that's exactly what we're going to discuss. Now, types of data analysis. So basically, there are 2 different types of data analysis: initial data analysis and exploratory data analysis. Now, what is initial data analysis and what is exploratory data analysis? Let's understand a little briefing about these both. First, let's get started with initial data analysis. So what exactly do you mean by initial data analysis? So data can be in any form. It can be an Excel file, it can be a SQL file, it can be a PDF, it can be an XML, it can be even a website. Whatever it is data. If you have some information in this which can be used to extract some valuable information, then it is data. So initial data analysis is a process of inspecting the data and screening the data that takes place after data collection and before statistical analysis. So before you conduct any statistical formulas and analysis on the data and squeeze the data to extract some valuable insights, the process which you perform is called as initial data analysis. Like taking the data from the source, cleaning the data, transforming the data into a readable format, and using that readable data to build some basic charts. What exactly is happening with this particular company, brand, or anything. Let's say I give you some data from the company, then you get some insights of it. How many number of traffic you received, how many number of orders you received, what's the sale that you made in a specific month, specific quarter, or specific year, and what was the profit. So basic information which you convert from the data and create a dashboard, right? That is called as initial data analysis. So a step beyond initial data analysis is known as the exploratory data analysis. This is where you perform some statistics and probability and predict the future, right? So let's dive deep and learn what exactly is exploratory data analysis. So a simple definition for exploratory data analysis is as follows. Exploratory data analysis is a key step in data analysis process that helps you identify patterns, outliers, and relationships between variables before making assumptions. It is not like you just create a dashboard out of the initial data analysis and you can predict the future. No, it's not like that. You might have to you might have to go through some permutations and combinations. You might have to check the seasons. You might have to check the possibilities, right? During some particular seasons in the year, let's say it's Christmas, then you can expect some good sales. Let's say it's some festival, it's some special occasion, you can expect some good sales on the product, right? And maybe a part of the year, maybe a part of 10 years, a decade, right? In a certain period of time, there might be some reason due to which the sales of a certain product were high. So to make sure that your assumptions, to make sure that your projection of the sales is 100% accurate, or at least 90 to 95% accurate, then you might have to go through the exploratory data analysis, where you make use of statistics in your data analysis. Now, there are certain steps that you might have to follow while going through exploratory data analysis. So following are the steps. So first few steps might be slightly relevant to initial data analysis, like connecting data, cleaning it, transforming it, and loading it. After that, you will import certain libraries from Python. And after that, you read the data, what exactly you have in your data, the number of columns, the number of rows, and if there are any null values, if there are any entries which are invalid, you might have to check that, read that, and you might have to check for duplicate entries. It is possible that one entry might have been entered by two different people, right? There might be a duplication, so you might have to eliminate those duplications. You might have to check for some missing values. You might have to calculate the total number of missing values from the dataset and try to eliminate them from the calculation during your exploratory data analysis. Followed by that, you have to do some model engineering. Followed by that, you might have to do some feature engineering, creating features, and then you will get started with exploratory data analysis. And at the end, you will generate a projection or a prediction or give your assumption that this might happen in the future, and you might have to take action to avoid it, or you might have to take action to improvise it, right? So this is how the steps in exploratory data analysis take part. Now, let's proceed and start with our demo on Python's exploratory data analysis. And in this session, we will be using the use case that we discussed before, which happens to be the student's performance dataset. So in this particular dataset, we will be having some columns based on physical activity, the distance from home, parental education, the subjects, the marks they have scored in the previous exam, the marks that they have scored in the previous exam, and if they have any disabilities, if they are having any resources that they require to write the exams, right? So a few parameters, the important parameters that we will be discussing in this session, and followed by that we will project the future, that how they will improve in their exams, and if there is a problem and if there is a solution to that, then we can implement that solution and help students to gain better marks in their exam. So that's the overall use case for this demonstration. Now let's get started with our Jupyter notebook. Now we are on Jupyter notebook. Now let's get started. So I would like to have a title for my notebook. So I'll write an HTML code for that. So HTML code, and I have 3 apostrophes. And here I would like to write something in H1, so I want my title to be in H1. So style will be background color, color name will be dark blue. So let's proceed with the Simplilearn's background, which will be dark blue usually. And the color of text will be orange. And I also want to have the font. Let me give the font size as 30. And in the next line, I'd like to have border radius. I can give the border radius as 20 pixels. And padding to be 16 pixels. Text alignment, I'd like to keep it center. There you go. Let's close the H1. Now let's code the background color or border color. So B style. So what we can do is we can basically have this code here, and what we will do is we will reuse this particular code segment, because we will be having multiple HTML codes in this particular workbook, which will explain the results of the analysis that we are doing. So the way we just run the code, and after that we will be getting some visualizations, and I will be writing some textual content in HTML page, so that it will be easier for the people to understand what exactly is happening here, right? So the color will be light blue, and now comes the text. We will close this, and here we will write the text as Python exploratory data analysis, and we will break here for student performance. And here we will close the H1. And lastly, we will display this in HTML code. So basically we missed this library. So we will be importing from IPython display import HTML to display this particular code. So without this particular library, we cannot display any HTML codes in our notebook. So we will quickly run that, and we have our title over here. Now let's proceed with the next part. Now we will use some libraries like CatBoost and LightBGM. So for that we might have to install these libraries. So we will be using pip install here, pip install CatBoost, and control enter to run this particular code segment, or you can also use run, and it's installed. And after that we will also install LightBGM. Sorry, not BGM. So it's already installed. Now we will start importing the libraries that we need. So we will be needing NumPy, Pandas, Seaborn, matplotlib, and we will also import another special library which is for ignoring warnings. So we will import warnings, and after that we will be importing that warnings from IPython display import clear output, and after that we will tell the Jupyter notebook to import if there are any warnings. So that code will be warning.filter warnings, and in the brackets we will write ignore. So the basic libraries which we will be needing are as follows: import numpy as np. Let's quickly copy this and proceed, enter, and now we will be needing pandas as pd, enter, and now we will be needing cborn sns, and we will also use matplotlib.pyplot as plt, and after that we will import warnings from ipython.display import clear output warnings dot filter warnings ignore. Now we'll just quickly run this query, run, and now we will proceed with feature engineering. So you can use a hashtag to ignore that particular line from execution for Jupyter Notebook. And here we will be importing import re from sklearn.impute import simple imputer from sklearn.model selection import kfold. There you go. Now let's quickly run this query. There you go. Now we will proceed with modeling and model evaluation. Once we are done with this, then we will directly import the data into our notebook. So for modeling the data, we will again use a hash code so that this particular line will not execute, and import some libraries lit-gbm as lgb from lit-gbm library, import lgbm regressor from catboost, import catboost regressor. There you go. Let's quickly run this command. There you go. Now lastly, we have one more task before importing the data, that is model evaluation. Once that is done, we can proceed with importing the data. There you go. Let's quickly run it. And now, so far so good, we have done the basic library imports, and feature engineering is done, modeling is done, and model evaluation is also done. Now we can begin with importing the data. So let's also add the HTML code where we have done this importing. So here I will try to add another segment, and I will import the HTML code here which displays a similar HTML format which explains what exactly is happening here. Just a moment, I have the code ready. I'll just paste it here. There you go. Let's quickly run this so that we have a HTML code here, page here which explains what exactly is happening here. So we are importing libraries and also student data. Now let's import the student data. For that, let's write the query. So we are importing the data as data frame, and after that we will write pandas read csv, right? And here we will add the location of the file, right? So the file is located in my downloads section. So let's quickly copy that location and paste it here. So this is the location of my file. Let's quickly run it. So there might be some error. It's okay, we can resolve it. So in such scenarios, you don't have to worry. Either you can add an R, but even if that doesn't work, you might have to change. In this case, it worked, but in case if it doesn't work, what you can do is you can eliminate the R, and you can just change this from forward slash to backslash. This will also help. So this could be worth it. So this can also work. So these are the situations where you can use this. Now let's proceed with some more interesting facts. Let's try to understand what's going on with our data set, right? So what you can do is, now the data is stored in df variable as a data frame. So what you can do is read this particular data, df dot shape, so that you can understand what's happening with this data, right? So it can tell you that there are 6,607 rows and 20 columns. Now let's add another query part, and here you can try to see the head, right? What head means? Basically, head means the column headers. So what you can do is just write df dot head and run. Now you have the column headers and couple of sample columns, couple of sample rows. Now let's proceed with checking the duplicates and identifying the total number of duplicate entries in this particular data set. So you can write down df dot duplicated dot sum, and you will get the number of duplicates present in this particular file. So we have 0 duplicate entries. Now let's see if there are any null elements in this particular data frame. So df dot is null dot sum. So these are all functions. Control enter. There you go. So in the column teacher quality, there are 78 null entries, and in parental educational level there are 90 null entries, and distance from home there are 67 null entries. Now what we can do is from df shape we can add a new cell here, and we can write a HTML code so that the viewer can understand that we are trying to understand our data. So let's write a quick code for that. So let's not waste much time in just writing the HTML code. So I've got that HTML code written in a notepad already. So I'll just paste it over here, and let's quickly run it so that we have a HTML visibility here. So this was supposed to be the result, so we will add it here. So what we will do is quickly edit this particular content. We'll just quickly copy this code and paste it over here. Change the content from importing libraries to reading student data, and we will cut this code from here and we will paste it in here so that it will give us some information. Let's also run this particular code segment so that we have reading student data. There you go. Now the next part of this session will be about creating a target variable. So overall target of this particular data analysis is about exam score, right? So we can name our target variable as exam score, and let's understand the distribution of this particular exam score with the variables we have. Now let's write down plot dot figure. Figure size should be around 15,9 equals to, let's add a bracket here, 15,9, or let's keep it as 6. No, 9 would be a little bigger. Now enter. Now we'll use cbound library here, sns dot count plot x is equals to data frame cleaned target. Okay, before cleaned target we might have to run a few more. Okay, we did not perform data cleaning so far, right? So let's proceed with data cleaning so far. So we found some empty entries, right, null entries, and we also found some. So here we have 299 rows which have missing values, so we will have to remove that. For that we might have to create a new column which has to be named as not assigned, right? Df data frame not assigned. which is equals to df dot drop na. So we will be dropping the null values here. It's a function, and here let's print the values. Print df underscore na dot shape. So how many number of rows and columns we have, right? And after that, let's also try to eliminate the null values as well. Dot is null. So we don't have null values, but we have some illegal entries maybe. There you go. Now let's quickly run this query. So there you go. So the new data is about 678,20. So there is some, okay, we did some mistake here. So we are supposed to add it as null, null. Now quickly run this. So we should not get any errors this time. There you go, no errors. So far so good. Now let's describe the new data set. df na dot describe. So these are the new columns and the rows that we have, and we have mean, standard variation, standard deviation, minimum, maximum. So the scores are split into 25%, 50%, and 75%, which could be based on hours studied, which could be based on attendance, sleep hours, previous scores, tutoring sessions, everything. So minimum sleep hours, maximum sleep hours, 25% of that, 50% of that, 75% of that. So that is supposed to be the describe. Now what we will do is we have a target variable which is exam score, right? Now we will do some changes to it. We already know in an exam there will be a threshold value. It can be 25 marks per exam, it can be 50 marks per exam, and it can be 100 marks per exam, right? In our situation, let's consider the threshold value is 100 marks, right? If there is a situation where marks is entered in a wrong way, right? It can, if they wanted to add 11, but by mistake if they added another one, right, triple one, it's not a right entry, right? So we will try to eliminate those kind of data. So we will create a new data frame here, which is data frame cleaned is equals to data frame underscore not null. So we have eliminated the null values, df underscore na. Now we will add our target variable, which is exam score should be. So let's come out of this, and here we will add it as should be less than or equal to 100, but not more than 100. Let's use square brackets. Here we also, the format is square brackets actually. Now enter, and we will describe this particular data set. Instead of dfna, we will copy paste this here. Now let's run this. Okay, exam score is not identified. Let's quickly check the error and resolve it. Yeah, so we missed out to add colons here. It's okay, not a problem. So this was supposed to be how it is. Now let's run this, and we will have the answer over here. So we have the output. Now let's check the head of this particular cleaned data set. So we can make use of the same code here and paste it right here. And instead of describe, let's write head, so that we have the header of this particular data set. So we have our study and everything normal, and we will categorize the data, right? So we will make use of 3 columns: hours studied, attendance, and previous scores. And after that, we will also make use of other columns in this particular data set, which happens to be the parental involvement, access to resources, sleep hours, tutoring sessions, etc. And now our target will be the exam score that we created over here, right? This exam score will be our target. And using this particular exam score target, we will categorize the data, okay? We will categorize the data in terms of, let's say, first class, second class, and pass or something like that, right? So if a student is scoring below 64, and that is a separate category. If the student is scoring equals to or above 65, that is a different category. And if the student is scoring beyond 70, that's a different category. And before we proceed with that, let's try to add a HTML code before this particular data set, so that we have an understanding of what exactly happened here. So I'll just quickly copy paste this particular code here. So we will run it, and now next we will check the data type, column separate and everything, and we will create data type category variables. Right, and now so far so good. Now we will create the categories. So num call equals to hours studied, comma, attendance. So let's quickly add the data. Previous exam scores. Just a minute, let's quickly add the columns. Let me take a while. So there you go, I've added the columns. So we are considering 3 different columns. Hours studied, attendance and previous scores. For num call and for cat call, we are considering the other columns apart from the first 3, and our target value is exam score. Let's quickly run this. There you go. And now we will try to build some visualizations, and before that let's try to add some data from in HTML. Let's try to create a what we can do is simply copy this particular HTML file here. We can take this and add it here so that we will understand what exactly is happening next. And in place of reading student data, we will write data visualization for student data, and we will keep the colors same, dark blue background, and the color for data visualization will be light blue and student data will be orange. Let's quickly run, and there we have it. Now our target variable is exam score, right? Now we will compare this particular target variable with 3 other parameters. So our parameters will be the following, as we discussed, creating the segregation in dataset, right? So first will be distribution of target variable with other parameters. So we will create another HTML file for that right here. Just a minute while I paste the code for HTML. Quickly run this. There you go. So distribution of target variable exam score against some parameters. Now we will write the plot for that. Plot.figure. So we are going to consider the size equals to 15,6. Fig size is equals to 15,6, the same one that we considered before, and we will be using cbon SNS dot count plot, open bracket, this is a function, x is equals to df cleaned. Okay, what we can do is just quickly take the column name so that we don't create any mistakes here, and we will paste it over here instead of df. There you go, of target. So our target is exam score, comma, and we will use the palette as green, and the plot title will be distribution of target variable exam score. We can copy this. Okay, just a minute. Before that, plt dot title should be, let's use double quotes. Now copy this and paste it here. I think semicolons went off. Okay, not a problem. It's right here. Let's add a dot as a full stop, and the next line. If you need, you can add the full stop. If not, you can ignore. plt dot grid true, which equals to major, comma, axis is equals to y, comma, line style equals to. So I want lines to be hyphen hyphen. In this way I want the lines, and comma, line width, let's say 0.5 or 0.7. Let's go with 0.7. Line width equals to 0.9 mm. There you go. Now let's quickly run this query. There you go, done. And we have the first visualization. So here you can see there are some students which are scoring 58, 59, and you can see maximum number of students are already scoring good marks, which is under 65 and which is under 70 and above 65,
And there is a good number of students which are also scoring above 65 as well, right? So sorry, 70 as well. So we have now less than or equal to 70, 71, and highest scorer in some situations there is also 100. If you can see, there is slight growth here. There are a few students, toppers maybe, which have already scored 100 as well. Now we have the list here. Now what we need to do is we need to segregate. That is part 1, which is less than or equal to 64, which falls under 65, and another category which falls in between 65 to 70 and above 70. So we need to categorize these three datas and segregate them as bottom 65, top which is above 70, and mid between 70 to 65, right? Now before that, if you want to add an HTML document segment here which explains about the distribution of target, you can also do that. It's already added here. Now let's continue. But in case if you want to add some data which explains that we are trying to segregate, you can also do that. I would like to do that. Let's quickly add that HTML code here. So what this particular code will do is it will tell the percentage of students which are scoring less than 65, number of percentage of students scoring in between 65 and 70, and the percent of students which are scoring beyond 70. Right, let's run this, and here we have the result. Bottom 21.81% scores under 64, while 24% scores over 70, and 50% are in between 65 to 69. Right, now let's continue with the segregation part of the data. So for segregation, we will create three different variables, A, B, C. So first, A is equals to length of df cleaned. So let's copy the column name, data frame name, length of df cleaned. Inside the square brackets, we'll again add df cleaned of target variable, which is exam score. Let's also add single quotes here, who are scoring in between or less than. Let's start with less than or equal to 64. We'll not consider 65, we'll consider 64, divided by len of df cleaned target variable exam score, single quotes, into 100, which will give us the percentage. Now similarly, let's just copy and paste this 3 more times for B and C. So here, instead of minus, I was supposed to add equals to, and another one. So here equals to, and instead of A, I will write B, and the last one is C. And instead of 64, we will add 70 here for top, and here we will make some changes. It should be greater than or equal to 65. So this is the third category, A, B, C, and then we will proceed with printing the files. So print the bottom for the first one, which is f of A is to dot to f, and we will add the percentage symbol over here, r under 64. Now we can copy paste the same here, and we can change the variables. So here we will be adding under over 70, lastly in between, the ones in between 65 and 70. There you go. Here we will change the values from A to B, and here A to C. There you go, and we can quickly run this query. So it's not 70, it was supposed to be 69. There you go. So we forgot to mention this particular one. Now let's run this. There you go. So we have 21% of people who are scoring under 64, 24% over 70, and 53% are in between average. So I think the school is focusing on improving this particular percentage, reducing this particular percentage, and increasing this particular percentage, and try to eliminate, if possible, this particular one which are under 64. So that is the overall motto, I guess. Now, so far so good. Let's now try to remove infinite values from HTML.
Right, so before that, let's add this particular HTML code here, so which explains what we are trying to do. So we will first implement the code that prevents warning about infinite values during data visualization. And now let's add the code which will try to eliminate the infinite values. Let's copy this particular data frame cleaned data frame name here. Now df cleaned dot replace square brackets np dot info comma minus np dot info out of these square brackets dot np dot na non na values. We're trying to eliminate na values. In place of those values you can write true, and after that we will try to eliminate the null. So if it is null dot sum, give me the total number of null values after this, right? So let's try to execute that. There you go. So all the null entries have been removed here. Now let's see the distribution of numerical values here. So before that, let's add the HTML code for that. So let's quickly run this. So distribution of numerical values. So we will be considering these three parameters. So if you go back, here you can see hours studied, attendance and previous course. So we will be considering these three values or these three columns and check the distribution of these variables against the exam score. So is it making any kind of variation if the attendance is high? If the attendance is high, is the exam score high? And apart from that, we have if our studies is high, is the mark score is high, and if the previous scores are high, is there a chance to get better scores in this particular exam? So what we are trying to do is we are trying to see if there is any direct involvement of number of study hours and number of days attended and number of or the number of marks they received in their previous course, and we'll try to build a visualization on that front. So let's go and build that. So we'll try to write the code here. Figure axis equals to ELT dot subplots. So we will be having three different plots here since we're considering three different categories, and the fixed size should be equal to 12,4. There you go. Now access is equals to access dot rebel for idx comma call in enumerate call, and we will try to import the Seaborn library here. We will try to create histoplots here, histograms here, histoplot. So line style, we will be selecting this one, and comma line width will be 0.7. There you go. Next will be access idx dot set title. So for this we will be setting the title as distribution of columns. So the columns will be the three ones: attendance, hours studied, and what was the third one that we considered? Previous course, right? So instead of mentioning them specifically, what we can do is we can just write columns here, COL, and close. There you go. And lastly, plt.height, and show the plot. There you go. Let's quickly run this query. Run, and now we will be having the visualizations here. So you can directly see the involvement of these three parameters here if they are trying to help. If the number of hours are increased, then you can see if there is a better improvement in scores. If the attendance is increased, if there is a betterment in scores, or if the previous scores are helping, then you can find it out how it is. There you go. Now we can write a result here in the form of HTML page, and if we run this, it will give you the result. The breaks or gaps in the hours studied variable may be due to the respondents answering appropriately. The variables attendance and previous scores, which exhibit a uniform distribution, have a normal impact on exam scores variable, which is our target variable. Now, let's proceed with another part of this session, which will be about the relationship between the numerical values and the target variables. Now, we will copy paste the same code and make some minute changes to it. So the only change that we did to it is we're trying to build a scatter plot. So we will be getting a scatter plot here. But before that, let's try to add another column here and try to add an HTML code which explains why we are doing it. There you go. A scatter plot. So basically these two are one and the same. Here we use some column graphs. So here we did the same using the scatter plot, which will help for a better understanding. Now we will try to build some correlations. So basically, a list is called correlation is created containing the names of the columns for which you want to calculate the correlation. So here in our situation, it is the df.corr, which is a data frame, and it is created by selecting only these columns for df clean data frame, effectively created a new data frame containing only the specified columns. Now the second one, which is the corr, which is a calculate correlation. So this method computes the correlation matrix for selected columns, which is in df.corr. The 1 indicates perfect positive correlation, -1 indicates the perfect negative correlation, and 0 indicates no correlation. And lastly, the setup of plot. This line sets up the figure size of the plot. In this particular situation, we are choosing 5 and 4. Right, now let's quickly try to execute this query and see the answer. And we will also add the HTML code for this so that we have a better understanding for this. So we will be adding that HTML box here, which will explain what exactly happened here. So this is our plot and this is the correlation. Now let's try to add that HTML code right here. So the result of this particular data visualization will be maintained here. So the hours studied and attendance shows a positive correlation with the target variable, which is exams hour. However, previous course appears to have no or little relationship with the target variable. Right, now let's continue with our next part of this session. So now we will try to identify the relationship between studies, hours, and attendance and extracurricular scores. Right, so we have other columns to consider, which is extracurricular activities. So there is a belief that extracurricular activities will also help students to study better. So we will find if there is a relation between the target variable and these extracurricular activities, attendance and study hours. Now let's quickly add the code here. Now let's quickly execute the code. Now we have the visualization which explains the relationship between the number of hours studied, extracurricular activities, etc. So here it is. And now let's add an HTML code which explains about this result. I think this particular code was supposed to be added here. So this is the resultant column here. Now here it explains about the influences that it performs. So the extracurricular activities, parental income, and extra things that influence the scores. And there you go. Now let us also consider other columns, right? The other parameters like resources are available or not, parental education, and other things which also might have influenced the exam scores of students. So for that, let's add an HTML code so that we have an HTML page here which explains what is the next procedure that we are following, right? Now let's add the query here. So here we are considering the other parameters like family income, peer influence, motivation level, gender, parental involvement, parental educational level, and extracurricular activities, and we are considering them against the target variable, which is exam score. And now let's execute this query. There you go. Now we have generated a graph which explains about this particular parameters against the target variable. And now let's add the HTML page here which explains about these results. Let's quickly run it, and there you go. So when certain factors affect Q1 and Q2 but not Q2, it can be understood that individual has overcome challenges through personal effort, right? So if government policies and corporate social contributors are focused on addressing these aspects, it seems that we could create a dynamic country with greater social mobility and open opportunities for all, right? So if extracurricular activities can outweigh the influence of other variables in academic performance, then we should foster that kind of an environment, right? So this is how you can extract some statistical analysis on this particular data set. Now let's quickly rename this Python EDA students performance, and you can quickly rename and save it.
Hello and welcome to Data Analytics Interview Questions. My name is Richard Kirshner with the Simplilearn team. That's www.simplilearn.com. Get certified, get ahead. Today we're going to jump into some common questions you might see on NumPy arrays and Pandas data frames in the Python, along with some Excel, Tableau, and SQL. Let's start with our first question. What is the difference between data mining and data profiling? It's real important to note that data mining is a process of finding relevant information which has not been found before. It is a way in which raw data is turned into valuable information. You can think of this as anything from the sales stats and from their SQL server all the way to web scraping and Census Bureau information. Where the heck do you mine it from? Where do you get all this data and information? Then we look at data profiling. It is usually done to assess a data set for its uniqueness, consistency, and logic. It cannot identify incorrect or inaccurate data values. So if somebody has a statistical analysis on one side and they're doing you might the wrong data to then program your data setup. So you got to be aware that when you're talking about data mining, you need to look at the integrity of what you're bringing in, where it's coming from. Data profiling is looking at it and saying, hey, how is this going to work? What's the logic? What's the consistency? Is it related to what I'm working with? Define the term data wrangling and data analytics. Data wrangling is a process of cleaning, structuring, and enriching the raw data into a desired usable format for better decision making. And you can see a nice chart here with our discover it. We structure the data how we want it. We clean it up, get rid of all those null values. We enrich it, so we might take and reformat some of the settings. Instead of having 5 different terms for height of somebody, in American, English, or whatever, we clean some of that up, and we might do a calculation and bring some of them together. And validate. I was just talking about that in the last one. You need to validate your data. Make sure you have a solid data source. And then, of course, it goes into the analysis. Very important to notice here in data wrangling, 80% of data analytics is usually in this whole part of wrangling the data, getting it to fit correctly. And don't confuse that with data cooking, which is actually when you're going into neural networks, cooking the data so it's all between 0 and 1 values. What are common problems that data analysts encounter during analysis? Handling duplicate and missing values, collecting the meaningful right data the right time, making data secure and dealing with compliance issues, handling data purging and storage problems. Again, we're talking about data wrangling here. 80% of most jobs are in wrangling that data and getting it in the right format and making sure it's good data to use. Number 4, what are the various steps involved in any analytics project? Understand the problem. We might spend 80% doing wrangling, but you better be ready to understand the problem, because if you can't, you're going to spend all your time in the wrong direction. This is probably the most important part of the process. Everything after it falls in, and then you can come back to it. 2, data collection, data cleaning. Number 3, 4, data exploration analysis, and 5, interpret the results. Number 5 is a close second for being the most important. If you can't interpret what you bring to the table to your clients, you're in trouble. So when this question comes up, you probably want to focus on those 2, noting that the rest of it 80% of the work is in 2, 3, and 4, while 1 and 5 are the most important parts. Which technical tools have you used for analysis and presentation purposes? Being a data analyst, you are expected to have knowledge of the below tools for analysis and presentation purposes. There's a wide variety out there. SQL Server, MySQL, you have your Excel, your SPSS, which is the IBM platform, Tableau, Python. You have all these different tools in here. Now, certainly a lot of jobs are going to be narrowed in on just a few of these tools. Like you're not going to have a Microsoft SQL Server and MySQL Server, but you better understand how to do basic SQL polls, and also understanding Excel and how the different formats for column and how to get those set up. Number 6, what are the best practices for data cleaning? This is really important to remember to go through this in detail. These always come up because 80% of most data analysis is in cleaning the data. Make a data cleaning plan by understanding where the common errors take place and keep communications open. Identify and remove duplicates before working with the data. This will lead to an effective data analysis process. Focus on the accuracy of the data, maintain the value types of data, provide mandatory constraints, and set cross-field validation. Standardize the data at the point of entry so that it is less chaotic, and you will be able to ensure that all the information is standardized, leading to fewer errors on entry. Number 7, how can you handle missing values in a data set? List-wise deletion. In list-wise deletion method, entire record is excluded from analysis if any single value is missing. Sometimes we're talking about records. Remember, this could be a single line in a database. So if you have your SQL comes back and you have 15 different columns, every one of those that has a missing value, you might just drop it just to make it easy because you already have enough data to do the processing. Average imputation. Use the average value of the responses from the other participants to fill in the missing value. This is really useful, and they'll ask you why these are useful, I guarantee it. If you have a whole group of data that's collected and it doesn't have that information in it, at that point you might average it in there. Regression substitution. You can use multiple regression analysis to estimate a missing value. That kind of goes with the average imputation input. Regression model means you're just going to actually generate a prediction as to what you think that value should be for those people based on the ones you do have. Multiple imputation. So when we talk about multiple inputs, it creates plausible values based on the correlations for the missing data, and then average the simulated data sets by incorporating random errors in your predictions. What do you understand by the term normal distribution? And the second you hear the word normal distribution, should be thinking a bell curve like we see here. Normal distribution is a type of continuous probability distribution that is symmetric about the mean, and in the graph, normal distribution will appear as a bell curve. The mean, median, and mode are equal. That's a quick way to know if you have normal distribution, is you can compute mean, median, and mode. All of them are located at the center of the distribution. 68% of the data lies within one standard deviation of the mean. 95% of the data falls within 2 standard deviations of the mean. 99.7% of the data lies within 3 standard deviations of the mean. What is time series analysis? Time series analysis is a statistical method that deals with ordered sequence of values of a variable of equally spaced time intervals. Time series data on a COVID-19 cases. And you can see we're looking at by days, so our space is of days, and each day goes by. If we take and graph it, you can see a time series graph always looks really nice if you have like 2 different, in this case we have the United States going over there. I'd have to look at the other setup in there, but they picked a couple different countries. And it's time sensitive. The next result is based on what the last one was. COVID is an excellent example of this. Anytime you do any word analytics where you're figuring out what someone's saying, what they said before makes a huge difference as to what they're going to say next. Another form of time series analysis. 10. How is joining different from blending in Tableau? So now we're going to jump into the Tableau package. Data joining. Data joining can only be done when the data comes from the same source. Combining 2 tables from the same database or 2 or more worksheets from the same Excel file. All the combined tables or sheets contains common set of dimensions and measures. Data blending. Data blending is used when the data is from 2 or more different sources, combining the Oracle table with the SQL server, or 2 sheets from Excel, or combining Excel sheet and Oracle table. In data blending, each data source contains its own set of dimensions and measures. How is overfitting different from underfitting? Always a good one. Overfitting. Probably the biggest danger in data analytics today is overfitting. Model trains from the data too well using the training set. The performance drops significantly over the test set. Happens when the model learns the noise and random fluctuations in the training data set in detail. And again, the performance drops way below what the test set has. The model neither trains the data well nor can generalize to new data. Performs poorly both on train and the test set. Happens when there is less data to build and an accurate model, and also when we try to build a linear model with a nonlinear data. In Microsoft Excel, a numeric value can be treated as a text value if it precedes with an apostrophe. Definitely not an exclamation. If you're used to programming in Python, you'll look for that hash code, and not an amber sign. And we can see here, if you enter the value 10 into a field, but you put the apostrophe in front of it, it will read that as a text, not as a number. What is the difference between count, count A, count blank, and count if in Excel? We can see here when we run in just count, D1 through D23, we get 19. And you'll notice that there is 19 numbers coming down here. And so it doesn't count the cost of each, which is the top bracket, and it doesn't count the blank spaces either with the straight count. When you do a count A, you'll get the answer is 20. So now when you do count A, it counts all of them, even the title cost of each. When you do count blank, we'll get 3. Why? There's 3 blank fields. And finally, the count if. If we do count if of E1 to E23 is greater than 10, there's 11 values in there. Basic counting of whatever's in your column, pretty solid on the table there. Explain how VLOOKUP works in Excel. VLOOKUP is used when you need to find things in a table or arrange by row. The syntax has 4 different parts to it. We have our lookup value, that's a value you want to look up. We have our table array, the range where the lookup value is located, column index number, the column number and range that contains the return value, and the range lookup. Specify true if you want an approximate match or false if you want an exact match of the return value. So here we see VLOOKUP F3 A2 to C8 2, 0 for prints. Now they don't show the F3. F3 is the actual cell that prints is in. That's what we're looking at is F3. So there's your prints. He pulls in from F3. A2 to C8 is the data we're looking into. And then number 2 is a column in that data. So in this case, we're looking for age. And we count name as 1, age as 2. Keep in mind this is Excel versus a lot of your Python and programming languages where you start at 0. In Excel, we always look at the cells as 1, 2, 3. So 2 represents the age. 0 is false for having an exact matchup versus 1. We don't actually need to worry about that too much in this. 0 or 1 would work with this example. And you can see with the Angela lookup, again, her name would be in the F column number 4. That's what the F4 stands for, is where they pulled Angela from. And then you have A1 to C8, and then we're looking at number 3. So number 3 is height, name being 1, age 2, and then height 3. And you'll see here it pulls in her height 5.8. So we're going to jump over to SQL. How do you subset or filter data in SQL? To subset or filter data in SQL, we use where and having clause. And you can see we have a nice table on the left where we have the title, the director, the year, the duration. We want to filter the table for movies that were directed by Brad Bird. Why? Just because we want to know what Brad Bird did. So we're going to do select star. You should know that the star refers to all. In this case, what are we going to return? We're going to return all, title, directory, year, and duration. That's what we mean by all. From movies, movies being our table, where director equals Brad Bird. And you can see he comes back and he did The Incredible and Ratatouille. To subset or filter data SQL, we can also use the where and having clause. So we're going to take a closer look at the different ways we can filter it here. Filter the table for directors whose movies have an average duration greater than 115 minutes. So there's a lot of really cool things into this SQL query, and these SQL queries can get pretty crazy. Select director sum duration as total duration, average duration as average duration from movies, group by director having average duration greater than 115. So again, what are we going to return? We're going to return whatever we put in our select, which in this case is director. We're going to have total duration, and that's going to be the sum of the duration. We're going to have the average duration, average underscore duration, which is going to be the average duration on there. And then we, of course, go ahead and group by director. And we want to make sure we group them by anyone that has having an average duration greater than 115. These SQL queries are so important. I don't know how many times the SQL comes up, and there's so many different other languages, not just MySQL and not Microsoft SQL, but in addition to that, where the SQL language comes in, especially with Hadoop and other areas. So you really should know your basic SQL. Doesn't hurt to get that little cheat sheet and glance over it and double check some of the different features in SQL. What is the difference between where and having clause in SQL? Where clause works on row data. In where clause, the filter occurs before any groupings are made. Aggregate functions cannot be used. So the syntax is select your columns from table where what the condition is. Having clause works on aggregated data. Having is used to filter values from a group. Aggregate functions can be used. And the syntax is select column names from table where the condition is, grouped by, having a condition ordered by column names. What is the correct syntax for reshape function in NumPy? So we're going to jump to the NumPy array program. And what you come up with is you have, in this case, it'd be numpy.reshape. A lot of times you do an import numpy as np, reshape, and then your array, and the new shape. And you can see here as the actual example comes in, the reshape is A, and we're going to reshape it in 2,5 setups. And you can see the printout in there that prints in 2 rows with 5 values in each one. What are the different ways to create a data frame in Pandas? Well, we can do it by initializing a list. So you can import your pandas as PD, very common. Data equals Tom 30, Jerry 20, Angela 35. We'll go ahead and create the data frame, and we'll say pd.dataframe is the data, columns equals name and age. So you can designate your columns. You can also designate index in there. You should always remember that the index, in this case, maybe you want the index instead of 1, 2 to be the date they signed up, or who knows, whatever. And you can see right there, it just generates a nice pandas data frame with Tom, Jerry, and Angela. Another way you can initialize a data frame is from dictionary. You can see here we have a dictionary where the date equals name, Tom, Jerry, Angela, Mary. Age is 20, 21, 19, 18. And if we do a df pd.dataframe on the data, you'll get the same kind of setup. You get your name, age, Tom, Jerry, Angela, and Mary. Write the Python code to create an employee's data frame from the emp.csv file and display the head and summary of it. To create a data frame in Python, you need to import the pandas library and use the read CSV function to load the CSV file. And here you can see we have import pandas as PD, employees, or the data frame employees, equals pd.readcsv, and then you have your path to that CSV file. There's a number of settings in the read CSV where you can tell it how many rows are the top index. You can set the columns in there. You can have skip rows. There's all kinds of things. You can also go in there and double check with your read CSV. But the most basic one is just to read a basic CSV. How will you select the department and age columns from an employee's data frame? So we have import pandas as PD. You can see we have created our data. We will go ahead and create our employees PD data frame on the left. And then on the right, to select department and age from the data frame, we just do employees, and you put the brackets around it. Now, if you're just doing one column, you could do just department. But if you're doing multiple columns, you got to have those in a second set of brackets. So it's got to be a reference with a list within the reference. What is the criteria to say whether a developed data model is good or not? A good model should be intuitive, insightful, and self-explanatory. Follow the old saying, KISS, keep it simple. The model developed should be able to easily consumed by the clients for actionable and profitable results. So if they can't read it, what good is it? A good model should easily adapt to changes according to business requirements. We live in quite a dynamic world nowadays, so that's pretty self-evident. And if the data gets updated, the model should be able to scale accordingly to the new data. So you have a nice data pipeline going where when you get new data coming in, you don't have to go and rewrite the whole code. What is the significance of exploratory data analysis? Exploratory data analysis is an important step in any data analysis process. Exploratory data analysis, EDA, helps to understand the data better. It helps you obtain confidence in your data to a point where you're ready to engage a machine learning algorithm. It allows you to refine your selection of feature variables that will be used later for model building. You can discover hidden trends and insights from the data. How do you treat outliers in a data set? An outlier is a data point that is distant from other similar points. They may be due to variability in the measurement or may indicate experimental errors. One, you can drop the outlier records. Pretty straightforward. You can cap your outliers data so it doesn't go past a certain value. You can assign it a new value. You can also try a new transformation to see if those outliers come in if you transform it slightly differently. Explain descriptive, predictive, and prescriptive analytics. Descriptive provides insights into the past to answer what has happened. Uses data aggregation and data mining techniques. Examples: an ice cream company can analyze how much ice cream was sold, which flavors were sold, and whether more or less ice cream was sold than before. Predictive understands the future to the answer, what could happen. Uses statistical models and forecasting techniques. Example: predicts the sale of ice creams during the summer, spring, and rainy days. So this is always interesting because you have your descriptive, which comes in, and your businesses are always looking to know what happened. Hey, did we have good sales last quarter? What are we expecting next quarter in sales? And we have a huge jump when we do prescriptive. Suggest various courses of action to answer what should you do. Uses optimization and simulation algorithms to advise possible outcomes. Example: lower prices to increase sale of ice creams, produce more or less quantities of certain flavor of ice cream. And we can certainly, today's world with the COVID virus, because we had that on our earlier graph, you could see that as a descriptive. What's happened? How many people have been infected? How many people have died in an area? Predictive. Where do we predict that to go? Do we see it going to get worse? Is it going to get better? What do we predict that we're going to need in hospital beds? And prescriptive. What can we change in our setup to have a better outcome? Maybe if we did more social distancing, if we tracked the virus. How do these different things directly affect the end, and can we create a better ending by changing some underlying criteria? What are the different types of sampling techniques used by data analysts? Sampling is a statistical method to select a subset of data from an entire data set. Population, to estimate the characteristics of the whole population. One, we can do a simple random sampling, so we can just pick out 500 random people in the United States to sample them. We call it a population. In regular data, we also call that a population, just because that's where it came from, was mainly from doing census. Systematic sampling, cluster sampling, stratified sampling, and judgment or purposive sampling. Then we have our systematic sampling. That's where you're doing like using 1, 5, 10, 15, 20. Use a very systematic approach for pulling samples from the setup. Cluster sampling. That's where we look at it and we say, hey, some of these things just naturally group together. If you were talking about population, which is really a nice way of looking at this, cluster sampling would be maybe by zip code. We're going to do everybody's zip code and just naturally cluster it that way. Stratified sampling would be more looking for shared things a group has, like income. So if you're studying something on poverty, you might look at their naturally group people based on income to begin with, and then study those individuals in the income to find out what kind of traits they have. And then judgmental. That is where the researcher very carefully selects each member of their own group. So it's very much based on their personal knowledge. Jumping on to 26, what are the different types of hypothesis testing? Hypothesis testing is a procedure used by statisticians and scientists to accept or reject statistical hypothesis. We start with the hypothesis testing. We have null hypothesis and alternative hypothesis. On the null hypothesis, it states that there is no relation between the predictor and the outcome variables in the population. It is denoted by H0. Example, there is no association between patients, BMI, and diabetes. Alternative hypothesis, it states there is some relation between the predictor and outcome variables in the population. It is denoted by H1. Example, there could be an association between patients' BMI and diabetes. And that's the body mass index, if you didn't catch the BMI and you're not in medical. Describe univariate, bivariate, and multivariate analysis. A univariate analysis, it is the simplest form of data analysis where the data being analyzed contains only one variable. An example is studying the heights of players in the NBA. Because it's so simple, it can be described using central tendencies, dispersion, quartiles, bar charts, histograms, pie charts, frequency distribution tables. The bivariate analysis, it involves analysis of two variables to find causes, relationships, and correlations between the variables. Example, analyzing sale of ice creams based on the temperature outside. Bivariate analysis can be explained using correlation coefficients, linear regression, logistic regression, scatter plots, and box plots. And multivariate analysis, it involves analysis of three or more variables to understand the relationship of each variable with the other variables. Example, analyzing revenue based on expenditure. So if we have our TV ads, we have our newspaper ads, our social media ads, and our revenue, we can now compare all those together. The multivariate analysis can be performed using multiple regression, factor analysis, classification and regression trees, cluster analysis, principal component analysis, clustering bar chart, dual axis chart. What function would you use to get the current date and time in Excel? In Excel, you can use the today and now function to get the current date and time. And you can see down here with the two examples where just equals today or equals now. Using the SUMIFS function in Excel, find the total quantity sold by sales representatives whose names start with A and the cost of each item they have sold is greater than 10. And you can see here on the left we have our actual table, and then we want to go ahead and SUMIFS. So we want the E2 through E20, B2 through B20 greater than 10. And this basically is just saying, hey, we're going to take everything in the E column and we're going to sum it up, but only those objects where the D column is greater than 10. That's what that means there. Is the below query correct? If not, how will you rectify it? Select customer ID, year, order date as order year from order where order year is greater than or equal to 2016. And hopefully you caught it right there. It's in the devil's in the details. We can't not use the alias name while filtering data using the where clause. So the correct format is all the same except for where it says where the year order date is greater than or equal to 16 versus using the order year, which we assign under the select setup. How are union, intersect, and except used in SQL? The union operator is used to combine the results of two or more select statements. And you can see here we have select star from region 1. We're going to make a union with select star from region 2. And it basically takes both these SQL tables and combines them to form a full new table on there. So that's your union as we bring everything together. When we look at the intersect operator, returns the common records that are the result of the two or more select statements. So you can see here we select star from region 1, intersect, select star from region 2, and we come up with only those records that are shared, that have the same data in them. And hopefully you jumped ahead to the except. The except operator returns the uncommon records that are the result of two or more select statements. So these are the two records, or the records that are not shared between the two databases. Using the product price table, write an SQL query to find the record with the fourth highest market price. So here we have a little bit of a brain teaser. They're always fun. And the first thing we want to do is we're going to go ahead and if you look at the script on the left, we really want the fourth one down. So we're going to select the top 4 from product price. But we're going to order it by market price descending. SP order by market price ascending. So what we do is we take the top 4 of the market price ascending, and that's going to give us the 4 greatest values. And then we're going to reverse that order and do descending. And we're going to take the top one of that, which is going to give us the lowest value, which will be the 4th greatest one in the list. From the product price table, find the total and average market price for each currency where the average market price is greater than 100 and currency is in the INR or the AUD. So INR or AUD, India Rupee or Australia dollar. You can see over here the SQL query. If you had trouble putting this together, you might actually do some of it in reverse. And you can see right here where the average market price is greater than 50. Remember, we use having, not where, at the end because it's part of the group. So group by currency, because we want those two currencies. And we want the currency India Rupee, the INR or the AUD. And as you keep going backwards, we're actually going to be selecting the currency, the sum of the market price as total price, and the average market price as average price. So there's our select. It's going to come from the product price, which is just our table over there, and then we have where our currency is in. And like I said, you can put it together however you want, but hopefully you got to the end there. So this question will test your knowledge in Tableau, exploring the different features of Tableau, and creating a suitable graph to solve a business problem. And of course, Tableau is very visual in its use, so it's very hard to test it without actually just getting your hands on. And if you can't visualize some of this and how to do it, then you should go back and refresh yourself. Using the sample superstore dataset, create a view to analyze the sales, profits, and quantities sold across different subcategories of items present under each category. So the first step is to go ahead and load the sample superstore dataset. So make sure you know how to load the sample, the superstore dataset. That's underneath either the connect button in the upper left or the Tableau icon up there, and be able to pull in the data set. And then once you've done that, you just drag the category and subcategory on rows and salaries onto columns. It will result in a horizontal bar chart. So in this one, we're just going to drag profit onto color and quantity onto label. Sort the sales axes in descending order of sum and sales within each subcategory. And if you're at home doing this, you'll see that chairs under furniture category had the highest sales and profit, while tables had the lowest profit. For office supplies, subcategory binders made the highest profit, even though storage had the highest sales. Under technology category, copiers made the highest profit, though it was the least amount of sales. Let's work to create a dual axis chart in Tableau to present sales and profits across different years using sample Superstore dataset. Load the orders sheet from the sample Superstore dataset. Drag the order data field from the dimensions onto columns and convert it into continuous month. Drag cells onto rows and profits to the right corner of the view until you see a light green rectangle. One of those things, if you haven't done this hands-on, you don't know what you're doing, you're going to run into a bind because you're going to be just kind of dropping it and wondering what happened. Synchronize the right axes by right-clicking on the profit axis. And then let's finalize it by going under the marks card, change some cells to bar and some profit to line, and adjust the size. And then we have a nice display that we can either print out or save and send off to the shareholders. Let's go ahead and do one more Tableau. Design a view in Tableau to show state-wise sales and profits using the sample Superstore dataset. In here you go ahead and drag the country field onto the view section and expand it to see the states. Drag the states field onto size and profit onto color. Increase the size of the bubbles, add a border and a halo color. States like Washington, California, and New York have the highest sales and profits, while Texas, Pennsylvania, and Ohio have a good amount of sales but the least amount of profits. We'll go ahead and skip back to Python NumPy. Suppose there is an array number equals NP, or NumPy if you're using NumPy, depending on how you set it up, dot array, and we just have 1 to 9 broken up into 3 groups. Extract the value 8 using 2D indexing. So you can see on the left we have our import NumPy as NP, number equals our NP array. If we print the number, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the value 8 is present in the second row and first column, we use the same index position and pass it to the array. And you just have number 2, 1, and you get 8. And remember, we're in Python, so you start at 0, not 1 like you do in Excel. Always gets me if I'm working between Excel and Python, where I just kind of flip, and usually it's the Excel that messes up because I do a lot more programming. Suppose there's an array that has values 0, 1, all the way up to 9. How will you display the following values from the array? 1, 3, 5, 7, 9. So first of all, we go ahead and create the array, np.arange of 10, which goes from 0 to 9, because there's 10 numbers in it, but we don't include the 10. We print it out. The first thing you want to do is, what's going on here with 1, 3, 5, 7, 9? Well, if we divide by 2, there's going to be a remainder equal to 1. And then from Python, remember that if you use the percentage sign, you get the remainder on there. So the remainder is 1. And then you have your NumPy array, and then we just want to do a logical statement of all values that have a remainder of 1, and that generates our nice 1, 3, 5, 7, 9. There are 2 arrays, A and B. Stack the arrays A and B horizontally. Boy, these horizontal vertical questions will get you every time. And in NumPy, we go ahead and we've created 2 different arrays over here, A and B. The first one is your concatenate, np.concatenate A and B on axes equal 1. That is the same as hstack. And in the back end, they're still identical. They run the same. That's all hstack is, a concatenate axes equals 1. How can you add a column to a pandas data frame? Suppose there's an imp data frame that has information about few employees. Let's add address column to that data frame. And you can see on the left we have our basic data frame. You should know your data frames very well. Basically it looks like an Excel spreadsheet. As you come over here, it's really simple. You just do df of address equals the address once you've assigned values to the address. Using the below given data, create a pivot table to find the total cells made by each cells represented for each item. Display the cells as a percentage of the grand total. So we're back in Tableau. Select the entire table range, click on Insert tab, and choose Pivot Table. Select the table range and the worksheet where you want to place the pivot table. It will return a pivot table where you can analyze your data. Drag the cell total on the values in sales rep and item onto row labels. It will give the sum of the sales made by each representative for each item they have sold. And finally, right-click on Sum of Cell Total and expand Show Values as to select percentage of grand total. Real important just to understand what a pivot table is. We're just pivoting it from rows and columns and switching this direction on there. And finally, we have our final pivot table, and you can see the values, roles, and sum of total sale. So we're going to go ahead and take a product table. This is off of an SQL, so we're going to do some SQL here. And we're going to use the product and sales order detail table, find the products that have total units sold greater than 1.5 million. And here's our sales order detail table. So we have a product table and a sales order detail table, two separate tables in the database. And what we're going to do is put together the SQL query. We want to select PP name, sum, SOD, unit price as sales. And then we have our pp.product ID from production product as pp inner join, sales.sales order detail as SOD on pp product ID equals SOD.product ID, group by pp.name, pp.product ID having a sum of SOD.unit price greater than the 150 million there. That's a mouthful. And again, these SQL queries, they start looking really crazy until you just break them apart and do them step by step. And what we're looking for is the inner join and how did you do the group by. That's really what they know. How do you do this inner join? This comes up so much in SQL. How do you pull in the ID from one chart and the information from another chart and the sum totals on that chart? How do you write a stored procedure in SQL? Let's create a stored procedure to find the sum, the squares of the first n natural numbers. So here we have our formula, n times n plus 1 times 2n plus 1 over 6. And you can see from the command prompt or the setup you have, depending on what your login is, the command is create procedure square sum 1. Declare our variable at n of integer as begin. And then we're going to declare the sum of integer. Set sum equals n times n plus 1 plus 2 times n plus 1 over 6. And then, of course, we can go ahead and print those out. Print first cast ampersand n, or our variable, as a variable character 20 natural numbers. Print the sum of the square is cast the at sum as variable character 40 end. And then we do the output, display the sum of the square for first 4 natural numbers. We have execute square sum 1, and then we're going to put in 4, and you can see here where it brings up the first 4 natural numbers. Sum of square is 30. Write a store procedure to find the total even number between two user-given numbers. A couple of things to note here. First, we go ahead and create our procedure. You have your two different variables, the n1, n2. And we go ahead and begin. We're going to declare our variable count as an integer. We're going to set count equal to 0. And then we have while n is less than n2. We're going to begin. And if n1 remainder 2 equals 0, so we're going to divide it by 2, even number, begin. We're going to set the count equal to count plus 1. We're going to print even number plus cast n as a variable character 10 for printing. Count is plus cast variable count as variable character 10 end. Else print odd number plus cast variable number 1 as variable character 10. And then we go ahead and set the increment our variable 1 up 1. So it'll go from n1 all the way to n2. And it'll print the total number of even numbers. And you can see here we went ahead and executed it. We're going to count the even numbers between 30 and 45. And you can just see it goes all the way down to 8. What is the difference between tree maps and heat maps in Tableau? Now, if you've worked in Python and other programmings, you should automatically know what a heat map is. But a tree map are used to display data in nested rectangles. You use dimensions to define the structure of the tree map and measure to define the size or color of individual rectangles. Tree maps are a relatively simple data visualization that can provide insight in a visually attractive format. And again, you can see the squares over here. This is our tree map over here with each block also has its information inside of its different blocks. A heat map helps to visualize measures against the dimensions with the help of colors and size to compare one or more dimensions and up to 2 measures. The layout is similar to a text table with variations in values encoded as colors. In heat map, you can quickly see a wide array of information. And in this one, you can see they use the colors to denote one thing and the size of the little square to denote something else. A lot of times you can even graph this into a 3-dimensional graph with other data so it pops out. But again, a heat map is the color and the size. Using the sample superstore dataset, display the top 5 and bottom 5 customers based on their profit. So you start by dragging the customer name field onto rows and profit on columns. Right-click on the customer name column to create a set. Give a name to the set and select Top tab to choose top 5 customers by sum profit. Similarly, create a set for the bottom 5 customers by sum profit. Select both the sets, right-click to create a combined set. Give a name to the set and choose all members in both sets. And then you can drag top and bottom customer sets onto the filters and profit field onto color to get the desired results. As we get down to the end of our list, we're going to try to keep you on your toes. We're going to skip back to NumPy. How to print 4 random integers between 1 and 15 using NumPy. To generate random numbers using NumPy, we use the random integer function. And you can see here we did the import NumPy as np random arrangement equals np.random integer 1 through 15 of 4. From the below data frame, going to jump again on you, now we're into pandas. How will you find the unique values for each column and subset the data for age less than 35 and height greater than 6? To find the unique values and the number of unique elements, use the unique and the InUnique function. You can see here we just did df height, so we're selecting just the height column, and we want to look for the unique. That returns an array, where InUnique, if we do that on the height or the age, will return just the number of unique values. And then we can do a subset the data for ages less than 35 and height greater than 6. So if we look over here, we have a new df. Remember, this is going to be taking slices of our original data frame. It doesn't actually change the data frame. So our new df equals the data frame, or df, the data frame where age is less than 35 and the height is greater than 6. And in case you're not using Tableau, which has a lot of its own different mapping programs in there, make sure you understand how to use the basics of Matplot library. Plot a sine graph using NumPy and Matplot library in Python. And the way we did this is we went ahead and generated an x. We know our y equals np.sine of x. If you print out x, you'll see a whole value here. Our Matplot library PyPlot as PLT. If you are working in Jupyter Notebook, make sure you understand the Matplot library inline, that little percentage sign Matplot library inline. That prints it on the page in the Jupyter Notebook. The newer version of Jupyter Notebook or Jupyter Labs automatically does that for you, but I usually put it in there just in case I end up on an older version. If you print y, you can see here we have our different y values and our different x values. You simply put in plt.plot xy and do a plot show. And before we go, let's get one more in. We're going to do a pandas using the below pandas data frame. Find the company with the highest average sales, derive the summary statistics for this sales column, and transpose these statistics. That's a mouthful, and just like any of these computer problems, break it apart. So first of all, we're looking for the highest average sales. So group the company column and use the mean function to find the average sales. And you can see here by company equals df.groupBy company. Once we've done that, using the describe function, we can now go ahead and look at the summary of statistics on here. Use the describe function to find the summary. So by company, those are groups. We're just going to describe them. And you could actually bundle those together if you wanted and just do them all in one line. So here we go, by company.describe. You can see we have a nice breakout, always good to remember. Whether you're using any of the packages, whether it's Tableau or Pandas in Python, or even R or some other package, being able to quick look and describe your data is very important. And then we can go ahead and just do a basic apply a transpose function over the describe method to transpose the statistics. All we've done here is flip the index with the column names, but if you're following the numbers, a lot of times it's easier to follow across one line, or maybe you want to average out the count, or there's all kinds of different reasons to do that.
Thank you for joining our full course on Excel by Simplilearn. Don't forget to subscribe to our channel for more expert-led courses and tutorials. If you have any questions or need further assistance, feel free to reach in the comment section below. Thank you for watching.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.